had a lecture given by Professor Madhav number of times, and very recently on Engineers Day, Sir has come to our campus and delivered a talk. Right, so it is always a pleasure to listen to such legends. Right, so he is one of the greatest geotechnical engineering professor. He is known worldwide. So today, years work was contributed by him will be released immediately after the lecture. So Andhra University is proud to have that inauguration of book here, because he is proud alumnus of the department. He is first batch student of JE College. So what else inspiration civil engineering need? So just during your laser time, just like you will see what are its contributions, achievements. Right? So anyway, today also we will start our day with a prayer. We have Dr. Lakshayani from philosophy department. So
जिह्वा मे मधुमत्तमा कर्णाभ्यां भूरि विश्रुवं ब्रह्मणः कोशोऽसि मेधया पिहितः श्रुतं मे गोपाय ॐ मेधा देवी जुषमाना नागात् विश्वाची भद्रा सुमनस्य माना त्वया जुष्टानुगमाना दुरुक्तान् बृहद्वदेम विदधे सुवीराः त्वया जुष्टऋषिर्भवति देवि त्वया ब्रह्मागत श्रीरुतत्वया त्वया जुष्टश्चित्रं विन्दते वसुसानो जुषस्वद्रविणो न मेधे मेधां म इन्द्रो दधातु मेधां देवी सरस्वती मेधां मे अश्विना उभावा दत्तां पुष्करस्रजाम् अप्सरासु च या मेधा गन्धर्वेषु च यन्मनः दैवी मेधा सरस्वती सा मां मेधा सुरभिर्जुषतात् स्वाहा आमां मेधा सुरभिर्विश्वरूपा हिरण्यवर्णा जगति जगम्या ऊर्जस्वती पयसा पिन्वमाना सा मां मेधा सुप्रतीका जुषन्तां मयि मेधां मयि प्रजां मयि अग्निस्तेजो दधातु मयि मेधां मयि प्रजां मयि इन्द्र इन्द्रियं दधातु मयि मेधां मयि प्रजां मयि सूर्यो भ्राजो दधातु ॐ हंस हंसाय विद्महे परमहंसाय धीमहि तन्नो हंसः प्रचोदयात् ॐ शान्ति शान्ति शान्तिः।
thank you, madam, for gracing the session. She happens to be the friend of the other speaker of the day, Professor Madhavi Lata. Give a brief introduction of
Professor M.R. Madhav, Institute Fellow, IIT Kanpur, AICTE, INAE, Distinguished Visiting Professor, Mentoring VNR, VJIT and College of Engineering, Andhra University, Visiting Professor, IIT Hyderabad, JNTU Hyderabad, Resource Person, Rajiv Gandhi University of Knowledge Technology, Guest Faculty, Engineering Staff College, formerly Chairman, Research Council, CSIR, CRRI and Governing Council, JNT University Kakinada, Advisor Consultant to Strata Geosystems, KSK, Halpro, Energy Infratech, retired as Professor of Civil Engineering, IIT Kanpur. He graduated in Civil Engineering from Andhra University in 1960, obtained the Master of Engineering and the Doctorate of Philosophy degrees from the Indian Institute of Sciences, Bangalore in the year 1961 and 1967 respectively. Professor Madhav sir worked at several universities abroad, Australia, Canada, Japan, Belgium, UK, etc. Professor Madhav's research interests span the whole gamut of geotechnical engineering. He guided nearly 50 doctoral and several master theses and final year projects. He co-edited books entitled Lowlands, Development and Management and Foundations and Soft Ground Engineering Challenges in Mekong Delta and authored more than 550 publications and referred international and national journals and conferences. Professor Madhav sir is a fellow of the Indian National Academy of Engineering, the Indian Geotechnical Society, the Institution of Engineers, etc. and was awarded the Kugelman Award of the AGS and the Professor Mehra Research Award of the University of Roorkee, Pandit Jawaharlal Nehru Birth Centenary Research Award of CBIP, the Doctor of Science degree of the Indian Institute of Science, the Bharat Ratna M. Vishwesvaraya Award, the Gopal Ranjan Research Award of IIT Roorkee, IGS, MS Jain Award, the Distinguished Teacher Award of IIT Kanpur, the Vishwakarma Award for Academic Excellence from CIDC, Professor Dinesh Mohan Award for Excellence in Geotechnical Engineering Practice, the IGS AIMIL Innovation in Design Award, the Outstanding Researcher Award from IAC MAG, the Distinguished Alumnus Award of the Indian Institute of Science, Bangalore, etc. He was the President of IGS, Vice President of Asia of ISSM and GE, and President of the International Association of Lowland Technology. He delivered a keynote lecture at Asian Regional Conference at Singapore, the first Mura lecture in 2008, IGS Ferroco Terzaghi Oration in 2010, and the first Victor D. Mello Goa lecture in 2017. Keynote lecture, Geotechnics of Soft Ground at Geotech Conference 2017, Guwahati. The first Professor Sri Ramarao lecture at Guntur and another keynote lecture for TC 207 of IISMGA at Bangalore. He received the Reviewer of the Year Award for the years 2016 and 2017 from Springer and IGS. He was awarded the Institute Fellow of IIT Kanpur in 2019. He was awarded the Outstanding Reviewer Award by the American Society of Civil Engineers in 2020. Professor Madhav sir was conferred Legend in Geotechnical Engineering at IGC Kochi in 2022 and Outstanding Civil Engineer Award by ACCE Ultratech at Hyderabad in 2023. He was awarded the Lifetime Achievement Award by the Deep Foundations Institute in 2024. Professor Madhav sir delivered the convocation address as Chief Guest and Orator at JNTU Anantapur in 2025. Most recently, he was awarded the first Asian Lifetime Achievement Award in 2025 by the Asian Societies of the International Society of Soil Mechanics and Geotechnical Engineering, an Outstanding Contributions Medal in December 2025 by the International Society for Computer Modeling and Advances in Geomechanics. It's an honor to introduce
Thank you very much. It's a great pleasure and honor to be here. I joined this institute 70 years before, graduated 66 years ago. But today I want to share you something. Can you hear me? basically what I'm trying to share with you. I would again like to thank ideas, Dr. Anil Singh and AP Singh, who brought this book, which you'll be seeing soon. But what I want to share is that geotechnical engineering, we have made enormous progress. But somewhere along the line, we have a parallel progress, but there is a big gap in terms of practice. I don't know people whether they appreciate the gap or not, but I wanted to bring out these facts to our practicing engineers and colleagues so that, in my opinion, the field of geotechnical engineering can be practiced and delivered. Yesterday, Professor Raji, if I remember right, said there's nothing like a problematic soil. But I would like to say, soil is problematic, otherwise you would have been here. For civil engineers, for them soil is, particularly for structural engineers, they have no feel for it. All they want is one benefit for it. But soil mechanics, geotechnical is very different. So I want to start my presentation with this quotation from Victor de Mello. Incidentally, he would have been 100 years. On May 14th, they're celebrating Centenary of de Mello, who was born in Goa. He said, the importance of science is not so much to say new facts. I mean, this is not always, but if you can think of different way of the same subject, that to me also is equally important. So I want to share that part of it with you. And what I want to say is that when I look at ground and geotechnical engineering, if I look at 4 or 5 colleagues, it is like this cartoon. We have very different perspectives. You give the same data, they'll say one thing. The practitioner says something, the contractor says something. So you find the biggest problem is how to synthesize all these ideas into one person. We had to grow to get overall picture. So what I'm going to present today would be some of them. I have many of them, but I don't think I have time for covering all of them. What I want to say is that the biggest problem is we start teaching soil mechanics, but we deal with the ground. You think the soil and the ground are the same or are they different? Second thing is the soil is not homogeneous nor semi-finite. This again what we keep teaching, assuming that the properties are same. Then ground is nature. This is one of the most important things. You will not get any normally consolidated soil. Soil is formed and the ground is always over-consolidated. I hope I'll be able to convince you that. But the problem is we practice as if it is a normally consolidated soil. There are enormous consequences. Okay. The other thing, ground is not steel, which is the rigid plastic material. We have a different material, I call it a compressible elastoplastic material. We should not ignore OCR, the price we pay is very high actually. The properties of the ground are very different from what we measure in the lab. I want to bring that into focus degree. The axial settlements you find are very different. The highest code, unfortunately, has what's called SPT correction, which originally was given in 1960s, part of the book by Terzaghi, only for finding a relative density of science. But we are using that correction for everything. And again, the consequence of that is our estimation, measurements, etc. are very different. And the bearing capacity, when I calculate, which is the bread and butter of geotechnical engineering, ought to be considering how the profile varies, the strength profile and the compressibility of the soil. And lastly, if you are in medical practice, some of the doctors, they can't cure anything. They say, let's take an antibiotic and they give a broad treatment. And here, even in India, we think that if the soil is not good enough, we go for piles. So I want to say, piles are not broad spectrum antibiotics. So let's go through the whole thing. So I want to say, if I look at soil, on the right you can see a large number of varieties. And you can look at human people, where people from different states, how different we are. But on the left you see ground. We may not be visualizing, but this is one of the complex profiles that you can think of a ground. Or if I look at a simple bridge foundations, I want to see how variable it can be. You can see that where the cover is maximum, you have different varieties, then you have thickness varies. So it's not as simple as a single entity or what it is. So please remember, soil and ground are two different things. I want you to again look at it. Soil you can see, you can feel it, you can test it, you can handle, manipulate, and you get so-called properties, honestly. I don't believe honestly they are properties, but we say, okay, liquid limit, plastic limit, undrained strength, etc. And we characterize. But when you look at the ground is like a human being. Please remember, the only two natural products, which again Characterizing himself said, the soil, the ground and the humans are not manufactured naturally. So you may think you have some, just because I have two eyes, nose, mouth, whatever it is, does it describe me? So it doesn't. So basically, it depends on what the in-situ conditions are, what is the engineering geology of it. This is the biggest problem. Most textbooks talk of marine clays, alluvial soils, etc. We are using indiscriminately the same principles for residual soils in this country. That is one side. Then we have the effect of water table, stress history, what have you. And then more, I believe, the ground has a response. It doesn't have characteristics. It depends, reacts to what we do. That's a major thing I would like to say. Ground doesn't have properties. If I do excavation, it will expand. If I load it, if I put a embankment, it will squeeze. Whatever it is, a response. So that's what we would like to say. So what I want again bring out the analogy would be, I would like to look at the human being and the soil, ground and society. These are all very different entities, but I want you to look at how they can. Just look at this room. I want to ask you a simple question. If I want to know the behavior of this class or group of people here, we are about 150. How do you do that? Can I just talk to 2-3 people, listen to them and say the group behavior is the same? When we are human beings, an individual is one. If you have 2 people, you have one. That small number you can deal with in a class. But if you have a large number, 100, 150, it becomes a very large group. Then you talk of the crowd. Maybe you are talking of 1,000, 2,000 people, etc. Can I predict the behavior of the crowd, knowing the behavior of 1 or 2 individuals? Then there is a big problem. There's a crowd and a mob. You know what's the difference between a crowd and a mob? Can anybody tell? My philosopher would have told me here, a sociologist. The difference is, in a crowd you are still an individual. In a mob, you lose your identity. You become one of the whole lot. Somebody says, "Bought this bus, kill the guy." You don't think of it. The whole mob behaves as one entity. Look at the ground. If I have a small particle, or a group of particles, or a small element I'm talking of, let's say triaxial one, 37.5 millimeter depth, 75 millimeter height, or odometer, 20 millimeter thick, 600 mm, etc. Then I come to ground. The one I showed you, such a large volume, you think you can represent by few elements that you test in the lab? Then the other interesting thing, the same ground during an earthquake can become a liquefied ground. What's the difference? The ground loses its identity in terms of effective stress. The effective stress becomes 0, so the same ground starts behaving like a liquid. Now you can see the parallelity between a crowd and a mob and a ground and liquid ground. So you can see, even though we are all practicing geotechnical, how many of us appreciate that ground is such a complex entity. What we normally do is we test some in the lab and we try to extrapolate the results to the field. How genuinely correct it is. So one of my techniques is we should now concentrate on understanding, observing, measuring the behavior of the ground and try to get the information back. That's what I would like to first characterize the ground from its response. Please remember, this is a reverse process, but you have to use them as a complementary one. I'm not saying one alone, but you have to do back and forth and you become much wiser. Okay. So for this, of course, way back in 1964, I think, gave the observation method. He said even when you are constructing, you find the response and change the design accordingly. So this is what the doctors do. If one is not well, he goes to check with the doctor. He gives a medicine prescribed. If you are cured, fine, but if one is not cured, you change the medicine, you change the dosage, you change the whole process, etc. That is necessary even in ground. So it is not there in the design office or classroom. Geotechnical engineering is in the field during construction. Your design, how it is implemented and how the ground is going to respond. Okay? Ground is neither homogeneous nor semi-infinite. We keep teaching as if these are very simple models to work on and all the bearing capacity equations, sediments, etc. are assuming as if it is. This is a classic example. We don't have that in most of the country, but if you go to northern Himalaya, where you have a glacial deposit, you get it. But I would like you to look at the simple alluvial soil, marine and alluvial soil. This is for all I know, probably from Visakhapatnam or to Bikangla. I want you to look at it. The underlying strength is 9 in the top, increases, then increases linearly. Alluvial soil is much more complicated because it's a Ganges deposits over the last 20,000 years. You can see that appears slightly, so increasing is large increase, variable. And here I have a different one, the strength increases. How do I characterize this as a homogeneous soil? How should I apply my theory? Have we considered that in our design? These are some of the complex profiles that we deal with. You can see the stratification. And the biggest problem is how to characterize this complexity. And many times, for example, in Visakhapatnam, you will probably get hard rock around 15, 20 meters. So it's a finite layer. We never put that in our analysis. I've yet to see a geotechnical investigation report that looks at this profile and gives a recommendation. They give the profile but never do the analysis. Then I come to the concept of overconsolidation. This is a historical wonder that we have. I want to know, all of you are probably familiar that we brought void ratio versus effective stress linear scale, void ratio versus effective stress on semi-log. And this was given by Casagrande in 1936, a simple graphical construction which we teach to all of you. And then we get what we call the maximum pass pressure overconsolidation. Right? And if you read any textbook, they say overconsolidation you can unload. Am I right? We teach that. The reason they did was way back in 1913, 14, when they wrote the textbook, the North American, Taylor, Terzaghi, Casagrande, Bishop, Skempton, all the books we borrowed from, they are in North America and Northern Europe. 20,000 years ago we had Ice Age. Ice Age had 100 to 120 meters of ice formed, and once the Ice Age is over, all the soil became overconsolidated. So they put that as a criteria. Tell me, did Ice Age come to India? We never had Ice Age. We didn't have any unloading. But why did we teach that to all our students? So overconsolidation in the traditional sense, incidentally Ice Age covered only 25% of the globe. So if I look at Southeast Asia, South Asia, part of even Central, Africa or South America, they didn't have. Near the tropics, no Ice Age was there. Why do we teach unloading? Honestly, there's no unloading. But we have what's called pseudo-overconsolidation. This is something we don't accept it, but we have to say our soils are overconsolidated. One of the reasons is long-term trees. All of the soils which are deposited are been in existence for 1,000, 10,000, 20,000 years. The consolidation is over, then the creep takes place. The creep gives you pseudo-overconsolidation. Similarly, desiccation, our temperatures in India can go up to as high as 50 degrees in some of these. So obviously the temperature effect will shrink the soil, making large effective stress. Then a lot of water table fluctuations. The water table can go 4 or 5 degrees. When the water table is high, you have submarine fade from the soil. But once the water table goes down, it's a total stress. So you find that soil gets over-consolidated because of water table fluctuation. Plus a lot of leaching. I found that in Kanpur, for example, when you have this limestone deposit, the lime gets deposited. We have a lot of conker there in alluvial soil. How did the conker become? It's a pure sand, but with calcium carbonate it became conker. So it becomes all of that. It could be a combination of all. So when I look at this effect, this is what way back in 1972. I think in the Moscow conference we presented, and of course there's a rank index around that too. You can see the soil got consolidated over a period of 10,000 years. Now if I load it, it behaves as if it's over-consolidated. That's why we call it a pseudo-overconsolidation. It's not over-consolidated in the traditional estimate. And how do you estimate? You can see that depends on plasticity index. No soil in India, most of them, except the one in the Bay of Bengal at the mouth of Hooghly, where we have some new soil being deposited. And of course that island is a bit of a contention between India and Bangladesh. But all other soils have been in existence for how long? 10,000, 20,000 years. So all of them develop more consolidation on the order of 1.5. And it's not a small amount, 1.5. I'm not talking heavily over consolidation. I'm talking lightly over consolidation. Okay? So you find, when I look at the profiles, I find in all the soils you have brought, even routine lab testing, can you see that over consolidation is around 6 to 7 at the top because of desiccation, and the creep effect it goes through at least 2, 1.52. Then nothing like a normally consolidated soil. This is, I got samples from different places. I didn't put all of them because not enough time. But basically what I want to say is that normally consolidated soil is like a equator. Have you seen equator drawn anywhere? It's a concept. But there is no normally consolidated soil. All soils in nature are over-consolidated. Okay. Then I want to come to the major one which I want to share with everybody. Ground is not steel or rigid cast. This is the biggest anomaly we have. Again, it's historicity. I have nothing against Terzaghi, please remember. He was great. He brought the subject into focus, and we are going to celebrate 100 years, I think. Glad that Anil and Madhavi will be there in Vienna. I hope some of you will be there. They are going to celebrate 100 years of soil mechanics with a time capsule. And I'm happy to say this is going to be included in the time capsule too, thanks to our idea which forwarded. I want to show you. I brought in here stress strain curves of all the engineering materials, civil engineering materials, steel, concrete, and soil. Okay, now look at steel. You have the normal steel which is 415, 420 megapascal ultimate strength. And failure strain is very low. G, the E value is around 210 gigapascal. Then we have the low E strength. That 220, 250. You have first lead and the second. These are steel stress strain curves. Then I plot concrete M50, M15. Can you show me where is the stress strain curve for soil and the linear plot? It's along the horizontal line. Now can you tell me, should I treat soil as this material? That's what we are doing. Again, it's not blame, but Terzaghi was a mechanical engineer. he studied Frankel mechanism, which was developed in 19 early part of it. Frankel was working on punching of metals. He came with a theory, and we adopted for very capacity. Would anybody with simple, rational knowledge, would you say that a material which behaves like this is the same as the one which is along the horizontal line? But we are doing it. And just to make life easy, I brought it on the log scale here. And if you look at failure strain for steel, they are not 1, not 2%. Whereas for soil, 10 to 15% is the failure strain. So, do you think ground soil is a rigid plastic material or highly deformable medium? What is the logic for treating ground as a rigid plastic medium? This is how we do that. Nothing wrong. Somebody has to start somewhere, but we are still hanging on to it. The sad part is the code, all the textbooks, and the way we teach. We think this is a holy thing. Honestly, this shouldn't be taught at all. For soil or ground. Even simple one which you got in Lambert, Whitman and other books now, they are divided into 3 zones. General shear, local shear, punching shear. And they again categorize this one step forward than rigid plastic material. If you look at the way it behaves, you can show these are the kind of mechanisms that you have. This is punching shear. Can you see it just keeps going down, there is no failure at all. Depends on that, and we want to classify that. So, yeah. I want to show the failure strain in loose and soft clays. The ultimate state is reached after 15% strain. Can you imagine that? Whereas steel, failure strain is less than or 2%. And we still do. And this is again what we teach in the class. Why should we stick to it honestly? Is there a clear demarcation or is there a continuity in the whole course? I want to say a simple analogy. If I have a pressure meter, it's a cylinder expanding into a cavity or the cavity expanding cylinder cavity, and in order to find out the limit pressure, Gibson and Anderson way back in 1962. What I am teaching is not anything new. It's all in the literature. Only thing is we are not communicating to the profession and the class action. So they came out with a simple equation. I'm sorry. Here is the cavity expanding cylindrical cavity. How did you get the limit pressure? I want you to look at the equation. Limit pressure is equal to NC CO into NC star. It's a very capacitive factor plus sigma H round, which is the horizontal strain. Can you say it's very similar to our very capacity, 100 very capacity, Cu and C into sigma round? Can you see the very similar expression? Except I want you to note that NC is a function of 1 plus natural log of G by Cu. What does it tell you? It depends on the stiffness of the ground. The ultimate condition does not depend on Andhra strength alone. Please remember that. Do we teach that? No. Then after that, basic came with this cavity expansion factors for CFI soil. We have, in addition to shave, depth, etc., we have compressibility factors. In which case, I don't need those demarcations. I don't have, say, general shear failure, local shear failure, or punching shear failure. I have a continuity. And you can see that the amount of variation if I plot with respect to that G by Cu or G by sigma tan phi whatever it is, you can plot how ultimate varying capacity or ultimate varying capacity varies a function of the relative stiffness to ultimate strength. Why don't we teach that skill? Or why don't we practice it? I got all these equations, I think, thanks to Parmouti. then the biggest problem is we call undisturbed sample. It's called oxymoron. I don't know how many of you know oxymoron. It's a contradiction of two words which are contradictory. Deafening silence, small crowd, original copy. So undisturbed sample is an oxymoron. There's nothing like undisturbed sample. You know how we investigate? We do drill a hole, we take the soil, we pour it, which is a disturbed or remolded sample, then we drive a sampling tube, very carefully supposed to be, and then take a sample out, bring it to the lab and test it. Again we test, please remember, either 97.5 mm and 75, whatever is the kind of sample. That is so-called undisturbed. Somebody worked out what happens to the sample during the process. The soil is here at point A. If I look at the stress changes, I believe in the stress path, I don't know if we teach it or not, how the point changes within the ground in terms of stresses. The stress changes from A to B during drilling, because we have put a lot of stresses into the ground. In sampling it goes from 3 to 6 because there are a lot of unloading. Then when I extrude from the tube, it goes from C to D. And by the time you test it, after trimming etc., it comes to point F. What we determine at point F is what we think is the proper delivery. Can you imagine what changes that are happening in the ground? There's nothing like an undisturbed sample. If I look at this, when they did with very careful testing, this is the so-called undisturbed sample. As you introduce the crudeness, this becomes manually remolded. Can you look at elong because they keep shifting left, which means they lose the over-consolidation effect, the stiffness effect, and everything. If I look at the stress strain curve, this is the behavior of the undisturbed sample, so-called perfect sample. And this is what we test. All our designs are based on these stress strain curves. So tell me, is this what soil mechanics geotechnical is? Are we realizing what we are doing to the sample? So we have a lot of measures to do that. Have you ever evaluated what is the degree of disturbance of the sample and how they correct it? Okay. Then the maximum pass pressure, Casagranti gave it in 1936. Where are we hanging on? After that, about 8 to 9 new methods are there, which are more. Casagranti method is a judgment of height. You have to find out the point of maximum curvature required tangent or something. But several new methods have come. Are we going to use them? But we are not using. There are so many methods given by Casagranti. Then this is one part of field. There are different methods. Even one colleagues from Bangalore in India. So you find several of these methods. So I tried to apply all of them, and you can see the amount of variation. Which ones are actually helpful? Is there a study so that you say this is the value? Even the consolidation ratio. Okay, that's better. So you can see the 8 methods, 9 methods you should calculate. Same data is the same, but I get different values. Which one shall I believe? Haven't studied that? Because over-consolidation ratio makes a big difference in terms of behavior. This is how it varies. If I look at, if I take Casagranti method, with any of these methods, variation can be 20 to 80%, plus or minus, which is true. Okay. One couple of sites I was doing. Once again, each borehole I have a different value. So what I'm trying to say is that complexity in the ground is so high, you have to use beyond rationality some kind of judgment. This is again comparison from different side. You can see again enormous variation. I have another side from Dartford. You can see the variation. It can be, in this case I found more than 100% difference. Then if I use the values to calculate sediment, you will be surprised. This is what Characterizing gives me, and this is what I am getting from other methods. So the sediment estimate is enormous. Which OCR do I use? Am I correct in predicting according to this, such a large value? Or should I use reasonable value, which is half to 1/3? Enormous variations. In all the projects that I do, where I have the data, I'm lost. I'm looking at 4 or 5 sites where I have the data. And here is the classic. People, this particular case, they said sediments are so high, they go for 5 formation. I said, why do you have to go for this when I can say sediments are much less than that? Okay? These are the. So it should depend on the Characterizing method, we are in trouble, honestly. Then, the biggest problem I found again in the last 10 years is, what you think you got from lab is a holy number. But the ground is not a soil sample. I was very fortunate that I would get good quality in situ behavior from various sites. One of them, couple of them are from Bangkok, another from Japan, another from Sweden, another from Italy. What I did was I plotted, I have the magma plotting, I have the segment with respect to time. I have a very famous Ashoka method, who is a brilliant guy at Nagoya University. All he did was take the segment, measure the note the segments at regular time intervals, say 25 days, 50 days, 7500, plot segment at 25 against segment at 50, segment at 50 against 70, SI minus 1. And then he said fit a line, and where this line meets 45 degree line, I get the final segment. Which means I am able to predict, because at infinite time, segment at the last increment and the present time increment is the same. I get the final segment. So once I get that, I can calculate. So I have this famous site from the Suvarnabhumi International Airport, one of the trial embankment. Soil profile is, as I said, very complicated. You can see soft soil. Bangkok soil is very challenging. You have a desiccation effect very high, OCR, and then has 100 stacking increases with depth, even for normally consolidated soils. For our consolidated, it is even more. So this profile, they put the embankment, they measure the segment at 20 meters. It's a magnetic distance of meter. You can measure segments at different depths. So you have a segment at say 20 meters, sorry, down 2 meters, 5 meters, 8 meters, etc. I have 10 time segment plots. So I apply the Ashoka method. I know what is the final segment. All I did was I characterize the simple profile. I have different layers where they have measured. Top segment 2.5, 8, 12, and 15 where the hard segment is. All of you are familiar with this simple equation. Assuming it is normally consolidated. I'll come to later. So if I know the segment, I know the load, and I can thickness I know, void ratio. Can I calculate CC? Simple. I measured from the field. It's like doing odometer test, but on a full scale, maybe something like 20 by 30 meter or 20 by 30 by 30 meters fragment. It's a real one which I measured. So I got the segment, and then I do the analysis. So I get the CC values because I have different inputs. 0.22 at the surface because it's a desiccated soil. Then you have a 7.4, 7.3, But as you go deeper, it becomes 0.3. CC, which I have been able to estimate from the field, is variable. Then I did the same thing with OCR, etc. I could estimate what would be the OCR of the desiccated soil. It can be as high as 9, 10, etc. I have another site. Very similar. This one is much larger. I can get from about 20 meters. I wanted to look at the data. This light blue line is what you determine in the lab. They did odometer test. When I look at the CC value, that's the depth. This is the value which we have adopted in design. But the way the ground behaves is in dark blue line. Do you think any comparison? It is half to less than half of what we determined. So you think one sample or whatever you test in the lab is good enough for the site? Please remember, the ground has its own property. The lab testing, because it's a highly disturbed soil, whatever, has no relation. Then I also calculated the CV value. Here the surprise is, the lab gave me a smaller CV. The field gave me twice the value of CV. I mean, it's radiant and solvent, honestly. Because in the field, there's a lot more layering effect in the sense that most sedimentary soil have KH much larger. We never even bothered to test it. So you find that the CV values are twice that of what you test in the lab, approximately. So this is how the source is. Okay. Then I go to the Centenary. This unfortunately again we're back in 40s, 50s when SPT was being done. Characterizing in fact realized that if you do test in the sand, the same relative density will give me different N values at different depths. If I have relative density of soil in the sand at 5 meters, 10 meters, N value will not be the same. So they said let's apply a overproduction correction. Beck had a PhD student called Bazara. They also did the same and submitted different forms of information. But all of them emphasize this correction is only for automatic correction is only for relative density estimation, and based on that you get angular shear resistance, etc. It doesn't affect any other property, but we use it all the time. Look at what the IS code says. You had corrected. Whereas if you look at the modern methods of estimating sediment, Mudland and Mudbridge, and Wetman, etc., they say don't use it. The reason is once you correct it, the corrected value reduces by 20, 30, 40%, which means your allowable pressure reduced by that amount. Why should I apply N value, corrected N, for estimating sediment? Again, have you realized that fallacy? Again, I said this is not mine, it is there in the literature. What we are missing is using that information. So, not a or IS 1976. All our colleagues are in the committee, but none of them bothered to modify that. And we are still, the problem here is that we are all hung up on cost. We are not updating geotechnical. Again, I brought the typical variation of strength with them. How many of us use this information? Let me assure you, not a single report looks at the non-homogeneity of the ground or compressibility of the ground. And we give varying capacity based on the minimum value. But if it increases with strength, is the varying capacity same? Which again was given way back in 1975 by Booker and Davis, I think. Varying capacity of non-homogeneous soil. Then we had some work with even desiccated soil. And you can easily find out what you mean the value of varying capacity as a function of rate of increase in strength with depth. All I had to do is plot CU with depth, get the rate of increase and get the value. And then I can get it. It is 20 to 30, 40% more than what you normally estimate. Are we not underestimating the whole thing? So we have several situations where we have a homogeneous soil, homogeneous finite soil, non-homogeneous, then we have many times stratification. Show me a report which looks at stratification. If the footing is here, they only use this value. The next one could be very close. Would this affect? So the problem is really the last one or last one. As I said, we teach foundation engineering. If you have a good soil, go for shallow foundation, otherwise go for fine foundation. We think fine foundations will solve our problem. I have a feeling stop, in between we have to think of a third alternative, I call it. I want to demarcate the structure. I want to look at the structure which can be light, medium, heavy. Light means I look at 1, 2-story typical buildings that you have, which are maybe you need 8 to 9 tons per meter square, 80 to 90 kPa. Medium are 5 to 6 story, you need 14, 15 tons per meter square, etc. Maybe you're of a multi-story bridges, etc. I want to look at the ground. Soft, medium stiff, and hard. Soft is a typical marine clay, and range strength varies from maybe 10, 14, 12, etc. Medium stiff soils are the alluvial soils, and values are anywhere from 20 to 30, 40, etc. Hard soil obviously is the SDR, hard rock, etc. If I look at this matrix, if I have a light structure on soft soil, I can get a very shallow foundation or with ground improvement. Medium stiff heavy structures too on a soft soil using ground improvement. Only when I have a very heavy structure on soft soil, I go to deep foundation. In all the cases, I can probably avoid deep foundation. I have nothing against it, but the reason I want is, if you avoid piles, sorry, I mean your business is piles. So, we are helping in terms of sustainability. If you can reduce use of concrete and steel, we are helping the environment. I don't know how many of you know, 1 ton of cement manufacture releases 1.5 tons of carbon dioxide. 1 ton of steel manufacture, cement is clinker is at 850 to 900 degrees Celsius. Steel is around 1400 to 1500 Celsius. 2 tons of carbon dioxide. Plus, if I want to install a pipe, I have to use a lot of energy. So, can I avoid pipes wherever it is? Including in Canada, I can do that, if only give me a chance. Okay. So, what I would like to do is that, which I think Professor Rajgopal Vishal, we have been working on this. We have a new geosynthetics, the third revolution of civil engineering. I can introduce a steep layer and then build my structure. I'll give you one simple example. I have a site here, not too far from the Shackleton. I did couple projects also here, but I don't have to data. Say, I'll give you a marine soil near the coast. I'll give what you want. This is the, can you look at the profile? And values are 2, 3, etc. Top luckily I have something like 8 to 10 or 2, 3 meters. Someday when I get the chance, I'll tell you, the engineering geology of the east coast of India is very unique. This soil is supposed to be highly plastic. And somebody who before me gave a recommendation that you want to go 25 to 30 meter long, 600, 450, 600, and they hardly give 60 to 70 tons capacity. The cost of piling was so high, the project was being abandoned. But somebody remembered that we can do something. So we said we simply designed a reinforced foundation. I have a granular bed which I reinforce with geogrids or geocells and then build it on. Okay. So we did that. So we did that work, removed the dewatered and spread the granular layer. From geogrid, put another granular layer, compact it. Put geocell for 1.5 to 2 meter thick. One trick is you have to use heavy vibrator. And once we compacted it, we started casting. You can say a 4-story building. On the same ground, no piles. And if you think how it is, I want to see. This Krishna University building is about 12 years, 13 years. Exactly same technology. It's still standing. Why do you need piles? Okay. Now I come to one of the unique things. You talk of modulus of deformation. I call it that. People talk of Young's modulus, elastic modulus. There's nothing elastic in soil. Soils are inelastic. So we should not use elastic modulus or Young's modulus. It's a modulus of elastic. What value should I use? Can you repeat it? Initial and intermediate. But if I use geophysical testing, that means I use MSW dynamic testing, I get a very low strain. This is value of G. If I go PMT, pressure meter test, I get here, relatometer is here, screw plate is here, or SPT is here in terms of strain. Is the G value same at every strain, or does it decrease from 100% to 10%? And if I want it to then, this is the range for deformation, strain for formation, which is hardly 10 to the power of -3 to 10 to the power of -2. Should I use any of these values, or should I use something else? And we do all this testing in the lab. That I do it. Isotopic compression, confined compression, odometer, traction, etc. Look at the stress strain first. Same sample, if I test under different conditions, the slopes of the curves are very different. What is the D value of the soil? Then of course the last one probably is theory of consolidation. Again, Terzaghi was brilliant. He was being a mechanical engineer. He knew the theory of conduction of heat in solid, which is exactly same as theory of consolidation for a linear stress strain behavior. But the moment you say no, soil doesn't behave linearly, log P if I take it, CC may be constant, but void ratio changes linearly with log effect. The moment you do that, the coupling between rate of sediment and rate of pore pressure disturbance is very different. We have never looked at it. We think that degree of consolidation with respect to sediment and degree of consolidation with respect to pore pressure. We have been doing it for the last 100 years, but we are not adopting it. So basically the final one is, engineering characteristics of soil or in the lab are not very, very relevant if you directly. You have to use your judgment to predict the behavior of the crop. Please remember, I'm not saying we don't test it, but once you get the values, think how do I use it. I have shown you at least 10 cases where it can deviate from that. So I want the codes to be rewritten so that people will appreciate how the ground behaves. That is the final model of this presentation. I hope I convinced you. I would like to end with my presentation. All of you know how to calculate a square root. Have you seen a square root? So I have a square root if you want to see. And of course, I end my presentation. As a science, but in practice is not equation. So all my young friends, please remember, all of us try to understand how the ground behaves. And again, on the lighter side, I can say, I've been married for 60 years, so if I want to understand my wife, I can't use equations. I think all of us who are married, we agree that life is a little more complex than simple. Thank you very much. Again, I'd like to thank you.
has touched all the existing concepts that we are teaching and which we are reading from both soil mechanics and foundation level. Sir has rightly pointed out the do's and don'ts. Right? So, hope the majority of contact students and who are here have realized what Sir has conveyed, and all this information has been published in the form of a book by Indian Geotechnical Society titled Geosopus. And IGS is sharing soft copies to all the delegates also. So you can go through the book during your leisure time, and it will be very much useful for your dissertation works and taking up some research work, right? So thank you very much, sir, for your excellent contribution to the geotechnical engineering complex. So this stands above all the textbooks written by different authors. They only gather information about this. Sir has, based on his observation and experience, based on his own findings, has brought out this volume. So we are very proud, sir, that an alumnus of Andhra University has published a very important document which will be referred by engineers across the world. Thank you very much, sir. The release of Geosopus will happen now. For that, I invite President of Indian Geotechnical Society, Dr. Anil Joseph, and Honorary Secretary of Indian Geotechnical Society. I also request Professor Rajagopal sir and other members
Rana. तीस साइड को कुछ नहीं पा तीसाला पूछन पकड़ा ఫాస్ట్గా వెళ్ళాలి. సార్ అడ్లేరా సార్ కూర్చోండి సార్.
She joined IIT Madras for her PhD under Professor Rajgopal. And later she became anyway, formal introduction to me Asa. Right? So it will be a proud moment for her that her guide will be introducing her. We can tell more about what she is popular for? Chenab. Okay, so she will be dealing her role, right, in construction of Chenab bridge, right? So what are the aspects, right? How long she is involved, right? So she will be clearly explaining, right, exactly what contribution she has made, right, in building Chenab bridge. So I invite Madhulata madam to come on to the Madhulata on the dais. If you do remember, I thought delivering maker madam.
శివన్న శివన్న
Regarding the other first we have it is extension introducing Andhra as of 2026. Madhavilata as of 2026, all of you know, with the newspapers and television channels, and if I start introducing her, the time will not be sufficient. But I'll just take a few, just maximum 2 minutes to tell you about her. When she joined for her PhD in 1996, she came just like one of you. Absolutely innocent, because even now she's innocent. a lot of aspirations. And she did her BTech at JNT Kakinada, just like me. So that's, and then she came along with Professor Sri Rama Rao Garu that time. And then we already heard about her because when she was doing MTech, IGC 1995 was held at Warangal, and there is a small girl who raised a lot of questions. That's a rarity, and now I don't see any students raising any questions. So that's her popularity was already there, and then she joined. And the way she took up research was phenomenal. And she worked with soft clay. Working with sand is probably more easy, and that's probably why most of the results that you see they are with sand. But she worked with clay and trying to synthesize and trying to achieve homogeneous soil of certain thickness. I think she worked with very large tank. She worked with sand on small triaxial compression, just 100 mm diameter test, and then with the sand, with clay, she did some tests on the test tanks that are about 2 meters long, half a meter wide, and then the depth was almost 1 meter thick. And you have to see her to believe. She used to come with half pants, and then she was kneading the clay. It's not easy to mix clay. It is not like taking a clay powder and then mixing it in the hand. She was doing it so much, and then it is not just for one test. Like every time you repeat the test, you have to have the same bed. Otherwise, your results will be totally different. You do not know whether the results are because of the geosynthetics or because of the clay soil below. And all the work that was done, she came to me one day with a lot of data. And then I don't know in what mood. But I said, this is any high school student can draw these graphs. But what is the analysis? I've not done. Maybe I said it a bit harshly, I don't know. And then for 2-3 days I didn't see her. I thought she was really angry. And I was also thinking maybe I should call her. But then the 4th day she came. She came with beautiful synthesis of how to correlate the modulus, the effect of geosynthetic and strength, and then she was able to correlate between the triaxial strength and then the observations from her test on the environment. That was the beauty. And the publications, they are still being referred now. I think the last time I checked was maybe almost 2 years back. Citations crossed more than 500, maybe 1,000. And you can see at that time itself, I knew that Madhuralata will be somebody. And now she has been awarded so many awards. And I think without any more time wasted, I want to have the pleasure of handing over to Madhuralata.
అందరికీ నమస్కారం. ఆంధ్ర విశ్వవిద్యాలయం శతమానాలు పూర్తి చేసుకుంది. లక్షలాది విద్యార్థులకి కళలకి ఆవిష్కారం సాకారం ఈ ప్రాంగణంలోనే జరిగింది. ఈ సందర్భంగా మీకు అందరికీ అభినందనలు. ఈ మహా విశ్వవిద్యాలయానికి చెయ్యెత్తి నమస్కారాలు తెలుపుతున్నాను. It's a great privilege to stand in front of my teachers. I am really overwhelmed. Professor Rajgopal, he is very precious. I will only call him as as precious, very rare kind of a researcher who is unbiased, not affected by any of political scenarios in the society. So great to have him as my research supervisor. And Dr. Anil Joseph and APC, the pillars of our society. Very difficult to talk after Professor Madhav. You all should agree, because you can never match his wisdom. It's like my talk would be like watching a mass movie after a K. Vishwanath sculpture. I'm a great fan for his wise talk, but I have my own fan base, sir. So hope I will be able to match their. And this session also is very strategically planned. Two stalwarts and in between my talk, and then my own student, Murali, my first PhD student, will be presenting in this session. Okay, so when I asked Centenary and Reddy about what to talk about, because I work on varied things. I have so many topics on which I give talks. He said, Chenab. So sorry for being repetitive. Many of you would have heard this talk here, elsewhere, or on websites, YouTube. But this is very fascinating national project, so people keep asking me about talking about this project. So please don't believe that this is the only thing I did in my life. There are several other things that I did in my life which have not seen this much of fame. Like, going forward, I will try to explain why this project became very famous. Why all of you have seen those newspaper articles about this project. So, because this is a 127-year-old dream of India to connect Jammu and Kashmir with the rest of the country by train. Maybe centuries ago, Maharajas of Jammu and Kashmir planned to have a train between Jammu and Srinagar, but it was not materialized because of the tough, complex geological conditions at the site. And in 2002, the government of India has declared this as a national project. From that time, the work moved very quickly, but then it took almost 20 years to complete. There are like several questions about why this kind of a project should take 20 years for completion. And in my talk, I will try to tell you why it took such long. This is a part of the bigger project, Jammu, Udhampur, Srinagar, Baramulla railing project of Indian Railways. There are several segments, Jammu to Udhampur, Udhampur to then Kajiganj, Katra where we have Vaishno Devi shrine, from there Kajiganj, then through Anantnag to Srinagar, and from Srinagar to Baramulla. Most of the other segments were completed quickly, but this segment where we have Chenab railway bridge took the longest time for the completion. Because of this, why it took such a long time is because of this ambition of our country to build the world's highest railway bridge at a height of 357 meters above the riverbed. This is like, if you put Eiffel Tower below the bridge, it is still 35 meters shorter than the bridge. And then we are trying to connect two steep rock jointed hills in younger Himalayan region or lower Sivalik region, which are highly complex, prone to earthquakes, extreme climatic conditions, and the height is like 359 meters is on the deck. If you stand, the wind can be blowing at a speed of 220 kilometers per hour. So that is the kind of structure we are talking about. And if you see this carefully, this almost half a kilometer arch is completely unsupported because there is this river Chenab flowing below, and the river is going to Pakistan. So very sensitive region politically and topographically, and you don't want to cause any disturbance to the river. So this arch is taking support only on two sides of these hills, which is the most difficult thing to achieve. The whole bridge is about 1.3 kilometers. And there are foundations, 4 foundations on the slope on the left abutment, and then 4 on the right abutment, and there are viaduct portion and other foundations. So I must describe my first visit to the site. This happened early 2005. Myself and Professor T.G. Sitaram, my colleague, we visited the site. To go there, we have to take a flight from Bangalore to Delhi, Delhi to Jammu, and then Jammu to Katra by road, and Katra to another village by road, and then take a boat, and then go to this foothill of this left abutment, and climb all the way up by foot, because there is no road on it, there are no facilities for human living there. And if you have to go to the other side, you have to climb down, take another boat, go to the other foothill and climb up all the way. So that was the initial condition. The conditions are not conducive for human living. Hardly you see humans, and there are like maybe 1 or 2 people living with cattle or a donkey. So other than that, you don't see any humans, because there is no human footfall on these hills. And what you see when you climb up is a kind of scary picture. It's kind of 3-dimensionally complex geological setting. What all you have studied in geology textbooks, you will see it in front of your eyes. And the first impression is like, we stand here, look at this, we are trying to build a bridge connecting these 2 hills. Are we being over ambitious? Is it possible at all without a support? So what are we going to do? So this was the first impression. But we have reached in geotechnical engineering, we have reached a stage that we have overcome several limitations of this soil, ground, like Professor has explained. Many solutions we have found. Earlier days when I was studying engineering, it is like how much bearing capacity the soil has. Now we ask, how much do you want? Because we have methods by which we can improve the ground, all problematic soils. So with all that confidence, we moved forward. The first step was creating roads on these slopes. When we are trying to make these approach roads, the most difficult part is, if you use regular techniques like blasting, you are going to cut extra slope, which you are not able to rebuild. Because if you are building foundations on these slopes, you need to have that kind of setting for making these foundations. Any slope cutting, extra slope cutting, would be a big problem in the future. So you need to follow the contours of this rocks carefully and cut it in a way that you don't create extra instabilities in the slope. So when we are doing this, like we keep traveling on these roads during our initial visits. During our second visit, we just missed a huge landslide by a whisker, few seconds. So why I am telling this is, when you travel on these approach roads in a polis kind of a vehicle, you don't see the end to the road. You don't know whether you are going into the valley or taking a turn. So those are the days like we just close our eyes and pray that we reach the destiny safe. So these are very difficult projects. And to students who really do not know about the seismic activity in this region is a kind of plate boundary, very close to the convergent plate boundary. The Indian plate on which we are living was far away from the Europe and Asian plate, we call Eurasian plate. And there's a huge ocean called Tethys, which was separating these 2 plates. And Indian plate is moving at a speed that about 10 million years ago, it hit the Eurasian plate, and the collision caused these Himalayas. And still the Indian plate is moving at a rate of 5 centimeters per year in the northeast direction. So you can understand the dynamics of this place. There is continuous tectonic plate activity, mountain building activity at this place, that you need to take care of these dynamic forces into your design when you are making this bridge or the foundations for the bridge. And more surprises in this region, there are like these kind of openings and caves you see everywhere. This is a dolomitic type of rock, type of limestone, which is reactive in nature. And if atmospheric carbon dioxide mixes with the rainwater, it forms carbonic acid, and part of it dissolves this rock. Over millions of years ago, these kind of caves are already formed in this rock. And then there are also these tectonic tensile forces which are opening these joints wider to create more open joints. And then if you have a kind of rock joints which are pressed by in-plane shear, you have more closed joints like this. If the forces are out of plane, then you have force like this. These are all the pictures I took from the site during my initial visits. Whatever we study in textbooks, we can see them there, and then we understand like how to deal with this kind of rocks. It's not an easy task because I started working in this project when I was just 2 years old in IASC system. And it is like a steep learning in the project that nothing is ready. There is no template, there is no blueprint for everything what we do in the field, but we learn and evolve. In this type of conditions, you can expect different types of failures. I can explain in brief. See, you have sets of joints. No joints are like single. There are sets of joints because these are formed due to tectonic activity. And if there is one set of joint which daylights or dips into the valley, and under the influence of its own weight and external forces, it can just get separated from the original slope and fall into the valley. We call it sliding kind of a failure. If two sets of joints intersect and they form a wedge, this wedge can also be falling into the valley under the influence of earthquake or external force or the foundation built on it. So that we call a wedge failure. And there are also situations where the joints are not favorable for falling, they are unfavorable for sliding and wedge failure, but there could be fatigue or creep-related forces by which they can fall into the valley due to flexure or toppling. So that is another type of failure. And then, if the rock is completely fractured, like I have shown in the pictures, this acts more like soil than rock because it's a completely fragmented rock. In such cases, you can expect a deep-seated global failure or rock failure like this. So these are the types of failure modes for which we need to do the analysis. And we are talking about 359 meters high. And when I say slope, it has 3 dimensions. On all 3 sides, you have to make cuts to make the foundations. And then on both sides. So these kind of rocks are spaced at almost 5 centimeters to 10 centimeters. So you can imagine that millions of rock joints exist in these slopes, which makes this geological analysis very complex. So this is the big data with which we started this. We have the digital elevation model, x, y, z coordinate of every point and the slope is mapped first. Then we have the seismology data given by IIT Roorkee. They have done a site-specific earthquake analysis and they gave a signature, time versus acceleration response of the most probable earthquake that can happen at the site. And we took almost 1 kilometer deep boreholes, and that data, stratification and samples from those boreholes are tested in the labs. All the data is there on one side. Then National Institute of Rock Mechanics has conducted tomography survey where we send electric pulse into the ground. Based on the resistance offered by different layers of the subsurface, you can map the voids, cavities, density, contrast. All the data is on one side. And then we also have lithology data, which gives you the properties of rocks, their texture, physical features, all that. Then geological data. Geologists have worked day and night at the site. They have gone physically to every elevation and mapped all the joint sets present at the site, their orientation, their frequency and persistence, and the spacing between them, and the infill material. All the data is there on the one side. We need to integrate all this big data into slope stability analysis and the design of foundations. Now these are my specific contributions to the project. I'm not going to read that out. In summary, starting from geotechnical, geological investigations, and then analysis of foundations and design and construction of foundations, slope stability analysis, providing support to slopes through rock anchors and grouting, long-term instrumentation, and then construction stage analysis, monitoring. This is the reason 17 years it took for completion of all these tasks. So that is one question asked by many newspapers, like why you should take 17 years for building a project like this. It has several stages, not one single person, millions of people worked for this project. And geotechnical and slope stability analysis was the most critical and complex part of this project. That is why it gathered a lot of attention. This is the first picture I drew in my Excel sheet from my computer I am presenting here. When we are planning about putting foundations on the slope, you need to make a base for it. how do you cut the rock slopes? So there were multiple options. This tells me like how naive I was at that point of time, how inexperienced I was at that point of time. Because as a, fresh student, you have so much of energy, you will think of multiple possibilities. But like Professor Madhav told, it is not just like, science, it is kind of art. You need to know like how to work with materials, and it's not easy to cut rock like this. There are several difficulties, including like you need to move construction equipment, you need to have berms to make those cuts. So finally, the railways has approved the last picture what I am showing. That is the final approved profile. We started geological investigations. To do this, on both sides we have created small tunnels, we call them adits. We can go inside, map the rock giants. We can also do some in situ tests inside these tunnels. You can see the drone image and also the close-up view of this tunnel on one side. So this is how you can move small equipment inside and do the test. This is also one pit made for a foundation site. So here also we mapped a lot of joints. And on the audits what we made also, we have 4 different sets of joints we encountered at the site. They have different inclinations. So these are like 4 joints and their spacing, sometimes it is less than 10 centimeters. And now to do the analysis, I am not going into the technical details of kinematic analysis, but what I want to tell the students is, if you have to analyze these joints and understand the types of failures I explained, you have to treat the earth as a kind of a face. This is what greater circle we call, is the face of earth, you can imagine. And every point on this represents by latitude and longitude, which you all understand. On this you put all the rock joint sets. You are seeing like 5 different joint sets here. This we call as pole plot. These are plotted through latitude and longitude. And then in a stereographic projection, you can see average of these joint poles, which you compare with the central line of the bridge and the slope face. And through that you can do the kinematic analysis. On the face of the earth, you have all these joint sets and how they are oriented with respect to each other and with respect to the slope. That is what you are going to analyze. For example, if you are analyzing for planar sliding, this is the face of the earth, and this central circle we call friction cone. When there is a type of failure which is about to happen in the rock, there is also a resistance which is inherent in the rock, which is the friction between the rock material. So we call it friction cone. That is represented by the friction angle drawn on this greater circle plot. And if there is a joint set which is falling within the friction cone, that means you have a possibility of sliding failure. So you need to analyze for such failures. And the best thing is, whatever we predicted initially on the paper was also seen at the site. That gave us a lot of confidence. Though it is difficult to say that failures give you confidence, it is the truth. Because if you go with this kind of analysis blindly, you don't know what you are predicting is correct or not. Sometimes what you predict, even in terms of failure, if you see on the field, it gives you a lot of confidence. Similarly, the wedge failure analysis, the intersection of 2 joint sets, if it falls within the friction cone, then you know that there is a wedge failure which is possible. At the Chenab bridge site, most of the types of failures we predicted are wedge failures. So all the support systems are designed for the wedge failures. When we are designing for wedge failure, we also consider earthquake forces. When I talk about earthquake force, earthquake is a random process. And in which direction earthquake works, the force is acting on this kind of wedges is unknown to us. So you need to consider all possible scenarios, whether it is acting along the sliding plane, or it is acting in the direction of the most critical joint, or it is acting in horizontal direction or vertical direction, or the resultant of horizontal and vertical components of the earthquake. So all those scenarios are considered, not one single scenario was left out. And then toppling failure was also analyzed. Here I have to also talk about 2 methods by which I did the global slope stability analysis. One is limit equilibrium analysis, a very simple method which people use, where we find out factor of safety against the failure. Factor of safety is nothing but resisting force divided by driving force. So in stress strain response, if you have a shear stress, shear strain response here, you have this kind of a plot which represents the constitutive behavior of the material. What I am showing you is A, B, C are the points on this constitutive response. The material behavior transforms from one point to the other point slowly. For example, you have this slope. This is a kind of imaginary slip line, what we call, along which you will measure the resistance and the driving force, and you get the factor of safety. What exactly happens along this slip line is, the point here, what I am showing you here is the peak point, the strength of the soil or rock is reached to its maximum. And that point, if it actually falls on this slip line, that is the point of starting of failure. And once this is initiated, failure is inevitable. If a point reaches, the position of peak A, then failure is inevitable in this slope. And slowly the A progresses and B comes to A, C also comes to A, everything fails. That is what is the limit equilibrium, what we consider in our analysis. We also do the pseudo-static analysis where we assume that earthquake is a static, pseudo-static kind of a phenomena. The earthquake force can be simplified into horizontal and vertical components of forces. Like all of you would have studied the slope stability analysis. Analysis is next step where you more three-dimensional kind of a computational platform are happening. If you are using a continuum model, you need to look for the concentration of shear strains that gives you the possibility of failure. So all these analyses are carried out, and then also to tell you how ground response analysis or earthquake analysis is carried out. Earthquake can be seen as this, like if you drop a water droplet into the kind of still water, then you can see these ripples which are like concentric circles. What is moving is not water, what is moving is the energy, which is moving from the concentric center to it spreads in concentric circles. Exactly this thing happens when earthquake happens. Earthquake happens few kilometers below the ground. And that actually, in terms of concentric circles, it propagates in all directions, completely in 360 degrees. So then you have to put this into your analysis. Earthquake is happening here, this we call as source, and this is the site where you are making your construction. It has a long path, which is kind of, it has several subsurface layers through which the earthquake wave passes through before it reaches the site. So the source parameters, if you consider for analysis, you are doing a big mistake. You need to understand how the source wave is transforming through these different layers by the time it hits the site. So this is called site-specific ground response analysis. And while it propagates through different layers, it changes its direction, it changes its amplitude, frequency and duration. And by the time it reaches the ground surface, its parameters are completely different from those at the site. So the site-specific analysis carried out by IIT Roorkee is something like this. You create all these subsurface layers of the Chenab ridge site, and when the earthquake hits the bottommost layer, it has certain properties which can be represented using a wave equation like this, where this is density and this is the shear modulus, this is the viscosity. And if you have this equation, it has a solution also in a complex wave form. And using this equation and substituting the parameters G and rho and psi of each of these layers, you can get what exactly you will receive at the topmost point where you are going to make a construction. So that we define as transfer function, which relates the motion at this point to the motion at the ground surface. So in practice, any earthquake wave, which is a combination of multiple simple harmonic waves, so you can actually use fast Fourier transforms to convert the random earthquake wave to multiple simple harmonic waves. And then say, for example, this red wave is what we have as a dynamic earthquake wave. that can be an addition of multiple simple harmonic waves. This is a simplification we can do using fast Fourier transforms. You can these are available in MATLAB also. And then you multiply this motion with the transfer function to get the final earthquake that can happen at the ground surface. This is what is the site-specific analysis. Now, dynamic analysis is where you put the earthquake pulse in the horizontal and vertical directions on the computational model you have generated, and you analyze for the stresses and deformations. We started cutting the slope now. When we have to cut the slope in all three directions, we followed a top-down approach because we are trying to make foundations on the top first. Otherwise, if you start from bottom, if you go up, all the debris will fall on the already completed foundation. So this is a kind of excavation scheme we follow. And then this is a picture of the excavation. To do this excavation, you cannot use regular blasting because I already told you that you can't cut more slope. So we followed a very systematic scheme of pre-splitting and controlled blasting. For example, if you have a coconut shell, you want to make coconut pieces out of it, there are multiple ways you can extract kernel from it. You can just throw it hard on the ground, hard ground. So it breaks into several pieces. That's what is blasting. But if you want to carefully extract the coconut, what do? You make clean cuts and you extract the coconut. That's what is called pre-splitting. So we have these carefully designed boreholes into which you put the explosive charge and you do delayed detonation through which you make clean cut in the slope. So if there is a slope like this, it's about like 20 meters slope, you have several subsections which have to be cut. The section which is far can be cut through regular blasting, but the section which is close to the final profile has to be cut through pre-splitting, and then you do the stabilization before you move down. So here C11 can be cut through controlled blasting, and after you remove this, pre-splitting, controlled blasting, then you stabilize this portion, then you move down, and this portion can be cut through regular blasting, then you do pre-splitting, controlled blasting and stabilization. So you move on like that to make this complete slope cut. That I am talking about 20 meters. So you can imagine the kind of work involved in making that kind of clean cuts on the slope. So, when we talk about cuts in the portion, what you have seen in the previous picture, it looks very simple. But you imagine what happens in the field, in a condition, climatic condition like that. These cuts and slope stabilization are not easy. So these cuts look like this in reality. And you generate huge amount of debris. So this debris has to be carefully transported, otherwise you are going to silt the river. Next day the project will be stopped because environmental safety is number one priority than infrastructure building in our country. So we have to carefully design these dump yards and transport this debris. And in the middle of the project, railways have developed cold feet about the earthquake signature that is given. So they said this represents close to 7 magnitude earthquake, but we want this bridge to withstand 8 magnitude earthquake. There comes a bigger problem because 7 to 8 is not just a number, right? It's a Richter scale number which has no meaning. But in terms of earthquake energy, it is 32 times more increase in the energy. So everything what you have designed has to be increased by 32 times to take the earthquake load related to 8 magnitude earthquake. So there's a huge escalation in the design anchors and routing what we have to do at the site. Now we have moved almost 20 meters inside the rock. This is the subsurface, and we reached a point of final slope profile. So by the time we reached 20 meters inside, everything changed. Some joints vanished, new joints appeared, and then rock is transforming from dolomite to quartzite. At some places it is completely weathered to shale. So whatever we designed based on the joint parameters and the properties of the rock available on the slope surface are no more valid now. So you need to completely change this design dynamically in real time when the excavation is happening and when the foundations are being constructed. That was a big challenge. To give you a way in which the changes happened, this is a summary of how different joints changed. Some of the joints moved, their inclination changed to 36 degrees. So 36 degrees change in inclination can cause tremendous change in your design. So that's what caused huge delay in the project. Everything has to be redesigned. And we also did global stability analysis. I used fast Lagrangian analysis of continuum. The only reason I went with this is it can take large strains, which are not possible with many other computational models. So that is the only reason. To determine the bearing capacity of the rock, we did a lot of geotechnical investigations, because this is a kind of project where geotechnical investigation is 0.01% or less. We are talking about kilometers. Like Professor Madhav has already told, you depend on these properties and design the whole thing, you are going to end up with huge errors and compromise on the safety. So there are multiple in-situ tests we did and many analysis and non-destructive testing to complement the very less geotechnical investigation that is possible in terms of destructive borehole methods. So some of these tests include in-situ direct shear tests, which I have never seen in my life. Almost half a meter by half a meter rock is cut on the site in the drifts what we made, and then 300 mm height, and you apply vertical stress and shear in situ. It's a very, very big test which gives you C and phi. I mean, you do 100 tests, you get 100 different values. So you cannot completely rely on these tests to determine your bearing capacity. And then huge cyclic plate load tests are carried out where we simulate the train loading, the cyclic train loading onto the realistic plate load test and do the analysis. And then these also we have conducted dilatometer tests. Dilatometer is a kind of instrument which looks like a bat which can be inserted into the ground. You inflate the membrane and the resistance offered by the surrounding subsurface is converted into the shear modulus of the rock. So Professor Ramurthy is standing here. He is called father of rock mechanics in our country. He was supervising these tests, in-situ tests, when we are doing inside this tunnel. There are several sets of rock mass properties we have arrived at the end of these tests. One was given by Professor K.S. Rao's group at IIT Delhi. One was given by our proof consultant Scott Wilson in UK. Other one is generated by ISC itself. So when we went back to railways, these are three sets of properties. Which one to use? They used very diplomatic answer is use all properties and then come up with worst case scenario. But that means that you are doing the analysis 3 times. But like in the project like this, you have to take that kind of effort because you don't want to make any compromise on the safety. So all 3 sets of properties are used in the analysis. Finally, the one which gave the least factor of safety is considered for the design. Now we did the global stability analysis also with all the foundation loads and the rock support anchors that I have designed and made sure that the deformations do not exceed the permissible limits. Now when we have to stabilize with rock anchors, this is a wedge which is created, that the inclination of 2 joints is making wedge here, and in very simple terms what is happening is there is a part of the rock which is getting cut and trying to fall into the valley. When something is falling from some height, your instinct tells you that stop with your hand. Same thing is what we do in terms of rock anchoring. You are stitching this falling wedge into the original slope profile by providing these long steel anchors which will stitch this wedge to the original slope. That's what is anchoring, which we designed, and then this is a realistic picture of how these anchors are stitched into the rock slope. And these machines which are actually hired for this are like, they have few crores per week, their rent to take it to that altitude and use it for stitching of these rock joints. And below the abutments where we are taking maximum support for the arch abutments, you needed higher support, so we have imported these divided bars and did the analysis and design. And while we are anchoring this, we also use this staggered pattern to derive uniform strength of the rock anchors into the slopes. To give you the magnitude of this rock cutting, 3 lakh meter cube of rock is cut from the slopes, and more than 66,000 meters of steel rock anchoring, double corrosion protected steel anchors are inserted into the slopes, and there's also shotcreting, 100 mm shotcreting is done on these slopes. Now when we are trying to make the foundations on the slope, biggest concern is rock is completely jointed, and then Even though you have put rock anchors, it is not going to integrate the rock joints. So the best method to make the ground surface even to stop differential settlements is grouting. We send cement grout into the rock and we make the joints integrated with each other. So we tried this. The first day was a big surprise. 50,000 bags of cement is gone into the rock. We do not know where it is gone because there are interconnected joints inside, and whatever we are pouring, it is finding its own path, and it is exiting, vanishing somewhere into the huge Himalayan slopes. So almost 2 months was spent, on this dilemma, what to do, how to do this grouting. It looks impossible at this point of time. Finally, a very intuitive engineering solution helped. What we did is we mixed color with the grout, and then we used several boreholes to send this the color mixed grout, and we traced the location from which the grout is exiting. So this is a kind of where we can see the color here. So it was easy to go back and reconstruct the structure of the pores inside the joint using these different trials of sending colored grout. We could reconstruct this joint structure inside. Now that we know the joint structure, we had to create a mix which can set within the influence zone of the foundation. So we designed a mix using sodium silicate, which the mix and match trial and error technique, and we did a lot of trials to make sure that the grout sets within the influence zone. And then when we do this grouting, we start from, these are all grout holes what we are seeing for one arch abutment foundation. We start from outer periphery and create a barrier, and then you go inwards. And then at the end, this is the original core which is taken from original slope. You can see that rock quality designation, whatever RMR value is like pathetically low here. And then we could cement these fragments using grouting. And this is like millions of such specimens are tested to make sure that these rocks are jointed and integrated together. And we did the unconfined compressive strength test also. And to make sure further, we also did the multi-channel analysis of surface waves, where this is the original subsurface which has so much of density contrast. It is now homogeneously grouted and you have uniform shear wave velocity at the site. So with that confidence, we started moving and making these foundations. Foundations at this point are very huge, 49 meters in length and 35 meters in width at a depth of 20 meters inside the rock. The height is 47 meters. You can imagine the kind of foundation. If you want to take a picture of this foundation, you have to go a few kilometers far and click a picture. So you can't see, these are like humans standing here or not even like ants in this picture. So, and once we made the foundation, the next step is to erect the arch elements. This is very, very beautiful civil engineering construction, I will tell you. Because we have the river flowing below. We are not able to put any cable cranes in the river to take support for the arch erection. We have to do it from both sides, on both arch abutments we created. So this is kind of a wonderful exercise where you bring the arch elements and erect from both sides and it comes and joins here. So when we are trying to do this, we had to fabricate the world's highest cable cranes here, 128 meters high. Each cable crane can take 20 tons of load at a time. Together they take 35 tons of load. In tandem they can work. So this is the exercise. And the biggest challenge here is, arch on its own is a wonderful, when it is completed, it's an excellent structure. It transmits the loads beautifully, uniformly. But when it is half complete or partially complete, it is most dangerous because it is very unstable. It needs support to keep it in its original position. So that support we have to take from backstays which are connected to this arch portions. But those backstays also need support. So they are supported on the foundations that we have just built. When you put these backstays, it is trying to pull the foundation. There's an uplift. To counteract that uplift forces, we had to redesign these pre-stressed anchors to put these foundations on the slope. Now another complexity is when the arch is moving from this point to the higher altitudes, the same backstays also move from one point to the other, and the support of foundation also has to go up and up. So different foundations have to progressively be made available for putting these backstays. So that was done, and like a bud it started, and like a flower it bloomed, this arch, you can see this. And when these segments come together, these are not magnets to stick to each other, right? We need to do a lot of engineering adjustment to make that arch perfect. So that we call golden joint. That golden joint was completed on the 75th Independence Day of India. So there's a huge celebration on the site. You can imagine that there's a kind of a lot of happiness at the site because we have completed the golden joint. The railway minister also was present on that day and he said, "Ab to bridge banega." So till that time, you know, everyone was very scared about whether we'll be able to complete this project. Once this golden joint is completed, then superstructure was simple. Steel elements are brought, the deck elements, and they are assembled at the site. So for the first time, Indian Railways has done this incremental launching of superstructure on both circular and transition curves. And when later in 2017, when I visited, most of the things are completed. So I realized that there is a lot of overburden which is still lying there. Though it doesn't give any problem to the design, we thought that this is important to stabilize this as well for long-term erosion control and permanent safety of the structure. So I have designed some slope stabilization measures for these portions which are exposed also. And then there's also kind of paths which are created by the rainwater in the rainy season. Rain can be very harsh in Jammu sometimes. So there are nalas automatically created. So for that also I've created these cladding walls much later in 2018-19 kind of a thing. And when I went later in 2021, I could see that all the stabilization measures which we have suggested are implemented at the site. And then when I go back from 2005 to now, like how the hills have transformed. We started on native hills like this, there was nothing on them. And then we have started cutting the slopes, and then we started erecting these cable cranes, and slowly the bridge has started coming. It has seen several stages of completion, and finally it is standing tall at 359 meters above the river. So this is a kind of transformation to the entire Jammu and Kashmir region. Can you click on the small video to give you the magnitude of the bridge for people who have not seen this already? Call this project civil engineering above the clouds, because in winter if you travel in this train, clouds are below your feet. So it's a kind of a civil engineering marvel to show to the world that our engineering excellence is this much that we can build a world's highest railway bridge at our Himalayas. The second highest is in China, which is half the height of this bridge. So as of now we are on top of the world in terms of railway infrastructure. And this is last year. My life has turned into a drama after that, all of you know. But it's a proud moment for the country, and I also watched it on TV and I was full of tears because I got goosebumps how the train is traveling on that arch, and it brought back memories of my young days. I come from a very small village in Andhra Pradesh, and then to be a part of this project is a big fortune, and I owe it to Indian Railways and everyone who has helped in construction of this bridge. So we were very happy, and some important features I want to tell you is all materials are custom made here. Minus 10 degrees to 40 degrees temperature change the materials can take. Bridge can take wind loads up to 266 kilometers per hour, and then all steel used is corrosion protected. And most important civil engineering redundancy is, even if you remove one complete pier or one critical arch segment, you can still run the train on the bridge. And the bridge is blast proof. It is very close to line of control. So DRDO has helped in making the bridge blast proof. If you drop a bomb, it will be safe. So all these important design features are part of this bridge. And in recent floods in Jammu, this is very important. What change this bridge has brought into Jammu and Kashmir? All roads were closed. This is the only trail line through which the government has transported flood material and flood victims from upper to lower regions and lower to upper regions. And also the entire agricultural produce of Jammu and Kashmir was at stake because of floods. They are getting rotten. Millions of tons of apples are moved through apple express trains created by Indian Railways, and the saffron, the mustard oil, everything which is produced in Jammu Kashmir can reach Delhi and other regions within days now, 1 or 2 days. So that is what we call as sustainability, not the construction. In terms of all these changes, socio-economic transformation of this region, I would call this project as one of the most important projects of Indian infrastructure. And I salute everyone who has contributed to this bridge, and I congratulate India for completing this wonderful infrastructural project. Thank you so much for your support.
Post-construction studies are being done?
Yes, this is a kind of project where regular maintenance is important. All those rock anchors are pre-stressed rock anchors. We need to maintain that pre-stress in the rock anchor. So continuous maintenance is done by Indian Railways, and also there is a lot of instrumentation through which we get data all the time. Even load cell data, all instrumentation data. In regular period we get that, and we analyze to make sure that everything is safe. Sir.
Can you hear me? If you think sending a man to Mars is a great thing, I would rather say this is even better. For geotechnical, what we have been doing, she has managed to get the attention of the society. To me, that's very important.
Thank you so much. Thank you so much.
Participants. So, I don't think there will be questions because
Sir.
so thank you, Professor Madhavilata, for your excellent involved in building the highest railway bridge in the world, right? Chenab bridge. So all of us are very happy that we all have close association with you, and we feel proud to say that you are involved in such important project. So on behalf of Andhra University, Department of Civil Engineering, and ITS Visakhapatnam, I thank you very much for accepting the invitation, for coming over here and delivering this topic.
It's a pleasure.
Earlier also, you have obliged by giving a webinar immediately after inauguration of the bridge drive. Thank you all. So we have two wonderful lectures in the session. So we will break for tea now. So try to complete your tea as quickly as possible within 10 minutes and come back. So you have listened to the student of Professor Rajgopal. So next is his turn. So her guide will be delivering a lecture. He will also speak about foundation issues of some of the bridges constructed near to Chenab bridge. So thank you all for your participation. I am not saying active participation because no questions we are receiving. Right, the speakers will be happy if you post some questions. Right, it indicates that you are active and following what they are telling. But as far as the two lectures are concerned, the things are very clear. So on your behalf, I say that everything is clear. So no questions were asked. So try to be active in committee. Thank you all. Join complete is arranged also. Before that, we would like to present a small memento as appreciation. Our team is arranged also.
geomembrane, geocells and so on. And this slide conceptually explains how we can construct very steep slopes, and especially in the urban areas, whenever you want to widen a road, you need to procure extra land. And but in the urban areas, we have so many built-up areas that we cannot procure the land. And instead of translating horizontally, we can make our slopes steeper and then add an extra lane. And that was actually the most used application for the geosynthetics when the technology came in the 60s and early 70s. But now we have many more applications. And just to show you some applications, I'm not going to go into very deep into this. In the 1990s, India built an airport in Sikkim, that is in Pakyong, that is on the outskirts of Gangtok. And this airport is also strategic because we didn't have any connection there during most of the years because of the heavy rainfall or heavy snow, and they needed air transport, and it's also close to Chinese border. And so for constructing this, actually it's a highly geologically active area. It is zone 5 as per the IS 1893, and for constructing a very long, this runway is about 3.5 kilometers. For constructing it, what they have done is they have cut down the hill and then they fill the valley, because otherwise you cannot get land, you cannot get a level ground where you can build any runway like this. And when you cut a slope, especially a stable slope with vegetation, you need to deal with erosion and then all kinds of issues. And then so this soil was reused in constructing a very steep embankment or a slope here. But then what do you do with all the water? Because the water is going to infiltrate into the ground and then flow through the soil. And for that, what we do is we call this as a permeable facing. This is it's a gabion mesh made of either we can make it out of metal, twisted metal, or with geosynthetic. And this wall, right from bottom to top, is about 70 meters. And this was filled with stone, so that any water that infiltrates can flow without any obstruction. Because we cannot build any concrete wall. Because if you build a concrete wall, all the water is going to stagnate. That will add an extra hydrostatic pressure. And imagine an earthquake happening. Earthquake of about intensity 8 or more than 7 happening at this place. You have such a huge mass of concrete, and when it is subjected to inertial action, you will have a lot of forces. And whereas this structure is flexible and it can adapt, it can readjust to the situation, and we can allow much larger deformations. And another example of this is the Shillong bypass road. It's actually, it is one of the another difficult area where rainfall is very, very heavy, almost 3 to 4 meters every year. And here you see the road being constructed and then vegetated slope. And in all these constructions, more than the slope, more than the internal stability, we need to take care of external, like at the surface. What happens at the surface? And we go the route of vegetation, because if you are able to grow the vegetation, there is nothing better than that, because the vegetation, the roots of the vegetation can hold the soil together. And how we do that is like this. We can put some seeding during the construction, and then the soil that we use in that part is different from the remaining soil. And this is another example of very tall construction. This is the Kannur International Airport. And these are all the different type of retaining walls that big all around. So coming back to this project, actually our involvement started much later. It started only in 2017 when I got a phone call, and then I asked how did you know. He happened to have watched my video lectures and video lectures, and then they contacted us. And initially our involvement was only the development of specifications. Actually, any project, the specifications are very, very important, especially in the government projects, because you need to have a level playing field so that everybody can bid for the project and get the project. And in this type of project, how do we develop the specifications? So they gave us that their design life should be at least 100 years, 120 years. In fact, all the geosynthetics, they are designed for 120 years. And then the fill material that they are going to use is going to be only tunnel mud. Tunnel mud is actually it's a debris from the stones and other material that they get from tunnels. And this is what you heard just recently, and this height of the bridge is more than the Eiffel Tower. And there is another iconic bridge, that is the Anzikard railway bridge. It's the first cable-stayed bridge in India. Both of them are marvelous structures. And it's actually the geology, already it was Madhav that has explained, it's very, very complicated geology. You can see these faults, and even while we were traveling, there was a landslide. But it got cleared within about half an hour, because we were afraid. Actually, it is that time it was very active for the wrong reasons, and we had to reach our place of stay before dark. And then when we asked the driver, he said, no problem, within half an hour it will be cleared, because these are all under defense control. The army people came, they cleared the road within half an hour. And you can see actually at any time this rock mass could slide onto the road. That was the situation. And you can see the deep valleys, and this is one of the tunnels, and this is me, that's me, and this is Mr. Singh, who invited us. This is Naidu Valley, Naidu, who was also part of the team. And this data you've already seen. Actually, the beauty is the majority of the railway line was in tunnels. The total length of this was about 272, Udhampur to Lonavala, and this combined length of the tunnels is about 119, and the longest tunnel is about 12 kilometers. And this was when we were doing the work, there was no railway track, and so we used to go through the tunnels. And one fine, like the driver took a wrong turn, he went into the wrong tunnel. Almost we drove 2 kilometers, there was a dead end. Because these are all like for emergency purpose, they make extra detours. And then we had to drive back for 2 kilometers. That was really scary because so dark, and then luckily we were able to come out. And this is actually see the entire area is geologically very active, and it's young geological formation, and it's seismically active zone 5, and the challenge here is to use the tunnel mark. If you touch with your hands, you could cut your hands. How sharp the materials were, and then this we have to use the geomaterials, and so that's a challenge. And we were given 3 bridge locations, 40, 41, and 42. Actually, these 3 are the most critical ones because the height is almost 50 meters. All the other bridges are low height, hardly 5-10 meters. And the geosynthetic reinforcement plus the shoring. Actually, I've already seen the nailing technology, and the reinforcement connected to these nails is called shoring. And so this technology was used in some places. And this particular table is from IIT Roorkee. They have done all the testing of the materials, and then all the geological data and other supplementary data was from them. And you can see the tunnel mud. It's mostly gravel size particles, 90%, and then here it's almost 67%. And then fines content is very low. And this is one of the tunnels through which we traveled. And the geology is very, very complicated. Actually, I've just extracted something from those reports. You can see the joint spacing, and then the different type of bedding joints. And luckily, in our locations, there were not too many joints. And these are some of the specifications. Actually, this the design is not very simple. We can do some hand calculations, like that's the minimum, because if we do the hand calculations, we understand the mechanism and we get the feel. Because if you do a software analysis, we don't know what the software is doing. And then the other thing is they wanted all the designs to be vetted by finite element analysis by using the Praxis program. And proof checking is as per the BS code, and then this FHCWA 2009. And these 2 codes are the most advanced. And now we have the Indian Code of Practice. About 1 month back, we had a workshop on the Code of Practice on the geosynthetics in the same way. And now we are actually in the afternoon today at 3 o'clock we have a meeting to discuss how to translate that for the highways, because the code that was developed was for the highways. And from this afternoon we are working on adapting the code for the highway projects. And so actually I'm not going to go into the details because the time is not sufficient. And then I started preparing my presentation only yesterday, and I didn't realize that it's not so easy. But so you can see the general site conditions. It was really it was mostly inaccessible because we had to walk. Because the roads were there, but then these are all on the valley side, so we had to walk and reach the place. And there is a requirement that any debris that is generated has to be safely disposed, because they don't want any contamination of the rivers or any other valleys. And these are all the different components. Unfortunately, what happened is we finalized the specifications only in 2018, and it's not so easy. It took more than 1 year, and then the construction started in 2019, very slowly, and by the time the construction was it took place, we had the COVID, and unfortunately we could not visit the site. Then after that, 2022, I was retiring, so I didn't have a chance to go. And so my pictures are all from whatever they sent. That's not good, but I have many more pictures. And the specifications were very, very stringent. And then we recommended a particular product. I'll show that product. And the requirement is, see, all these are geosynthetic products, polymeric products. They undergo a lot of damages and creep. And then the most damage that we can expect is the construction-induced damage. Just imagine you lay a plastic sheet and dump soil. Even if you dump soil, you have some damage because there will be some small particles. But here we are dealing with tunnel work with gravel-sized particles. 90% of the soil is gravel-sized particles, and we can expect a lot of damage. So, considering all these factors and the long-term performance, we recommended only polyester-based geosynthetics, and we did not. And because that's the polyester has the least creep factor, and then one product that we recommended had very low damage factor, and then they floated, and then we had meetings, all video meetings, and we selected, and then the other vendors, they came back. They say, what's wrong if their damage factor is 1.3, 1.4? Like we said, we limit the damage factor only to 1.1. And their products, they had much higher, in one case 1.4. Then they said they'll supply a very high strength geosynthetic, so that even after using a very high damage factor, their minimum strength will still be more than what is required for the design. That was a very difficult situation. And then we said, can you satisfy the reliability? Because there is another thing called reliability, like how safe. See, with say you place a reinforcement, and that will have a damage of almost 40%. 1.4 is 40% damage. So in the laboratory, you can damage a product and then test, it will still be good. But in reality, in the ground, we did not know. And so there were so many discussions, and even after I retired, there were still some queries under RTI. Somebody wrote a letter to Director IIT Madras that they have not recommended some products, and they were biased. And in fact, the spec document is very, very, has to be carefully developed with all legal wording, so that you do not, by mistake, even if you favor any vendor by mistake, that could be a problem. And we made it so open that anybody can bid for the project. So this, all types of precautions were taken to allow for reinforcement and then the drainage. See, for the vegetation, coir is the best means for growth of vegetation, because that's a biologically degradable product. And coir Advantage is it can hold the water, moisture, and then as it is degrading, it will provide some biological the venue for the plants to grow. And so all these slopes were covered with thick coir mat. And sometimes these coir mats, they can be pre-seeded. So at the factory itself, when they make along with seeds, and it comes like a carpet. You just bring it and unroll it on your side. Then the other thing is the drainage. What do you do with, how do you handle the rainwater? And frequently we put some interceptors, that is the drainage medium. And previously we were only using aggregate medium to trap the water and lead it in a preferential direction. And nowadays we use the drainage, the composites, the geosynthetic drainage composites. And we have tested all these products. We had recommended the drainage capacity. Actually this, when we think of it, we can test in several ways in the lab and get different results. See, if we test with flexible, inside a flexible medium, we get a low drainage capacity, and some of the vendors, what they have done is, they have supplied us the drainage properties with hard surface on both top and bottom. That we call as hard to hard and hard to soft. But what we recommended is with soft ground on both sides. Like that means that they have to put some plastic foam above the geosynthetic and below the geosynthetic and do the testing. And some vendors very intelligently showed very high flow capacity, but then with the wrong boundary conditions. So that was another thing that we had to carefully evaluate and then say that no, we will not accept that result. And see, all the analysis are very conceptually what a third year BTech student will understand. We go through the slip circle analysis, and then the sliding analysis, and then when it comes to retaining walls or very steep slopes, you consider sliding, overturning, bearing capacity, and all these things. These are all very, very simple calculations. And here you see the slip circle analysis, and then the sliding analysis. And then the reinforcement that we recommended was the stick type reinforcement, polymeric custom. Actually, it is made of polyester, and it comes in clusters and with a very thick coating. And we have done the field testing of this in the site. Actually, we could not go to Kashmir for this, but just before this, we had another experience with Andhra International Airport, and this material was buried in the soil, and it was compacted under 20-ton vibro roller. And we have tested, we exhumed the samples, and then when we tested in the lab, the damage factor was hardly 1.05. Very, very low. And with tunnel mud, so 1.08 or something. It's very, very low. And say if it is, if the damage factor is low, its reliability is much better. And you supply this product in rolls like this. And then, so actually these are, sorry, I didn't arrange them. This is at one bridge site. And then at one of the sites, you can see actually there was not enough land space for providing reinforcement of sufficient length, and so this slope was stabilized by use of a combination of soil nails or rock anchors, and then these rock anchors were connected to the reinforcement layers, and this we call as the shoring technique. It's a little bit more complicated, and we require only finite element analysis because none of the limit equilibrium programs can handle this. And the toe is always a problem in all these embankments, and the toe was stabilized by using the Gabion meshes filled with stone. I showed that. This is it. So actually this the toe was stabilized by using this Gabions. And periodically we have to put some drainage outlets so that all the water that's collected inside the soil is led outside. These pictures are not from Kashmir, these are from Kannur International Airport. And we dump the soil and then do the spreading. The spreading also is not so easy because these very, very stiff materials, and you need force of some people, and what we do is we stretch them, and then we put some steel hooks and attach them to the ground, and then spread some soil, and then do the compaction. So this compaction, this is the spreader. The soil is dumped and it's spread, and then we water and then do the compaction. And see, any construction during the rains, you have to be careful because although it is designed, but it's not designed for partial rain, because only after it is fully constructed it will have a strength. And so adequate care was taken to prevent any rainwater from seeping into the embankment fill. And this is from Kannur International Airport. See, this is the concept, that is what I was showing. We call it as a chimney drain. Yeah, so this particular one is from Vijayawada, Kanadurga temple. And actually the chimney drain is very simple. We make a vertical wall with stones, and the stones being larger size particles, they have more permeability. The water can flow, and we construct this type of chimney drains. The water gets collected, and then it flows along the preferential path and then comes out. And this is the pipe that conveys the water out. Then whenever we have any surface to treat at the railway track level, we have to also have an aggregate layer to lead the water out. And then this was covered with geomembrane to prevent the water from seeping in. And the surface treatment, actually it is very important in any of these constructions, because these are all very tall structures. We are dealing with a 50-meter slope at almost 70 degrees. Not in one step, but in multiple steps. And so this was supported by steel mesh at the surface, and then the coir mat, and then vegetation. Like after the vegetation grows, we do not require any coir, because after the roots of the plants, they can take care. And this is another location where they had a pillar at bridge number 87. It's very, very high pillar, and just next to that There's a very steep cut, and there it was not possible to have any geosynthetic wall, and this entire length was supported by rock anchors, and then we do the spray concrete on the surface, and actually the analysis was done by different programs. All the finite element analysis was done by Plaxis program, and for slope stability analysis we used the slide, and then we used Lisa, and then we used Geoslope, and then this vendor, they had some McAfee Nextars program. This was very good. This particular slide is, this particular picture is from the program slide. So this Sangalram tunnel, actually I just put it, this is from Amtron's magazine. This is almost 12 kilometers long tunnel, one of the longest in Indian railways. And you can see the site geology. It's very, very fragile rock. It's the end of my presentation. It's a brief presentation, and you can see all the students. One is IIT. So everyone in IIT are all very intelligent, including monkeys. They love to grab the things from people and drink, and this particular one is enjoying the coke. So thank you very much, and students are making another presentation. Within the 2 days, this is the best time. And so whatever Madhavalata helped constructing, that's not enough. You need railway track to run through, and the geology is extremely complicated. You need to understand, and you need to do the analysis by different methods, because that's the only way to understand the process mechanism that come out into that. So thank you. We give lunch only for those students who ask questions, then they will ask. No lunch for the students who don't ask questions. So no lunch. They will skip lunch.
Thank you so much, sir, for this wonderful presentation. It's my privilege when Centenary and Delhi sir asked me to conclude my own supervisor staff. So I would want to tell you one small story. Like when I joined IIT Madras, I was so interested in working with him. No, from my village I took all my things and went for the interview. I was so sure that I'll get an admission in IIT Madras. I didn't know that there is a possibility that I may not get admission. Then I went and they said, you will know the result next week. I don't know what to do with my stuff. I took the admission fee also in envelope and went. So I went to sir, this is the situation, can you keep it in your Almera? Then he is like, no, I can't handle money. And I said, sir, I came alone, I don't know what to do. So then he said like, okay, I am sealing it in front of you, putting your name on it, putting here in my Almera. So when you come back, if you get an admission, I'll give it. If you don't get an admission, I don't know, you have to figure out how to take this money. So that is the kind of, person he is. And then I got admission and I went and they told your supervisor is Professor Krishna Swami. Then I am like, what is this? I don't know, I wanted to work I cried, sir, you are not my guide. Then he consoled, he said that he is officially one of the supervisors, I am your second supervisor, but I am the one you will work on geocells, my favorite problem. So that gave me kind of consolation. Then rest is history. All the love for the research, what he talked about, working on lab, soft soils, fully mud. I now, after my PhD, I never touched soft soils. Most of my work is on sands. So those were wonderful days when I look back. And today I also, went back into my PhD journey. There are two computers in this room, one for him, one for me. And I was working only in his room because he is very insecure that if I go out, I will disappear. So when I left IIT Madras, on that day I went and cried at my computer also because it was so sentimental. Right, 5 years I was sitting next to him, working on the computer. So those are wonderful days. He has not lost 1 inch of his curiosity and love for science. I realized that. That is what he instilled in every student of his. Most of his students are faculty in IITs, IISc and Andhra University. Sirisha is here. We are all indebted to him to our, with utmost respect. I thank him and I am sure Geotechnical Journal as associate editor. I am going to only pray for Meher Baba and give him advisor. Then I totally believed it, but he proved himself wrong. He still has service to do to the country, and we are very fortunate to have him teaching here at Andhra University. Thank you so much.
I've not seen her being absent. Only for 2-3 days she used to go during weekend to her home, very close to Chenab, and that's the dedication that she had. Thank you very much. It was wonderful. We also learned, like we all learn only because but we pretend that we all learn. That's the beauty of it. Thank you very much, sir, for your wonderful lecture covering various issues related to stability of mangroves in various soil conditions. Next we will move on.
Kindly, I request Professor Amma Malo sir to hand over a memento of the
Characterization of expansive soils by Professor T. Thiagaraj from IIT Madras. Dr. T. Thiagaraj is a professor of civil engineering at Indian Institute of Technology, Madras. He obtained his BE from Osmania University and MSc and PhD in Geotechnical Engineering from Indian Institute of Science, Bangalore. He is actively engaged in teaching, research and consultancy at IIT Madras. His research interests include unsaturated soil behavior, ground development, geo-environmental engineering, and use of waste materials. He has supervised 10 doctoral theses and published over 50 papers in reputed international and national journals. Dr. Thiagaraj received the prestigious IGS Professor Dinesh Mohan Award in 2016 for excellence in geotechnical practices. Now I request sir to go on with the lecture.
Good afternoon. I feel very humbled listening to lectures by Mr. Madhav and Madhav Madam and Rajgopal sir. My topic will be a very small topic, which is a laboratory study on the not a field studies. It is based mainly on the expansive soils. So it will be maybe interesting to the students who are present here. So we have worked something recently on the expansive soil and developed a method of characterization of the expansive soil that is called as desiccated state freestyle method. Right, so that I will be presenting. Before that, let me thank the organizers for giving me this opportunity. Thank you very much, Professor Reddy and others in the organizing committee. So I will not stand in between your lunch and these things. I will try to be very as fast as possible. This is the organizational presentation. I will present something on the desiccated state freestyle method for expansive soil, and I will talk something on lime precipitation technique. So with these two things, I will be concluding. I will not dwell much on it. You know very well about the expansive soils. So they are characterized by very high swell and shrink characteristics, primarily because of the Montemorillite mineral. Right, so they undergo several meters of swelling in some cases, and most of the typical field heat will be somewhere up to 300 mm. And they exert very high pressures of as much as 1000 kPa, but in regularly what we encounter in India is around 200 to 300 kPa. Right, so they cause severe distress to lightly loaded structures such as a G+1 structure or just ground floor and pavements is the lightly loaded structure. So those are some of the examples, and cost of repairs are very high. So in view of that, we need methods to characterize it and to tweak it before we do any new project. So I need not insist on the spread of expansive soils. It's spread in 40 countries. Right, so and it covers about 20% of our land area in India. Right, so in Andhra Pradesh also we have this expansive soil, and the cost of damage for repairing in UK, some numbers are given very old. I don't have a recent thing from abroad, so it is somewhere in 15 billion in US alone and 350 million pounds in 2002 in UK. So that's the nature of it. So repairing cost is very high when compared with the initial cost. So you can see the distress for the simple buildings. You can see that a huge crack even before the building is occupied. On the right side you can see a taxiway, a lot of longitudinal cracks, distress. So this is a railway track. You can see a lot of undulations. And this is a typical ground floor building. You can see diagonal crack and also separation of the wall. And this is also taken some time back by being in Saudi Arabia. You can see a new building even before it is inaugurated, a lot of cracks because of expansive soil. It has a compound wall. And you can see here a lot of undulations in the pavement. And of course, the slab, grade slab is an issue if you have swelling. Right, so I think I need not dwell much on it. As I said, spectite or monochromite is a clay mineral which causes a lot of distress because of the sludging potentials due to seasonal moisture contents in rainy and dry seasons. Right, so typically spectites are characterized with very high divalent ions such as calcium ions and magnesium ions when compared with the monovalent ions. And we know that clay particles will have negative charge on their faces, and on the edges it will have positive charges. Because of that, you can see water forms clay easily. So clay particle is very negligible in comparison with the water that cracks because of the negative charge. I just wanted to show that. Right. So and we have many methods that are there which are developed over a long period of time. We can categorize them as both qualitative and quantitative methods. Quantitative methods are odometer tests, wherein we do the direct
testing in the odometers, swell potential and swell pressure evaluation, and whereas quantitative methods like index, some of the free swell index, right, free swell test, modified free swell index, free swell ratio, so many tests are there, liquid limit, shrinkage limit, right, plasticity index, activity test, and polarity. These are all qualitative ones, so we cannot quantify them, we can, right, so degree of expansivity we can categorize them, but we will not be able to quantify them. And other ones are, we get to know, we can quantify the mineral that is present, based on that we can say the soils are swelling. I want to dwell maybe 30 seconds or 1 minute on this slide. So you can see that in the quantitative methods, we have interval limits and activity. So you know about all those methods. And this is the chart wherein you have a plasticity chart. Right, you are very well aware of the A line. So A line, only we look at it, but you need to always plot the U line. In any report, if you see, you will only see the A line, but U line you will not see. So this simple plasticity chart, a second list plasticity chart, we get to know a lot of information. For example, just below the A line, pile nets will be there, and just above that A line, inlights will be there, and U line, right? So it is similar to the A line, 0.9 times of liquid limit minus 8%. So that line, just below that, all multiple like stick type groups will fall there. So without even doing an elaborate qualitative or quantitative test, with just index test, you will be able to find out what are the problems. And further, we have many classifications like such as with colloidal content, with liquid limit, plasticity index, shrinkage index, and so on. But they suffer from some disadvantages. For example, liquid limit is just based on the diffuse double layer thickness, and it is a strength-based test, you know that. Similarly, shrinkage limit, it depends on gradation and initial moisture content of samples. Colloidal content, swelling depends on amount of expanding clay minerals rather than the percentage of space. Right. So since we have many methods, but they are all only qualitative one, and many people in the field still rely upon the free swell test. So this free swell test comes in a lot of research has been done. You can see that Oates and Gibbs in 1956 he started that. Right, so he gave the final volume minus initial volume by initial volume. Further, IS code adapts this differential free swell, that is VD minus VK by VK, where VD is the volume, sediment volume and distilled water, where VK is the sediment volume in kerosene. Right, so Sridharan et al. He developed the free swell, he said that for granulate soils, free swell index is negative. And then Sivapula, he modified it. Instead of taking VK in the kerosene, he has taken the volume of solids as a reference. And Sridharan et al. Also gave, Sridharan and Prakash, they gave a very useful index test that is called as free swell ratio. Many people do not use, but you can try using this. It is simple ratio of volume of sediment in distilled water to that of kerosene. With this, you will come to know what type of mineral is there, what is the swelling potential. So these are all tests I've just put up there. You are very familiar, we use that in IS code also, but they suffer from the disadvantages. So what are those? I think mainly they do not take into the field density or water content into consideration. Further, structure is also very important, which is brought up by Lambe. So it also, the structure also, it is not included in the simple free swell test. Right? So I was telling about the modified free swell index given by Sridharan and Prakash. You can see that we can simply use that value. So high, medium, high swelling is, if the free swell ratio is just more than 2, we can say that they are high or very high. So as I said, they are on the powdered samples, all the free swell tests. Right, so the effect of placement, density or water content are not incorporated into the free swell test. Right, so this is how the Sridharan gave based on the free swell ratio. He gave tentative minerals that are present. If it is 1.5 and above, the major mineral will be not more weight, otherwise some other minerals. I am not going into details. I am just going fast. So typically what is swell potential? So if you have a sample from the field or from the lab which is compacted to maximum dry density and optimum moisture content, whatever is the heat that we observe in the laboratory odometer, that is the swell potential, and swell pressure is the pressure that is required. So in order to not to allow any volume change, is the swell pressure, you know very well about it. Just want to show the numbers here. If you have pure clay minerals, right? So you can see that 1 mole night swelling will be, swell potential will be 1500. That is the range. But in nature we don't have pure one, so we have mixed minerals. You can see that different classifications are available. So given by moles and gips, so which is measured from dry to saturated state. But whereas Seed et al. He gave from compacted to saturated state, and Chen he gave volume change measured at 50 kPa CT. You can see the classification. These values are high, these values are low because of the high surcharge and from the state from which it is done. Of course, a lot of correlations are available, so I am not going it, I am skipping. And we have different methods to analyze swell pressure, right? So no swell method, I think I will going very fast. So we can have free swell and load method. From there we can get the swell pressure, or we can do free tests. This is called as swell under load, and wherever it cuts, that gives a swell pressure, and no volume change. It can be done in the odometer or using a triaxial frame, that also gives. So among them, the free swell and load is high value because of the fully developed double layers, but whereas the swell under load will be the lower value because it will not allow diffusible layers to develop very fully. Right, so let me skip some of those slides. Right, so main problem when you do testing in the laboratory or the laboratory samples is the imperviousness of the soil. So it may take long time. So if you introduce some holes in the sample that will accelerate like sand rains, that can be used to, I have cut down some of the slides with how to accelerate the testing methods. So I am not discussing that aspect in this. Okay, I come to my method. So this is what my interest in presenting. Whatever I presented so far is the known from the literature. So you can see here, this is the proposing a new method called as desiccated state free swell. So wherein we use a very simple steam ring. We can compact the sample using the spacer and eject it and get a sample something like this. So this sample size is just equivalent to the top 100 ml jar that we use for the free swell. That is the diameter. And thickness is similar to the top 10 grams of soil if you pour. What will be the height of that sediment? So that is the thickness of the sample. So some details are given here. And this paper is recently published in Bulletin of Engineering Geology. You can refer to it for more details. We have done a detailed study on 20 soils, right? So taken from different places, expansive soils, non-expansive soils. You can see that I am not going into all the details. You can plasticity index somewhere from 77 and plasticity index up to 50. So wide range of plasticity soils are used for the testing. And then for a particular soil, you can see that this is the compaction curve. These are the placement conditions. Because why the free swell method that we use, we do it on the powder, right? That powder, only 10 grams of soils, two soil samples will take. One in the distilled water jars, one in the kerosene, and that we use it. Structure is broken and placement condition is broken. So as I said, we are going to take an undisturbed sample from the field where the density is maintained and water content is maintained and the structure is maintained. Or if you compact in the laboratory also we can use it. So these are the compaction conditions that we have used. And then these are the swell potentials of different soils. Covered very high swelling soil to non-swelling soils also, you can see from that graph. And here are the interesting results. You can see that with water content, obviously on the compacted specimens, the free swell with the increase in water content is particular density it decreases. But when we do the same test on a desiccated sample, right, so which is compacted to certain water content, but desiccated before we do the test. So when you desiccate it, you can see that the free swell, desiccated free swell increases with the water content. It's very opposite to that of this because of the initial state. Higher the water content, higher will be the desiccated, lower will be the desiccated volume, then higher will be the swelling. So for that reason, that is the behavior. And then the further, this is how we have defined the desiccated free swell index. So this is where Vs is the swollen volume, Vd is the desiccated sample volume. Right, so we can do the test on a desiccated sample where we get the desiccated state free swell index, or simple free swell index from the compacted state where the reference will be the compacted volume. Now, we further evaluated the parametric study with the density. You can see that with increasing density, desiccated state free swell index increases, but whereas for the tile line, irrespective of the density, there is no volume change. So, as there is a nice correlation here. So, we have varied for a given soil, we have varied the sand percentage, and then we found that odometer swell potential is reducing with the increasing sand content. It is very well known. But our desiccated free swell index, which is developed newly, that also it is very matching along with that similar behavior was there. What I want to say is desiccated free swell is also decreasing along with the increase in the sand content. So that is not. So now based on that, we try to develop a chart and a new classification chart. So we tried with different things: with desiccated free swell with liquid limit, desiccated free swell with plasticity index, and free swell index. Right. So we can see that there is a correlation when the scatter is more. When here we will plot with the desiccated free swell with the actual orometer swell potential that are determined, it is fitting very well. So based on this, we have proposed this chart, right? So you can see that this small portion is low, medium, high, and very high different shading portions. You can see that that is a chart that we have here, and you can see that the R square is high in case of desiccated free swell with respect to the swell potential. And this is what is the U degree of soil expansion based on the desiccated free swell index. You can see that the degree of classification from low to very high. You can see the desiccated free swell based on the swell potential is less than 75. We said it can be low. These are the ranges based on the swell potential. But based on the liquid limit, plasticity index, and the free swell based on the desiccated thing, these are the values. So you can use these values if you want to classify based on the desiccated free swell index. Then further we thought whatever we have developed, so we have put up, we were not happy with that chart, and we have developed this, and you can see that with the desiccated volume, that is shrunken volume versus desiccated state free swell, we have put all our results there, and then we have come up with these three zones. So zone 1 is low, right? So zone 2 is medium, and zone 3 is high swell. And then further we validated by taking some samples, taking small undisturbed sample, just push with your hand, bring it to the lab and make the specimen within no time. Small specimen about just greater than 1 inch, equivalent to the top diameter of the free swell jar, as I said. So and then we did some testing on all these soils, and whatever the classification that is done by the actual orometer swell potentials or swell pressures, so that is plotted here, and it is very well matching with the orometer test results. So pretty much. So this is the advantage of this. So we have used about 10 undisturbed samples to validate the field. So that is what is a method which takes into account the field placement condition. So we should not look the soil as a polar or individual particle. So we have considered the field structure, field water content and field density, and we can see whether the soil will, what will be the potential, whether it is expansive or not. All that can be found by this modified or DSM method, differential desiccated state physical method. So that is the problem. Then I will introduce maybe 10 more minutes I will take. I do not want to sit in between your lunch. I want to introduce one small new concept for the stabilization of soil, which is aligned with the lime stabilization. So you know very well for the expansive soils, right? So the chemical stabilization is the best method. So among the chemical stabilization methods, we use lime extensively because it's of its very well known properties, right? So modifying properties. So that's the thing. And this lime, when it is mixed physically, it is effective because of two reactions: short-term reactions and long-term pozzolanic reactions, right? So I will just highlight what is pozzolanic reactions. When we add lime, the pH of the environment increases to greater than 12. So under that high pH, the silica and alumina in the clay lattice dissolves and reacts with the available calcium and forms calcium silicate gel or calcium aluminate gel, and that gets hardens, and then that reactions we call it as pozzolanic reaction. Whereas the modification reactions such as flocculation, right? So ion exchange, alteration of Coulomb electrical forces, those happen immediately after mixing the soils. Right? You can see that the solubility of whenever it's a different pH, you can see that the silica and alumina, so these are the lines, they around pH about 9 to 12, so the resolution is very high, right? So that is where the environment about pH of 9 to 12 is conducive for the pozzolanic reactions to happen. Whatever the calcium-based stabilization that we do, we should see that the pH level rises to somewhere 9 to 12. So these are all very low value content I'm skipping. So we can talk about the stabilization in the field in two categories: shallow stabilization or deep stabilization. Shallow stabilization is by physical mixing using rotavator or different types of equipments, right? So I will just show some of them. We can fill and we can apply the dry form or slurry form, right, and then mix it and then water it and then compact. So I just skipped it. I want to highlight one point. In the lab, so when you mix the lime, it will be very effective. But in the field, it is very difficult to apply the lime in the field because of impervious nature of the clay soil, right? So and further, this active zone is very important for the expansive soils, right? So what is active zone? The dry season and wet season water contents, they vary. You can see the variation is very high at the surface. Dry season almost water content becomes zero and becomes flush shade. And as you go deeper, the variation becomes reduced. And after certain depth, there is no variation. Means if you have a foundation, you place in this stable zone where the variation is not there, there is no issue. But if you place any structure in this active zone, you will have problems. So we need to stabilize this active soil. If at all we need to do some stabilization. Okay. And just given these slides, I think I do not want to sit in between lines. When you can see that active zone in India is about, as per codes, it's 1.5, right? So, but in Madhya Pradesh it is reported as 3 to 3.5. In Colorado it is 16 meters. So, just what I want to say, these values may not be accurate. It depends on many factors. For example, you can see this active depth in the open ground, it is around this depth. But if you have vegetation trees, it goes further down. And but if it is covered, it reduces. Right? If you are for any site, if you are excavating the soil and then leaving it for some time, the active zone reduces. If you are placing some soil, that changes. So that also need to be taken into account. Right? So when we use lime in the field, as I said, we can apply in these three forms: lime columns, lime piles, or limestone. These methods are mainly pioneered for the soft soils, right? But the same methods are being used for the expansive soils also. some in spite of their ineffectiveness. I just want to highlight some of the things. We did some experiment with line piles in the small laboratory modes. You can see here, when we make a mold, in the mold we compact the soil, we place the lines in the hole, and then we observe. We avoid it for 2 months or 1 month, and then we observe the properties. We saw that there is not much variation in the physicochemical properties. Characterization did not change. pH I was talking about. pH remained almost same as that of untreated one. It did not go through the conducive for the post-nodic reaction. 9 or 12, it did not move there. So what we want to say is the line pile was not effective. Then further, what is the other method? Other method is lime slurry stabilization. Lime slurry, we inject lime slurry into the ground and we treat the soil. So we tried in the laboratory, we desiccated. Lime slurry we were not able to inject in the compacted form or in the wet form because of impervious nature of the soil. We desiccated it, and then you can see that it was migrating, and then you can see the UCS is increasing, right? And the pH also was conducive for post-nodic reactions. All the properties were changing. Right? We also implemented in the field 1081, and then we saw that this method was effective. Right? So I'm just keeping some slides. Right? What I want to say is, from this line pile treatment could only promote the short-term reactions. Lime slurry technique was effective, but this effectiveness depends upon the extent of desiccation cracks formed. If the desiccation cracks are less, then it will not be useful. For example, in the rainy seasons, we will not be able to use this method. Only in the summer, where you have desiccation cracks are high, we will be able to use this. And field lime slurry technique was more effective than the laboratory because of the extensive. So this is the summary of it. What is it, lime piles? Why is it ineffective? It is ineffective because whatever the lime that is put it in the hole, it stays there only because of the imperviousness of the clay soil, and other one is low solubility of lime, just about 0.3 grams per liter. So it is not soluble. So diffusion also will not happen. Because of these two things, lime piles is ineffective. And other one is lime columns. The other name is, we call it as deep soil mixing. It is very effective, mainly for the soft soils and other soils, but even in expansive soils also it is very effective, but doing is difficult. It is not impossible, but it is difficult, or it becomes expensive and time consuming, so it is not much practice. Only other method is lime slurry. As I said, the success of this lime slurry depends on extensive shrinkage cracks that are developed. If the cracks are not there, or it is limited to the depth of shrinkage cracks. For that, we came up with a new method called as lime precipitation technique. So we know that if lime is mixed with the soil, it is very effective. We thought that we can make a hole in the ground, pour the calcium chloride solution through the borehole, and then the sodium hydroxide solution, so that the reactions happen in the soil after passing into the ground, and then lime forms. If lime forms, it is very effective. So we did with this basis, we did some experiments. We physically mixed. First, the various concentrations were added, and then we saw that it is reducing the liquid limit, increasing the pH, similarly the plasticity index. We have used two sequences. One is calcium chloride sequence. Calcium chloride was passed first, then sodium hydroxide. In other one, other way. Both the things with the lime precipitation content, with the curing period. So we can see that this lime precipitation was effective based on the laboratory tests on the remolded samples. Then what we thought was, since it is very effective, so you can see here the effectiveness in the shrinkage limit. Simple shrinkage limit will, if you take a picture of it, it will talk a lot about the stabilization. You can see this is the untreated soil which shrunk more just before doing the shrinkage limit. But these are with lime precipitation content, different content. The last one is with high lime precipitation content. You can see that it did not shrink at all because of the flocculated type of structure. You can see in the category, it became from CH, it became amide. You know that it became non-plastic, and then you can see the fabric also the untreated soil, it went to the flocculated state. So this is ceofolized chart. This is called a ceofolized fabric chart. So please, very useful for the stabilization. So further, it is effective during first time mixing, but any stabilization should be stable. Durability we need to study. That durability we need some wet dry test, subjected to different wetting and drying cycles, and check whether it is effective or not. You can see that. So the brittle behavior you can observe means pozzolanic reactions have happened, right? So then we have seen with wetting and drying. You can see the red color one is the untreated soil, and so that equilibrium bandwidth is very tight, swell and shrink, but whereas the treated one is almost zero. This is on a remolded sample, physically mixed solutions and did it. Then we thought, since it is very effective, so what we did was we have compacted the soil in the large mold, made a sand column, and then poured the solutions, and then taken the samples and tested. So when we did that, so it was very effective. So you can see in case of pH increased, right? So the liquidity decreased, right? So shrinkage limit also increased a lot. So from there we can say that it is working well, and the wetting and drying and UCS behavior of the line precipitation treated samples. Brittle, the strength increase means pozzolanic reactions are happening with the line precipitation. Similarly, you can see here wetting and drying, volume change behavior during wetting and drying, almost zero. Line precipitated samples did not so, and we have supplemented the results with the microstructural studies. You can see that agglomeration and cementation. I think come to the conclusions. Why this method? We have so many methods of chemical stabilization. Why is it usefulness? Because of the imperviousness of the line, we can use this method. Apart from that, we would have constructed a structure like building or pavement, but if you come to know that the soil is a problematic later, we have to remove it and then do the treatment. Instead of that one, without removing the existing structure, we can make the borehole surrounding it and pour the calcium chloride solution or sodium hydroxide solution, right, and see that the solution goes below it, and then the line can precipitate and then it can treat. So that's the advantages of this line precipitation technique. So just in a nutshell, I want to conclude is lime treatment is effective provided lime is able to migrate or diffuse into the soil. That drawback was overcome by lime precipitation technique, wherein the calcium chloride or sodium hydroxide are highly soluble. They can just diffuse into the water, they can migrate into the water to the fissures and crack, and it promoted both modification and post-modification. So I think that's it. I think I did not take much time. I tried to restrict my time. So I just want to acknowledge the people who were involved, my MTech students, and then my guys. This work I just started at IIC, but it was not successful. Later on, I continued. Thank you.
studied the behavior of the soil, carbon dioxide for that, and had given a soil classification based on the volume occupied by the soil in water as well as in the geoset. And that he had correlated with the standing atomic outcome as well as X-ray density. And it has excellently correlated. And it is not understood why it has not been taken into consideration and why the IS code is not available so far, even after a lapse of 40 years or so. That's my
Thank you for your question. I think still our IS for the pavements and all, we are using the free swell index. It was developed over a period of time. It used tentative clay mineral that is present. I will show the free swell ratio. If you want to know about the mineral, you need to look at the free swell ratio. That will give tentatively. If it is more than 1.5 and above, we can say that non-moilite is present. Otherwise, other minerals such as illite or granite are present. That table you can use the Sridhar and Prakash table, that is regarding the free swell ratio. Other than that, IS code, I think these many methods, whatever we have, those are all index tests only. They are not. We are talking based on the index properties only. They are not the actual engineering properties that are required for a geotechnical design. Geotechnical design, if you have to do, you need to do the direct tests such as odometer, swell potential, and swell pressure, and use it. But for the easiness, they are using the index test. Maybe IS codes needs to be revised. More than that, this differential free swell, you don't need CCL4 or you don't need the kerosene. Simple, take a small sample, basically, and it can be done in the field also. You don't need any equipment. You need a simple free swell jar with a small ring, and that can be done. You can try, and some of you can try and give me some feedback. I want this method to be adopted. That's why I wanted to present this. Thank you. I hope I can discuss with you. I hope I have clarified.
They presented right about retrofit their structure that is affected by expansive soil. I think we have recently made a publication. He has forwarded to me the experience that I will share it with you all. You can also proceed. So thank you all for patient listening. So we had a wonderful morning session. So take your lunch and assemble back by 2:30 so that we will be the rest of the lectures and right across the introductory session, right? So thank you. So lunch will arrive outside this house. Before that I would like to present this morning. Students, probably you have seen his slides on the expansive side. Yes. So if you have any questions, you can ask. Thank you.
Nearly 220 publications of technical papers in international or national journals of conferences, seminar proceedings, including book chapters. He was a recipient of DRLS Young Scientist Research Award, Boyd Cash Fellowship and Heritage Fellowship.
Okay, thank you. Good afternoon, you all. Okay, I hope we had a good lunch. Of course, it's a delayed lunch. Okay, so but of course, I was supposed to complete my talk by this time, but I'm starting now. Just to understand, I would like to see how the crowd is How many are the BTech students here? Can you please raise your hands? Okay, I expect you are third year or fourth year students, right? Second year. Okay. Have you studied about geotechnical engineering? No, studied. Okay. Any MTech students? How many are there? A good number. Okay. Yeah. PhD scholars. Okay, few of them. Very good. So, and other industry people are there. So thank you. Okay, good. So various departments and faculty and so masters are there. And happy to stand in front of our guru, Professor Madhvilata. Okay, a legendary for the country now. Yeah, my BTech student also is there, Mr. Kudaram. He's a garrison engineer in metal engineering service. A good example for the civil engineering profession, what he is demonstrating, and so on. Yeah, first of all, thanks to Andhra University team, particularly Professor Centenary for inviting me for delivering this talk and to be part of this particularly Centenary celebrations, 100 years of Andhra University. That's a very proud moment for the university and thing. And we have seen the good alumni starting from Professor V.S. Rajgaru and Professor Madhav and several other people who are there. And I congratulate all the students sitting here being part of this great institution. And only thing, please consider it's a responsibility. You have to raise the flag further higher and you have to set an example for your further generations. That's what you have to keep your target and go on. Yeah, my topic, of course, yesterday and today we had different diversified topics, and now we are touching about the seismic earthquake related aspects. Of course, I will be talking about primarily stone column applications. Of course, in general, our theme is problematic ground, problematic site. Of course, the liquefiable site is a problematic ground under certain situations. That's what we will be dealing with. Of course, the stone columns. And then next, Professor Prasad will be talking about seismic aspects and so on. This is the content what I plan to cover quickly. I'll briefly touch upon the seismic hazards, what is the liquefaction and various aspects, and what are the in general mitigation aspects. And then I'll focus a little bit more on the stone column design construction. What are the mechanisms that will operate in mitigating the liquefaction and concluding remarks. So various seismic hazards, earthquakes, they will lead to the different seismic hazards, which we can be primarily due to the loss of strength and stiffness. When material is subject to seismic loading, it will be strength degradation will occur. So that is what leading to the failure of the thing. So various things can be seen in terms of the ground shaking and amplification, because the earthquake is occurring when it is traveling from the ground, beneath the ground to the surface, how the amplification will occur, how the it will be soil properties, behavior, wave propagation will be coming into the picture, and leading to the structural failure. This is what overall structural hazards. Some of the pictures just to set the context from the earlier earthquakes. Very traditional pictures. Whenever you talk about earthquakes, these are the first pictures what we will be seeing about the 1964 earthquake. So if you see these things, primarily the structure is okay, but because of the soil-related associated problems, it led to the failure. When you take the building collapse and the bridge collapse, that's primarily the geotechnical related earthquake damage, and is a liquefaction typical example. And you have this. Various Bhuj earthquake, 2000 Bhuj earthquake examples. So primarily India focused on earthquake-related studies after this particular event, several of the things. And some other examples, various infrastructure projects, buildings and all, which are getting damaged due to the earthquake and associated things. Various aspects are there. Of course, so our focus is on the liquefaction, what is happening during the liquefaction. So when the soil will behave like a liquid and it will flow along with the water, that's what the simple way to understand. It will be losing its strength. Some examples, again, old conventional classical examples which led to the failure. I would like to take your attention to the some schematic here which is demonstrating the liquefaction related aspects. So before liquefaction how it is and after liquefaction how it will behave seismic results. Basically water from the ground will be coming up, there is building collapse and underground structures will be bombed out and various damages are there. So these are Christchurch and New Zealand Christchurch earthquake where several of the things are seen. So this is another good example of liquefaction. So a building which is very good in standing things. So after that earthquake and liquefaction occurred, you can just see people unable to stand here in front of the building. There is a full muddy soil. They are unable to stand. So that's how the situation. There is some research team soon after the earthquake they visited and they tried to and underground structures were floating up like this one. So some. So their sand boils, it's like a boiling type of signatures will be there under the earthquake. So in some cases, some sites it's not liquefaction, it's not only one time, sometimes de-liquefaction may also occur because earthquake events, there will be successive events will be there that will also lead to the failure. Some examples are there. Retaining structures and so on. Even deep foundations we consider to be safe for measure of thing. And we have to take care in the liquefaction what will happen. Okay, it will lack the lateral resistance, some buckling type of behavior will be coming into picture. So we have to understand it. So there are some good examples are there which will show the effectiveness of the ground improvement during the earthquake. So some of the other nearby unimproved grounds got failure effect, but whereas the ground improved aspects, that the ground could stably stay. So there's some one good example from the Japan. So where some part where the ground improvement was, the whole project is under execution. Where the ground improvement part what was done, that area was good. The remaining part is liquefaction was occurring to the sun. So what will happen actually the particles are there. Next slide. So when it is liquefied, what is coming up? Okay, this immediately they are in good contact. Will have a lot of contact forces. When water is increasing, water pressure is increasing, the particles will lose its connection pressures will be reducing. When it's more water is there, then it will completely lose the thing. Will be particles will be moving separately. This is how the liquefaction in a simple way, what is that will happen. So we have to see that one and we have to control that one, liquefaction and associated dynamics. So basically what is liquefaction? Generation of the pore water pressure because of the undrained loading conditions. Of course many of you while studying the soil strength will be dealing with the drained loading, undrained loading because here earthquake type of loadings are very fast rate of loadings. Then drainage will not occur, so it's undrained loading condition. And that will lead to increase the pore water pressure, will lead to the liquefaction. There are two categories, flow liquefaction and cyclic mobility over there. So it will basically what it will do because of the reduction in the effective stress and the shear strength will be reduced, and the cyclic mobility is the leading to the larger displacements of the thing. There are certain signatures what we have seen the pictures like sand boils, lateral spreads, ground movement and flow failures, and loss of bearing capacity like some structure has failed, okay, and ground oscillations etc. These different signatures would be there. So which type of the soils would be liquefied and how to predict as a primary question one need to have this particular thing. Primarily sand soils, coagulous soils which are loose to very loose soils. So when it is subject to the seismic loading, positive pore water will be generated. Those things will be subjected to the liquefaction primarily. Of course, there are some, it's not only limited to the very loose and loose soil, there are certain other things also. So we can also see here, so groundwater level less than 10 meters and saturated soil layer at a depth of less than 20 meters and even some fine content also up to 25% usually. Some of the conditions are there. So we can, of course, having said this one, it's not only limited to the only the coagulous soils. There are certain examples are there where the non-plastic silts are liquefied, some examples, some place even gravelly soils also liquefied in some case, and in case even in the case of corrosive soils, of course we will not call that as a pore water liquefaction completely, but huge deformation, cyclic mobility aspects also will become in the picture. So it's not that we can eliminate this soil will not be there, mostly of course certain criteria is there, but more or less all types of soil they will be having some issue, but we need to avoid it. So of course in the cohesionless soils, directly we will consider that as a liquefaction, complete loss of strength, and in the clays and plasticity, plastic seeds, it will be considered as cyclic soft. Some parameters which will be leading to the liquefaction, of course Chinese criteria, criteria and so on are there. Even gravels also will be liquefied. So these are the things. So that's how predict the liquefaction, what are the soils to be liquefied. So just to before planning its mitigation measure, it is to understand what are the factors it is influencing the liquefaction and strength. Basically, strength and stiffness of the soil is primary thing, and of course loading, earthquake loading, how much is the load is occurring, what is the intensity and magnitude of earthquakes occurring, those are the things, various things. If you can list out earthquake intensity and duration, what is the level of the groundwater table we talk, soil type and the soil state, value density, how the particle size gradation, and the placement conditions and drainage conditions, how it is draining, and confining pressures, etc., various things will be affecting this one. So while planning the mitigation measures, some of these things, if you are improving, while controlling the thing, we can avoid the liquefaction, we can mitigate the liquefaction. That's what the point. So of course, initially what we have seen is what are the probable soils which are going to liquefy. Okay, first identifying, and then we have to really calculate whether the soil is going to liquefy or not for a given conditions of the earthquake condition, whatever we will say. So there are various methods are available, simplified methods, semi-empirical methods, and one can go with the effective stress time history models, more rigorous things, and there are certain probabilistic methods are there which can be implemented, and of course some detailed laboratory tests in terms of element test, model test also can be conducted to evaluate the liquefaction potential. More commonly used one is the simplified cyclic stress-based semi-empirical methods based on inputs and parameters. So what we will see here, load versus resistance. Load means due to earthquake, how much load is coming, and how the soil, how much is the resistance it has, those things we will see. The load versus resistance, load will be calculated as a function of earthquake acceleration, earthquake magnitude, and what the stress and what depth is the particular point is considered. Okay, the stress and the horizontal acceleration, that is the shear stress, how much it is creating, and that is the load. And the second one is the resistance, how much is the resistance it is developing. We can see the soil strength, material strength in terms of some in situ test parameters. I am sure you are aware of the in situ test values, something like SPT, CPT values are represented here, and the resistance also will be considered, what is the magnitude of thing, and space minus also thing. Basically, we will be counting some value for the resistance, some value for the load, and we will be calculating towards factor of safety. That is a simple way of telling the simplified method of liquefaction evaluation. And one can plot the what is the factor of safety against it. So this is one particular example. A typical soil profile is given here with SPTN values, and if you follow certain steps like calculating the load, calculating resistance, one can evaluate the liquefaction factor safety. Again, in liquefaction, some detailed procedures can follow at each step. What is the liquefaction factor safety? Whether liquefying or not, okay, something like we can establish. These are result doing as per the Higgs and Bolong 2006. Okay, even our IS code also mentioned the procedure for the evaluating the liquefaction potential. IS 1893, based on that one, we can evaluate the thing. This is a particular one. This is how will be evaluated. Of course, primary liquefaction evaluation potential is the factor of safety with reference to the less than 1 or more than 1 will be looking into the thing. And it is not that one only factor of safety greater than 1 can be considered as a safe one, but there is certain things we need to understand. So basically, what is the whole mechanism? What is the whole mechanism? Due to the seismic loading, pore water pressures are increasing, and it is leading to the liquefaction, that is effective stress zero condition leading to failure. But up to certain level, it may not be reaching to the liquefaction completely, but due to increase of the pore water pressure, reduction in the effective stress initiation is also to be there. Those things we have to take care. So up to 1.2, if you see here factor of safety up to 1.2, you can just see about 50% of the pore water pressure are increasing. That will affect the strength of the soil. So that also need to be taken care. And further, not only simple factor of safety, liquefaction potential index IL also will be looking into in a particular one. So what is that factor of safety point? What to say? Each depth we are calculating one factor of safety. Okay. So in the liquefaction potential index, what we take, we will complete up to 20 meters of depth. What is the factor of safety values at different depths? What is the value? And we will get one cumulative number, one single number for a particular site condition. So that is the liquefaction potential index as proposed by Iwasaki et al. So these are the things. Based on this one can classify a particular site is liquefaction risk in terms of level of liquefaction is based on IL values. And its severity also can be listed here. We can identify what's the site in this one. So this is one typical example, and the CPT based test results, and the results are there. And what's the factor of safety with depth, and what the cumulative IL values are there. These are some typical examples. There are certain probabilistic framework also is there to look into the site liquefaction and associated things. So someone wants to work on this is the one good software, okay, which is of course one can get this a trial version to evaluate the liquefaction potential, giving various input parameters also. Yeah, so we identified what is liquefaction, how to evaluate the liquefaction potential. Yes, at a particular site it is liquefaction inevitable, is what to do. We can just see. So what the primary thing as an engineer is, we will improve the ground, we will improve the engineering properties of the ground. And primarily we will be reinforcing the soil to resist the higher seismic loads. You understand, right? Earthquake is higher seismic loads, lateral forces are there. If you have the more stiffer element, it will be able to resist the shear forces. That's what we mean. And primary reason for liquefaction is the generation of the pore water pressure. If you provide easy drainage, pore water pressure generated will able to dissipate. It is the drainage will provide, and we can reduce the groundwater level. There are some primary mechanisms what we need to implement to mitigate the liquefaction testing. Accordingly, some methods, basically what we can do, we can apply the ground method, engineering of the ground, that's where. There is a strategy to be considered in terms of liquefaction evaluation, ground method. There is things are there, one need to can look into either improving the ground, improving the structure as a holistic way, okay, ensuring the whole safety of the structure. Improving the ground, improving the substructure and superstructure together. So one can look into various aspects as well. So looking into various principles, okay, primarily what is that is targeted where increasing the density, solidification, adjusting the tracer distribution, and providing the drainage and so on. And the methods are defined with the densification methods, solidification method, replacement method, etc. And each of these methods, various methods are there. We can see this. So looking into the grain size distribution of various soils, certain methods will be more suitable to various things, and this is the distribution of various things. So primarily what we are looking is the drains for liquefaction, drains for consolidation. This is what vibro replacement. So these are all fall under the stone columns related category. So what we do. So just summary of the things in terms of various concept of improvement, what are various methods are available, and in that one, so our focus is to the gravel drains, which are also work as a densification mechanism, or replacement and reinforcement mechanism, and also drainage mechanism. These are the four principles which we are working for improving the granular inclusions. Now coming to the granular inclusions as a ground improvement method, which is for resisting the liquefaction, mitigating liquefaction. So they are basically in a granular or columnar form. In the ground, will be installing the piles, granular piles, basically granular material. Stone, when you are using the stone, it can be sand piles, it can be stone columns. So there are broadly we can call them as a granular columns. So various functions they will facilitate reinforcement and drainage and densification mechanism. Of course, certain advantages are listed here. So how they are installed? Okay, in different pattern they will be installed. For studying and analyzing the thing, a unit cell, single unit cell will be considered to study the behavior of the thing. This is a single unit cell. That means in between this area, you can see here the area, circular area represented here. You can represent as a three-dimensional cylindrical one. If you represent in a two-dimensional thing, so we can see this is what area it is represented. This is a unit cell, what will be considered. The granular columns or stone columns can be installed in different patterns. So this is a rectangular pattern, triangular and radial pattern. Various patterns are there. And various parameters will be looked into, particularly area replacement ratio is the primary one in a given area. How much area the stone column is covering, that's what area replacement ratio will be defined. So AC is the area of the column and A is the tributary area, whatever the soil area, total area, that is what we are considering. This is the parameter he will be give us how much area is being improved with the stone column, that's what we will be doing. Of course, the spacing between the stone columns based on the pattern we can define. So what is the area DE value and what is the area ratio. So these are the parameters what we do. So how do we construct? Okay, this is the arrangement we have seen. The columns, how do we construct? Traditionally, so without much mechanized things, this is the where normal soil investigation team also can be installing using this what is the rammed stone columns method. So where you will be making a borehole, installing the stone gradually and ramming that gradually and gradually coming up. This is what the rammed stone columns. This is not very equipment based thing, which is small projects they will be executing. However, in the large projects where you need to install the major proper controlled way, so this is a vibro compaction method, vibro installation methods will be used. So this primarily Keller group is a primary things which will be contributing. Various methods are there, wet method, dry method and so on. I'm not going into the details, but there are certain methods are that which will be used for the installation of the stone columns and so on. So various applications, they will basically improve the things for performance. So how to design this particular one? Various design guidelines are there. So what are the design parameters while designing the stone columns? So we need to decide what is the diameter of the granular for the stone column, at what spacing we are installing the stone columns. So what is the pattern of installation, that means triangular pattern, rectangular pattern or the square pattern, whatever the thing. And information about the length of the pipe, how much depth we have to install. These are the design parameters what we need to get from the various things. Of course, what is the material to be used in the stone columns, the gradation details of the material. These are the details are required in hand for going to the construction. Various references are there. So those who are interested for more details, we can refer to this one. So this is one classic international document, very good document. Of course, we have our own IS 15284 is the code, design and construction drawing. Of course, for Graves method is again Keller based two documents are there. So one is the general stone column design, other one is the earthquake induced liquefaction related design. Two aspects are there. So various methods are there. Okay. So these are some parameters, general range of the parameters. So what is the backfill material? What is the range of the parameters? What is the pattern? Typical spacing between 1.5 to 3.5 meters to center. And the diameter of the stone column generally 0.6 to 1 meter generally. Depending on sometimes, it's not limited to sometimes 1.0 to 1.5 meters also. And area replacement ratio, so generally 0.1 to 0.3 in that range is there, depending on the thing. So length of the columns up to the 20 meters also are there, generally 5 to 15 meters. Of course, depending on the soil state up to what depth we have to do, so that will be decided. And with the area replacement ratio and total thing, we will be understanding what is the extent of the area to be improved and so on. And of course, for the normal thing, we will also consider what is the load it can carry. Of course, various details about the material, how it will be used, and what the gradation related requirements, what the suitability of that material. There are certain standard things are there, so which need to be adapted. So what is that we are doing here in the ground? We are installing a more stiffer material into the thing, okay, which is some reinforcement effect is there. So when you apply the load, there will be higher stresses will be concentrated at the column level, and whereas the lesser stresses will be there in the original soil layer. So there is a design parameter. Stress concentration factor is another important parameter which will be governing the design. This also can be targeted. So there are some relations how the stress concentration can look, considering the equilibrium of the thing. When you are loading the thing, whole thing will be strain equilibrium, everything will be settling same. So for attaining that one, there is a stress here that will be different. Therefore, the things will be calculated. One can calculate it for a given area ratio for a targeted concentration vector. What the stress in soil, what the stress in the column material can be calculated. While installing the stone columns, the soil will be improved, densification will be occurring. So we can also calculate the improved ground, what is the N value. Basically, we know without treatment what is the SPTN value, with treatment what is the SPTN value. Okay? So we have proposed some relation, a tentative relation based on the previous studies. Some of the data were used and established this one. If you know the initial ground SPTN values, if we are adopting some different replacement ratios, what will be the improved SPTN value? Okay, some preliminary data, it's not a final one, tentative estimation which can be used to understand. And there is some other data value, improved values also can be there. So there is some data clearly showing the before the treatment, after the improvement can be calculated. That's a general one. So coming to the liquefaction mitigation function of the stone columns, what are various mechanisms working? As we discussed, primarily the reinforcement mechanism and drainage mechanism and densification. While installing the stone columns, original ground which was considered to be loose or very loose condition, due to the installation process, the ground also gets densified. We can also take that into consideration, how the densification is improving the soil strength. That's what we think. And the dilation during this densification, what will happen originally is the loose soil, it will be contract to nature. When the soil is becoming densified, it's a dilative behavior. It will be generating the negative pore water pressures rather than the positive pore water pressures. So that will also reduce the thing. And stone columns, they because they are the void structure is there. What are the pore water pressure? They will store some water, external water. So that is also can be done. So there are various mechanisms will go forward. So it can be looked into. So reinforcement mechanism can be simply shown this one. So you can just see you have the very stiffer element is here. Because of the stiffer element, the shear stresses which are coming onto the soil will be reducing, and the rate of pore water pressure generated can be reduced. That's what the effect of the reinforcement what we can just see in this one. So one can calculate how much is the shear stress without the stone column it is coming to the soil. With inclusion of the stone column, how much is the shear stress we can calculate. Of course, considering what is the shear modulus of the column material, what is shear modulus of the soil material, and area which one can calculate. Second one is the drainage effect. So when you install the drains vertically, so what are the pore water pressures are generated, they will be entering into the laterally traveling and entering the drains. They will be easily quickly dissipated by this mechanism. So pore water pressures will be very quickly dissipated. That's the second mechanism, drainage mechanism should be working. So there are some certain examples, some model tests were conducted. So this is the unimproved ground when you apply the shaking studies. So it is going to the liquefy. When you apply the stone columns, so the pore water pressures are not increasing significantly. There, the drainage is happening. These are some. So to study how the pore water pressures are reduced and so on, of course one can do the numerical modeling and other studies. So a simple analytical model has been developed. So I hope when you studied about permeability, so you must have seen about Laplace equation, permeability. The same thing is the permeability equation, consolidation equations are put together to see how the pore water pressure is generated, how they are dissipated the thing. So basically that's the framework has been considered. Here UG, dUG by dN is with the change of the cyclic loading, how the pore water pressure increasing. So that will be considered, and we can calculate what is the pore water pressure different things and so on. If you discretize the whole element into the numerical finite difference framework, so we can calculate at each point what is the pore water pressure during the cyclic loading and after the cyclic loading also. So So we can calculate that. That's the framework with the appropriate boundary conditions would be considered. Due to the earthquake, pore water pressure generation will be added into the model. So this is the level of how the pore water pressure will be added. That is the function which has been well established function will be. So with that one can see without the ground improvement what is the maximum pore water pressure ratio, and with the improvement what is the maximum pore water pressure ratio. Is a typical pictures diagrams. So this T by TD is nothing but the T is the time at a different interval. TD is the duration of the earthquake. Timing event is there. Duration of the T by TD is that one. So you see the T by TD means up to 1 the seismic event is occurred, and afterwards seismic event is stopped, then dissipation is occurring. That's what the thing what we can see here. So gradually when it is very low value, 0 value, the pore water pressure will be 1, W max is the 1, and if you are including the stone columns, you can see with increasing the area ratio, A where B value is nothing but an indicative measure of the area replacement ratio, you can reduce the pore water pressure ratios. So this is what the effectively what we can just show. So various conditions, the various design parameters are there, TAD, TBD, different parameters which are taking care of the marginal permeability of the soil, MV compression resistivity value, and what is the duration of the earthquake. These things will be considered for different cases. One can see various parameters. That's a primary model of serial repair. Based on that one, there are certain modifications or improvement by various researchers looked into various effects and to the various things. So what is that? It is considered there. So primarily this is the densification effect. What is shown here? This is the indication of being very close to the pile. You say the darker color indicates the more densification. As you go far from this stone column, you are less densification, or if you go into the ozone side condition, there is a densification effect what we can see, and that will be considered in the analysis, and how the densification effect is improving the liquefaction for what we just have seen. So they have been studied, and basically here when you are considering densification effect, change in the permeability along the radial direction also considered. Otherwise, what we consider is permeability is uniform in all the locations, but the densification will be different. So there are some model parameters and dilation effect, including the negative pore water pressure consideration. So these are the values what can be considered. The other effects, the soil fabric effect and other models can be looked into. For different A by B values, we can just see how it is. So these are the typical curves to consider the various effects and how the forward weather ratios are increased for different conditions. So these are the design curves what we can use for the designing of the liquefaction. So what is the? I will just show a simple example here. Designing for the liquefaction mitigation. So you have a given soil properties having the MV value and permeability value, some given parameter. Okay, in situ soil we have some parameters, and we are considering some earthquake magnitude resistant earthquake values. So if you are assuming there are 24 uniform cycles, in a period of 35 seconds is the earthquake duration, and 8.0 is the magnitude of that's a load earthquake loading. So under this condition, one can define the various parameters, and we can also use this curve to identify what is the TAD values what you are getting, and what is our target pore water pressures we can reduce, and so on. So this is a target. We try to keep the pore water pressure maximum to 0.5, and we will see the particular the TAD value, and we can come to the A by B parameter, and we can decide what is the area ratio or A by B parameters required for a given earthquake. We can so that's the general way of designing the particular aspect. There is certain case studies just to briefly highlight. So where the stone columns have been employed for the mitigation of the liquefaction. Various cases in Assam, India is oil refinery plant. This is the site profile. So what is the soil condition, actual soil conditions, the SPM values, I have shown earlier how the reference for the calculation of the liquefaction. In the diffusion Bollinger method, assuming the 8 magnitude and PCA value of 2.363, liquefaction evaluation was done. So this is the area up to about 8 meters of the depth the soil is going to liquefy. Okay, that is the problem. Okay, so now they have to design the particular one as a stone columns. So after the various design process, they have arrived at the stone columns diameter ranging from 800 mm to 1.1 meter diameter, spacings at different locations. Okay, depending on the intensity of the loading, because in a plant area, it's not that all area will be having the same level of loading and requirements and so on. Depending on the factor of safety and so on, they have adopted different spacings. Okay, 1.6 meter, 1.8 meter, 1.4 meter. So of course, up to 8 meters is shown as the liquefied value, and they have improved up to the 11.5 meters maximum. Some locations 8 meters, 10 and 11.5 meters and so on. So they have, during the execution of the stone columns to ascertain the quality of the thing, they have done some loading tests. Okay? Of course, they cannot test the liquefaction improvement, but the loading test, how much it has been improved, some load test, some more data can be obtained from this cellular. Another case study is the NDPL power plant in New Delhi. So where the 108 megawatt is power plant is there. In the subsoil conditions where it has the loose to medium test sandy soils with the SP10 values and the top 10 to 12 meters loose sands. So they have done the evaluation and finally arrived at the design of 500 mm diameter up to 8 to 12 meters with a triangular grid of 2 meters and so another project ROB, road orbit project in Bongaigaon, again Assam state where the higher earthquake magnitude values are there. So this is a soil profile and this is a liquefaction analysis where you can see up to 6 meters depth you have the effect of safety less than 1, and this has been the ROB railway orbit with REVA. So at the bottom, so they have installed the stone columns through the ground. Another example. So going to that area and other side. So that's something quickly. So liquefaction is the most hazardous to conclude. The most hazardous damage during earthquake. So among various remedial measures, what we have, stone columns, granular inclusions considered to be the best method because it facilitates various functions like densification, drainage, densification, and reinforcing the thing. These are the primary things which will be employing the thing in reducing the liquefaction. So we have to look into what the different mechanisms are operating, and they need to be considered while designing the thing. Okay. So all the mechanisms along with their mechanisms are to be considered, which can be applied to that. Thank you. Yeah. Do you have any questions? Anything? Any discussions? Not only questions. So you're welcome.
Evaluation of liquefaction potential. Finally, we described liquefaction mitigation methods, in particular using granular flights, what we call stone columns. So, I think everything is clear. In fact, much access to PPT and other things. Thank you for giving the time and money. Thank you very much.
So, yeah, as of course, when the starting remarks, Professor Centenary was not here, so again I am repeating. Thanks to me for inviting me, taking part in the Centenary celebrations of the university. Yeah, I just requested the students to take this as a responsibility. Take the flags and
I'll introduce myself to you. Good evening. He is Dr. S.K. Prasad. He did his PhD from Japan in 1995 and he was a gold medalist in MTech from IIT Kanpur. He was received from a reputed college of Mysore, that is Geotechnical College of Engineering. After that he worked in MSRIT, then He got an offer in IITs, but he prefer to work in Mysore. He likes Mysore. So it is a place where you get lot of peace. He refused to join the IITs even if they got the offer in 1995. Otherwise even today he would have been a senior most professor. And then he is adjudged as the #1 person in earthquake engineering in Karnataka. And he has delivered lot of invited lectures including Singapore, ARC, etc. And he has published many papers and produced PhDs. And he is a very, very popular teacher. And at the age of 62, he retired from JC and he has been invited by some other college and he is doing very well in that college. And particularly, he is very active in the geotechnical activities. The Mysore chapter was in the Bangalore chapter and now he has started a new chapter in Mysore and it is doing very well. And every year, he is conducting one program called Ragi. Ragi is a different one, but the expansion area
recent advances in geotechnical
or infrastructure. Ragi. Every year he will conduct, and the beauty of it is the speakers will not be repeated. Every year, one academician and one field person. And he is doing a lot of
two each.
And he has been invited by all the organizations in the state to deliver lecture. He is a very, very and you will going to enjoy that shortly. Thank you.
Sir. Very good friend of mine. Naturally, he has to speak good about me. Well, first of all, I have to thank Professor Satyanarayan Reddy and his team for an excellent program. I enjoyed yesterday, I enjoyed today also, and every speaker was simply fabulous. And hospitality-wise also, wonderful. My sincere thanks. And I'm also very happy to see that lot of technical things are happening in Andhra University under his leadership, Centenary Reddy's leadership. Also, I came to know that Tech program is going very good, both in geotech and structural engineering, full strength. That clearly shows the popularity of the institution. Well, since morning you all had stalwart speaking, and naturally it's not easy to compete with those who spoke very, very well. First speaker was actually my teacher at IIT Kanpur, and incidentally I was very happy that Professor Murli Krishna gave a talk on liquefaction, and I thought somehow I did not repeat that, so I'll be talking about a slightly different topic which I'm told Satyanarayan Reddy has been teaching in earthquake geotechnical engineering. Well, luckily I have not kept too many formulae here because being the last lecture, you would be enjoying if there are too many formulae. So I have taken many things from internet and other sources. My sincere thanks. Those authors. Well, this is what I have here. General introduction about earthquakes, earthquake geotechnical engineering, and then scientific. So I have about 45 minutes time, and I'll try to complete within that whatever the coverage I bring. I'll try to talk more through case studies here. And Visakhapatnam is known to be relatively free from earthquake. You don't have to worry about earthquakes, but you don't know. Earthquakes are so unpredictable. I always take the example of an earthquake in Maharashtra sometime back in 1993, Latur, Kilari. That used to be in zone 1, seismic zone 1, seismically least active. People had no idea about earthquake resistant design, construction and so on. But in 1993, I think September or October, there was a 6 magnitude earthquake, 6.3 or so, and it killed 20,000 people. Main reason is, the buildings were not designed for earthquake resistance. Early in the morning, around 5 a.m., this earthquake happened. The buildings were built mainly using masonry. They were not, connected to each other very well. There was much of key provided. And when the shaking happened, these masonry walls just could not take the load. They, they failed. And the moment they failed, whatever roof was sitting on them, it had to come down. And people were sleeping in their, houses at around 5 a.m. They simply perished without any information. So about 20,000 people killed purely because of lack of knowledge with the civil engineers about earthquake resistant construction. So what I want to mention here is that we just cannot take earthquakes very lightly. We all will have to be prepared. And I'm very happy that the MTech program has all these things. I just want to mention or show you where India stands with respect to handling the natural disasters. There is World Risk Index. I have taken a slightly older detail, and according to this, India stands at 90th position out of about 180 countries, which means there is still a lot we need to do in order to improve. We have been talking about biggest Bharat, developed country by 2047, and if we have to become so, we need to be very, very good with respect to disaster management, with respect to improving our World Risk Index. The other point I just would like to mention here is about one of the recent earthquakes which happened in Turkey sometime back in 2023 with a magnitude of 7.8. It killed more than 50,000 people in Turkey and Syria. And the interesting point about this is there were two earthquakes which happened in about 9 hours period. One of them had a magnitude of 7.8. The other one about 100 kilometers away had a magnitude around 7.5. Many cities around these epicenters were severely damaged. And the interesting point was, there is one city called Erection, very close to the earthquake of the first earthquake, and epicenter of the first earthquake, and there was no damage there. That is what the city claims. You can see here the kind of destruction suffered by different infrastructures. You can also see in the left picture number of aftershocks after the two big earthquakes. And this picture also shows the devastation suffered. Earthquakes are one such natural disasters. The kind of force they generate is so big, you can see huge amount of disasters. As I mentioned, the city of Erection claims that there was absolutely no damage. It claims that there was no death, not even injury. And the reason it quotes is that strictly they follow the bylaws. Strictly, whatever are the guidelines of the Corporation of Erection are followed by every resident. So message is, if you want to think about disaster management, you have to see to it that, you follow whatever are the guidelines. More or less, this should be comfortable. So this is what the city of Erection is before and after the earthquake. Okay. I just want you people to have a feel of how an earthquake would be. This is in Mexico during the 2017 earthquake. Earthquakes are such disasters which create huge amount of panic. You can imagine, in road roof friends, relatives staying in such buildings, and what would be the situation. Immediately after the earthquake, a panic-like situation like this is a common thing. As mentioned by my good friend, I lived in Tokyo for about 3 years, 1993 to 1996. Probably I must have experienced 6 to 7 earthquakes, and every time I felt very vulnerable. Luckily, the kind of shaking was less, therefore there was no damage at all. And I happened to visit a place where a big earthquake happened in 1995, and after about 3 to 4 months, it's called Kobe City. And 1995 there was an earthquake which caused huge amount of problems. So just I want you to have a look at how the situation would be during an earthquake. Okay. Let me just go forward. So earthquakes are the vibrations which are created at the ground surface. That is because at some depth below there will be some disturbance. That disturbance, as was shown in one of the previous talks, I forgot who was it. There will be wave propagation. So through the body of the earth, the waves do move. Just like you drop a stone into the water in a pond, you will have rings formed. Exactly similar way waves are formed, and these waves move up, and when they hit the surface, they cause vibration, and this vibration is totally unpredictable. What do I mean by unpredictable? You just cannot say when the next earthquake happens. You just cannot say what will be its duration, what will be its magnitude, what will be the level of acceleration, and so on. So in general you should know the point where the earthquake happens, we call it as focus or hypocenter. Point exactly above that on the ground surface is epicenter, and the distance between the two is called focal depth. Naturally, when the focal depth is small, that is when the earthquake happens at shallow depths, it is going to be very disastrous. And if the epicenter is close to you, naturally it causes more disasters. So, as I mentioned, earthquake shaking is unpredictable. That means, you have a shaking in 3 different directions, totally random, and it is cyclic. If I am just pushing you, you know that I am pushing you, and therefore you know how to react. But if I keep pushing and pulling you, you also will have to adjust to what I do, therefore your mind also has to work. So whenever it is a cyclic kind of load, it is very difficult to handle. And as I mentioned, every earthquake motion is very different from the other. Same earthquake at 2 different places. Same place, 2 different earthquakes. The earthquake motions are very different. Therefore, earthquakes are unpredictable. With respect to India, we should say that earthquakes are fairly common. We should say that 60% of India is seismically very active. And we have had our share of bad luck with many earthquakes in the past. Some of them I have listed here. And we also have had very big earthquakes of magnitude 8 and above some time back. And all of them caused disastrous damage. So this is what is the earthquake zonation map. And unfortunately, the 2025 version of IS 1893 has been taken back. Sometimes I feel bad, but we can't do much about that. Well, so just had a few questions. So Erzin city, why did it not suffer any damage? It's because the residents strictly followed the bylaws, and I want you to remember this message. So if we follow the guidelines, we are almost sure that things will be okay. So just try to mention what is the position of India with respect to World Risk Index, and I told you it's somewhere in the middle, and we need to do a lot to improve. 80th, the 90th out of 180 countries. So major effects of earthquake, loss of life, economic loss, deviation from the normal life, and all of them. Okay, how many zones seismically India is divided into? 4 zones, 2, 3, 4, 5. earthquake geotechnical engineering, I first want to mention, since morning we have been hearing that soil is a very complex material, very difficult to understand. And today, we have been having lots of activities underground. So, I'll not be surprised in future if we have one city underground. That's the kind of development which we are having. And if at all we need to have so many activities underground, it is because of the geotechnical engineers. And all these are the geotechnical structures. All these are structures which are in direct contact with soil. And hence, if you have to design them, you need to have a good knowledge about the soil with which it is in contact. And as I mentioned, soil is very complex because it has solid particles which are different in sizes and shapes, connected mainly by contact. In between them void space, sometimes filled with air, sometimes filled with water, sometimes with both water and air. And hence, they all make things very complex. Professor Madhav very clearly mentioned in the morning about the complexities, and I have listed some of these complexities in soil, which make it difficult to understand, which make it difficult to predict what kind of load it can take before it fails. But I always say, there are a few interesting characteristics soil has. All of you will agree with me that soil is colorful. Will you agree with me? Do you agree with me that it is colorful? It exists in different colors. You have red soil, you have black soil, and so on. Soil is sensitive. It gets disturbed if you disturb it. If you allow it to be intact in its place, it will be happy. If you try to take it out, it shows loss in strength. There are hypersensitive clays which have sufficient strength in their place. You bring them to the laboratory, you try to test its shear strength, it could be even zero. Soil has memory. It knows what load, what pressure it was subjected to before. And if the present pressure is more, it behaves in one way. If it is less, it behaves in totally different way. You can show that through E log P curve in consolidation theory. It changes its properties with time. Maybe water content. During summer, it will be less. During rainy season, it will be more. So what I want to tell here is that these are all the properties which give life to soil. These are all the properties which compare with those of human beings. So, soil should not be, just neglected. It is not like steel, it's not like concrete. Its behavior is much more intelligent. Therefore, if you understand it very well, it will be happy. If you misunderstand, if you are careless, it will show its anger in the form of failures. Whatever failures you saw earlier, it's because of our misunderstanding. So going forward, earthquake engineering in general is interdisciplinary. Main objective is to see that the structures are built to be earthquake resistant. Therefore, during earthquakes, loss of life, economic loss should be as much reduced as possible. And earthquake geotechnical engineering connects between, the geologist who talks about the behavior at greater depth and a structural engineer who concentrates on the behavior of superstructure. And when there is a disturbance which happens at some depth below, the waves are formed. These waves move through the body of the soil, and it all depends on the kind of soil which is available. And this soil may change several things. That's what we will discuss. And then finally, at the ground surface, you will see a horizontal force generated. And that horizontal force, whatever structure is there on top, should be able to withstand. It's a dynamic force. In general, earthquake geotechnical engineering, I always say, is very, very complex and unpredictable because you deal with soil which is complex. You deal with earthquakes which are unpredictable. and it's a combination of soil, complex soil and unpredictable earthquake, causing earthquake geotechnical engineering a very challenging field to handle. And any amount of research, there is still scope for more and more research. Some of the important happenings in earthquake geotechnical engineering, one is wave propagation through the body of the ground, and when it reaches the ground surface, what will be the response at the ground surface. So somewhere at some depth the earthquake happens, waves move, sometimes waves move directly through the rock, sometimes they travel a long distance through the rock, and when they travel the long distance, many high frequency terms will vanish, and then they go through the soil, overburdened soil which is layered, and so on, multiple times when they reach the ground surface, and there will be a totally different ground motion altogether at the surface. The second most important thing you should know is that you have a soil, if you consider a level ground, soil with vertical stress sigma v equal to maybe gamma times z, horizontal stress K times sigma v, K is the coefficient of earth pressure. And whenever earthquake happens, these shear waves move through the ground, and hence they cause shear stress also to the element. So the element will be subjected to the normal stresses as well as the shear stresses, and these shear stresses depend on the magnitude of earthquake. And if the shaking is more, naturally this will be more, therefore your Mohr circle gets enlarged. And if it gets enlarged to an extent where the failure happens, you have the problem. The other important thing is, because of the shaking, the shear strain increases. When the shaking is more, the strain level will be high. And if you just plot a graph between the stiffness of the ground and the strain level, interestingly you see that at very low strain level, when the shaking is very, very small, maybe in the elastic range, the shear stiffness, shear modulus will be very large, maximum. And when the strain level increases during rigorous shaking in a big earthquake, you can see that the stiffness may even reduce to zero. On the other hand, damping, which is sluggishness, damping enormously increases at large strains. So whenever you have a big earthquake, strain level increases, which causes loss in stiffness, which also causes sluggishness, increased damping. These are some of the important aspects, geotechnical aspects of earthquake. You have the primary effect, which is mainly ground break, fault formation and so on, and many secondary effects. And very quickly go through the different aspects of them, through pictures only. So there was one earthquake in 2001, which we call as Bhuj earthquake or Gujarat earthquake. Most of you youngsters probably were not born then, and during that there were quite a lot of knowledge which we all gained in earthquake engineering, including in earthquake geotechnical engineering. So some of the faults which were formed during which earthquake are shown here. San Andreas fault, which was formed sometime in 1906 in California, which is now a place for tourists to visit also, which runs for hundreds of kilometers. So this is one of the famous ones. And there are some other faults which are formed during some of the recent earthquakes. You can see how the ground has behaved because of the shaking it some depth. And when the faults are formed, you will see the vertical movement, horizontal movement, all causing lots of problem at the ground surface. And if you have any structure on the fault, automatically, however good it is, it will fail. So one of the messages I have just tried to show you here, a compound, a wall without any structure, a building and a dam. So depends depending on the importance of the structure, we have to be careful. If the structure is a compound like that, you don't have to bother where you are building. But if you are building a dam, you have to really consult a seismologist or a geologist and find out whether it is in a vulnerable place or not. So, because there was a fault below this dam, this could not survive. And all these pictures are from one of the earthquakes in Taiwan, 1999. Same. The fault has moved in this direction. Unfortunately, this bridge structure and the dam structure came across this fault. So wherever the fault has moved, there was no way the structure could survive. On the other hand, there are many interesting things do happen during earthquakes. So this is in Turkey. A fault came very close to this building, a school building, and it destroyed these places. But interestingly, this building survived. It's very difficult to understand how sometimes some crazy things do happen, but they survive. Landslides, it's quite natural. Whenever there is a shaking, there is a shear stress which causes the landslide to happen. And also shaking will reduce the strength of the ground. So soil will lose its strength and there is an extra shear stress which are causing the landslide. So animation of how the landslide can happen. This was in Loma Prieta earthquake in 1989 in USA. My friend Professor Murli Krishna explained about liquefaction. Simply, the ground will behave like liquid. Whatever SPC, whatever strength ground has, it will, in the worst situation, become zero. So you have your building built on a soil with good strength. Suddenly, when it becomes zero, you can understand what happens. He very clearly explained what are the consequences of liquefaction. Again, these pictures show how the transportation facility can have a disastrous failure, whether it is a railway track or a elevated road. So this was in Bhuj earthquake 2001. Retaining walls. You have a retaining wall. Behind this there is a backfill. So backfill is subjected to active earth pressure, and when you shake, the backfill may reduce its strength, lose its strength. The moment it loses its strength, the active earth pressure may increase, the coefficient of active earth pressure may increase. In the worst scenario, when it liquefies, K will become 1. On the other hand, passive earth pressure will decrease. So automatically, earth pressure changes do happen, causing lots of problems like this. And this is one famous picture taken by my professor. His name is Professor Tatsuoka. He has been a very good consultant in various categories, ground improvement and earthquake resistant construction and so on. He was extremely happy after the Kobe earthquake in 1995 because the earthquake proved that all conventional retaining walls failed, but reinforced earth wall, it remained intact. You can see here, this is a wall built, and then these are the buildings, very conventional buildings in Japan. And after the earthquake, you can see the fate of these buildings, but see how the reinforced earth wall survived. So he felt that whatever he was explaining earlier, he got a proof out of this. Well, failure of bridges, and here particularly I am talking about failure due to the ground movement, okay, maybe due to liquefaction. So you have deck slabs, built simply supported on the piers with certain bearings, and the available bearing was less. Therefore, failure like this happened. This happened in 1964 in Niigata earthquake. Same thing followed 30 years later. Failure of dams. This is the top one is in United States, Lower San Fernando Dam. The base of the dam, earthen dam, liquefied. Luckily, there was not much of water in the reservoir, therefore not serious damage happened. But because it liquefied, Similar thing happened in Bhuj after the Gujarat earthquake. We happened to visit about 4 dam sites, and we collected a lot of information and we gave very good inference out of that. Tunnels also do fail. Naturally, waves come from bottom, and these waves do cause problems of shaking to the tunnel material. And the other important thing is tsunami. We never had heard about tsunami until 2004, but in 2004 there was a huge earthquake in Indonesia, Sumatra, causing tsunami which affected about 14 countries, and the total death was something like 2.3 lakh people or so. Going forward, two very important things I always say with respect to earthquake geotechnical engineering is, one is liquefaction, which my friend Professor Krishna covered, and the other one is side effect. As I mentioned, you have the earthquake happening at some depth, waves travel. Most of the times we have layered soil. When the waves travel through layered soil of different layers of different stiffnesses, waves move through them, and there will be reflection, there will be refraction, deflection, and several things. And multiple reflections and refractions, by the time the waves come to the surface, there will be amplification in ground motion. In addition, new waves are generated at the surface waves, long wave and rally wave. All these cause amplification in ground motion. And because of the shaking, the ground loses its stiffness. So it degrades in strength and stiffness, causing lots of changes. So, shaking, if it happens at some depth, and if you have surfaces like this, you may have a solid bedrock, rising up to the top, or you may have different materials. Depending on the kind of materials, it moves, waves move in, the shaking will be different at different places. That is what is important to be identified. So, you will have, the disturbance happening. Waves sometimes directly go to the top, sometimes they travel through the rock, and when they travel long distance, many of the high frequency waves will be eliminated because of the damping effect. Only low frequency waves will be available, and these waves, when they move through the overburden, there may be lots of changes happening, and hence different structures are likely to vibrate in different fashion. I'll just try to show quickly a few of the case studies, including one work which we had done with respect to Bhuj earthquake, Geotechnical earthquake in Mexico in 1985. So this was perhaps the first earthquake during which side effect was found out. So this is Mexico country. Mexico City is somewhere at the center here, and earthquake happened here, almost 400 kilometers away. So earthquake had a shaking of the order of about 0.15 G here, and there was no damage. On the other hand, the waves moved for almost 400 kilometers, and here there was severe damage. And that is when people started understanding about the side effect. So this is the city of Mexico, a beautiful city with maybe 2 crore population. All around there is hilly terrain. There was one lake here called Lake Texcoco. So naturally, like Indian cities, they have dried it up because of the requirement of land. And below the lake, you have very soft soil. So they call it as volcanic clay. So this earthquake had a magnitude 8, focal at 20 kilometers, and it happened almost 400 kilometers, 380 kilometers from Mexico City, and the casualties is close to 20,000. This is how the city looked after the earthquake. Different parts of city. I quickly go onto this, and interestingly, some of the buildings survived. On the other hand, some buildings suffered severe damage. Here also, Masonry building has survived, but an RC building has failed. Okay. So one of the famous towers, built sometime in 1940s. It's called Torre Latino-Americana office building. It survived 3 to 4 earthquakes. On the other hand, in the foreground, you can see the buildings which have failed. So as I mentioned, the source is on the sea coast, and it had some magnitude, 0.15 G is the level of acceleration. The overall predominant frequency was 2 Hz. Surprisingly, the damage was less. On the other hand, the waves moved through a distance of 380 kilometers. This is Mexico City. Some portion is on the mountain range, hilly terrain, and some portion on soft soil. Soft soil extending for 40 to 60 meters, and there was an amplification in the ground motion. So this was in the plan. This is in the hilly terrain. So there is University of Mexico, and there was a sensor to record, and this is the soft clay area, and this is where one more recording was made. Approximately the overburden thickness here was about 40 meters, and this is where the shaking was very, very large. Okay. Dry lake Texcoco, and the kind of soil in that area, you can see the water content was 400%. Clay thickness 30 to 40 meters. Plasticity index more than 200%. Void ratio 15. SPTM value very, very low, less than 10. You can see what kind of soil is this, and the strain and stiffness behavior. You can see up to 10 to the power minus 3. Strain level had not dropped. Suddenly it dropped almost vertically. Also damping, up to 10 to the power minus 3, it had not increased. Suddenly there is a rapid increase. So at the epicenter, this was the shaking. In the mountain range, this was the shaking. On the other hand, where lake was there, in the soft soil, this was the shaking. So I want you to have a look at how the ground motion changed. So basically, I want to mention here that the soft soil can simply enhance the ground motion, amplify the ground motion. And it was also proved that the natural frequency of the ground was almost equivalent to the frequency with which the earthquake motion happened, nearly causing resonance phenomena. Structural engineers do not believe in resonance during earthquakes, because they say, earthquake happens only over a maximum 1 minute, out of which strong motion part is only 20 seconds. And so there is no time for resonance. But in ground, we see resonance-like phenomena, and this is what is proved here. So approximately, at 2 seconds, that is 0.5 Hertz, you have a resonance-like phenomenon. Similar things have happened in the other earthquakes. Loma Prieta earthquake, I just want to show you, this is in USA, 1989, and this is San Francisco, and equally big city, which is music level city, is Oakland. They are close by. In Oakland, one of these bridges, which was built, in 1950s, okay, it's a 2 or 3 tiered bridge carrying a highway. It suffered severe damage in soft soil. So this is the plan view. 3 different types of soil. This is hilly terrain, okay, where you have bedrock, and this is soft soil, and this one is intermediate, sandy soil. So the failure, this is the highway, and whenever the highway moved through soft soil, that entire portion suffered damage. Again indicating the effect of amplification in ground motion and possibly resonance effect causing the failure. Another picture, after the Loma Prieta earthquake, there were many aftershocks. these are the three places where sensors were placed. The distance between these hinges is less than 1 kilometer. Here you can see the kind of shaking. So this is the one which suffered maximum shaking. You see somewhere here. On the other hand, this one, MEAS, this suffered least shaking. So this is downhole sensors at different levels. You can see at the ground level the kind of amplification in the ground motion during one single earthquake. So very quickly on to this earthquake in 1995 I mentioned. So this is in a city called Kobe, and basically many man-made islands are also there. Some of them suffered severe damage during liquefaction, and due to liquefaction there, some of which my friend showed those pictures. So interestingly here, the geological cross-section of the city of Kobe is like this, and these are all the man-made islands. Okay. And this is the area where sufficient amount of damage happened, and the soil profile, if you see, the place where the damage happened had soft clay for sufficient thickness. I just go to the work which we did in Bhuj in 2001. Magnitude of earthquake was 7.7 and the intensity of shaking was 10. Approximately 20,000 people were killed. And earthquake happened close to Bhuj city, but in Ahmedabad city, almost 250 kilometers away, more than 100 buildings, most of them built about 10 years back, built out of reinforcement concrete, apartment buildings, suffered severe damage, almost causing about 2,000 deaths. And that's what I tried to mention here. 4 to 10 floor buildings, most of them built about 10 years before the earthquake. And the distance of Ahmedabad city from the epicenter was more than 250 kilometers. Many people talked about various problems including liquefaction, but it was site effect which was the major cause for failure. So we did not have too many earthquake data during that time. Now you have sensors everywhere. We could collect only the data from the passport office in Ahmedabad city. We tried to analyze the frequency content. Mostly predominant frequency was in the range of 1 to 3 hertz. Soil in Ahmedabad city was definitely not causing liquefaction because it was not saturated. The SPT N value was less. Overburden was about 10 to 15 meters, but water content during earthquake was not to the saturation level. Therefore, it was not liquefaction, and we were able to show that the frequency contents of the ground and of the buildings between 4 to 10 stories and the natural and the frequency content of earthquake, all of them were close to 3 hertz, causing resonance-like phenomena. And we did the site response analysis, and we found that the level of amplification at the ground level was close to 20 times. Whatever shaking happened at the bottom, it was amplified by 19 times. And this amplification and resonance-like phenomena was the major cause for failure. Like this, we have many situations, many instances in which the earthquakes have happened. This was in Christ Church. After many earthquakes, different places, not very far, maybe about 5 to 10 kilometers, we can see the level of acceleration changes. 1.62 G somewhere and 0.13 G somewhere. So in a distance of about 4 to 5 kilometers. So site effect is something which we have to take into account. IS 1893-2016 has advocated that we need to consider. So when do you consider? It all depends on the importance of the structure. It also depends upon in which seismic zone you are constructing that. And if that is the case, it is not just enough to follow whatever is the zonation guideline which the IS says you need to analyze by some technique. So site effect is important. So site effect is the influence of the overburdened soil in changing the shape of the ground motion, amplitude, frequency and duration of the earthquake motion. Many a times it amplifies. Many a times resonance like phenomena will happen. Okay. I close here because I know I'm occupying my good friend's lecture time. So there are many, analysis methods. There are several softwares which you can use. One-dimensional analysis, two-three-dimensional analysis can be thought about. But I always believe in being simple. There is no need to think about very complicated analysis. So even one-dimensional analysis can many a times give reasonably good solution to us. And I just try to mention, in general in geotechnical engineering, biggest problem is to get accurate input data. So if you have very good analysis method and very poor input data, it doesn't help us at all. So we need to balance between the two. Therefore, it is not necessary that we go for a rigorous analysis. It is more important to collect the data as accurately as possible. So I just close here and would like to mention that 1893-2002, there was no mention about side effect. But the next book and the recent one, 2025 one, also talked rigorously about side effect. And 2002, it said, there is no resonance like effect at all. But in 2002, 2016, it was mentioned that, but there are exceptions where resonance-like conditions have been seen to occur between long-distance waves and tall structures founded on deep soft soils. So that's what is added, and that has been improved in the recent code which has been taken back. So I discussed about several case studies, and I just would like to conclude mentioning that failure of geotechnical structures during earthquakes can be catastrophic. Knowledge of earthquake geotechnical engineering is essential in seismic analysis of structures. It is extremely important to consider site effect and hence, amplification in the ground motion, and understand what is the force, which design force at the ground surface, and depending on that, you can design the superstructure. Simplified 1D analysis using wave propagation theory in frequency domain is reasonable enough. You don't need to apply very sophisticated ones. So with that, permit me to thank you, and thanks to Professor Centenary and his team for all the excellent work. Thank you all.
Any questions?
Yeah. Any question? Yeah. About liquefaction, my friend covered about different mitigation measures. Here, you have to check what is the natural frequency of the ground and the structure. And it should not be very close to the earthquake frequency. Earthquake generally is between 0.5 and 2 hertz. So what happens is, some structures which are masonry, which may have frequency less than 0.5 hertz, they may survive. On the other hand, that's what I showed. 4 to 10 story buildings, RCC buildings, only failed. All of them were built, just 10 years back. They failed because, they vibrated almost at the same frequency as the ground vibration. So you have to check for resonance effect, and you have to find out what is the expected force at the ground level and design the structure for that. And other treatments can be, if the soil is soft, you can think about ground improving, and sometimes you can even take going for deep foundation, take them into bedrock or stronger soil. But if it is an important structure, in a seismically active zone. It is not enough if you just follow 18 degrees zonation and do the analysis. Site characterization has to be made. Yes, sir. Thank you.
Sir, thank you, Professor Prasad sir,
Thank
for
you,
your
sir. Thank you.
excellent presentation.
Thank you very much.
Starting from basics of earthquake engineering, sir has explained right how the ground motion gets amplified from its point of origin. So I advise those who are interested in earthquake engineering to get a copy of Geotechnical Earthquake Engineering written by L.S. Kramer. Okay, so coming to mitigation methods, so if you need to thoroughly investigate soil, if at all any liquefiable soil is there, you have to take some ground improvement techniques or do grouting to poisonous soil if it is thin layer. Ensure that it does not get liquefied. And as the SAR advised, prefer deep foundations compared to shallow foundations. And one more thing is in superstructure, you have to design your structure as ductile as possible. Right?
Very, very good.
So that is the basic thing to be followed in structural designs. Right? You have what is known as ductile detailing. That should be perfectly executed. Though design may be done, but while executing ductile detailing is not properly followed, there won't be any benefit of it. So thank you very much, sir.
Thank you, sir. Thank you.
For traveling from Mysore. Sir worked as professor and head at popular known as SJCE, Mysore, and he is known for his work in earthquake engineering, liquefaction analysis, and his guide is a popular professor. I think Professor Tawhata. Right, so thank you very much, sir. We enjoyed your stay here for.
Definitely, I enjoyed all the hospitality, sir. Thank you very much.
So majority of EC members, in particular, right, Prasad sir, Ramesh sir, Murali Krishna, Madhuri Lata, Anil Joseph, right? So all are very supportive and friendly. That is the reason why we are organizing good events on regular basis. So thank you very much, sir.
Thank you, and I request you to continue all these good habits, good practices, so that IGS Visakhapatnam chapter be the best chapter in terms of quality activities. Please continue that. And maybe very soon we should have IGC along with it.
Yeah, thank you very much, sir. We look forward to host IGC.
Sure.
Coming 2-3 years. Thank you, sir, for your nice words. We will come to the last.
Small question, sir.
Yeah. Yes, sir.
Here in railways we are getting the speed higher from 160 to 320 kilometers like that. Any special care to be taken in foundation?
Perhaps yes.
Yes.
Perhaps yes. We have now
Bullet
the
trains.
vehicles or the trains, traveling. Bullet train, you have no problem because they are building mainly above ground. And also new track. But the track on which you have this Vande Bharat train goes, it has to be verified. And I heard, in a place like Patna, there have been some failures, and they have kept it confidential. But it could be due to the resonance-like phenomena. Some masonry structures have developed some cracks. You are very true, sir. So any vibration, it is very different from static loading. So it has different kinds of effects. We have to verify for all those effects. Sir, thank you. Thank you very much, sir. Thank you, sir. Thank you all. You have been a wonderful audience. mobile number. I will share. And you know, please go to my mobile number. I'll share it in a day or mine is 94496.
This was a great lecture by S.K. Prasad sir.
Oh, thank you, thank you.
The next lecture will be by Dr. H.N. Ramesh sir on forensic analysis. Dr. H.N. Ramesh sir worked as Principal and Professor of Civil Engineering at University Visvesvaraya College of Engineering, formerly Dean of Engineering for 2 years from 2015 to 2017 and formerly Vice Chancellor, Director, PFED of Bangalore University. He completed BE from GBTD College of Engineering in first class with distinction in the year 1984. Obtained PhD from IIC Bangalore in the year 1994 in Geotechnical Engineering. He started his career as a lecturer in Civil Engineering at STJIT in the year 1984. He served as Geotechnical Consultant with Sequence Surveys Bangalore during 1994 to 1995 and as a Senior Geotechnical Engineer in Tata Consulting Engineers during 1995 to 1996. He joined University Visvesvaraya College of Engineering as a reader in Soil Mechanics and Foundation Engineering in 1996 and was promoted as Professor of Civil Engineering in February 2004. He was the Chairman of the Department of Civil Engineering, UVCE, during 2010 to 2012. Professor Ramesh sir so far supervised 10 PhD students, more than 50 ME students and 1 MSc student by research. He published over 125 research articles in national, international conferences, journals. His publications received Best Research Papers Award at national level in 1997, 2008 and 2012. He presented his technical papers in international conferences at Singapore and Dallas, USA in 2003 and 2011 respectively. He has presented papers and chaired sessions in many national and international conferences held in India. He also delivered invited and keynote lectures in several national conferences. He served as the Chairman of BOE for undergraduate and postgraduate programs in civil engineering of UVCE many times and also as a BOS member of several times and BOS Chairman for 2 years. He has also honor of serving as a BOS member of VTU. Professor Ramesh sir is actively involved in teaching, research and consulting related to civil engineering. He has handled an AICTE funded research project and more than 100 consultancy projects in area of geotechnical engineering. He was the member of Executive Council of Indian Geotechnical Survey 7 times. He served as General Secretary of Karnataka Geotechnical Center KGC during 1998 to 2008 and as the Vice Chairman of KGC during 2008 to 2013, now working as a Chairman of IGS Chapter Bangalore. He is a member of the expert committees of AICTE, UGC and UPSC at present and served as a member of Executive Council of VTU for a 3-year term, that is 2013 to 2016. I heartily welcome you, sir, Patla. We look forward for the future lecture.
Thank you, Ms. Rita. Good evening to everybody. Good evening. So, first of all, I congratulate Andhra University for celebrating 100th year, because we know the excitement we enjoy. Myself and Prasad are the graduates from Mysore University. Mysore University celebrated 100th year in 2016. And I am from UVC, I was a faculty and also principal. We celebrated 100th year in 2017. So UVC is the oldest engineering in the state of Karnataka, 5th oldest in the country. So we know the excitement, and the government will give the funds. Central government gave 100 crores to Mysore University. I think you will enjoy all those excitements. Yeah. And also I am very happy that the civil engineering department is celebrating 70th year. So I am very happy that, of course, I am a finisher today, no problem. Therefore I have selected the topic accordingly, so that you should have a good finishing this one. We have the practice of teaching students in the afternoon after lunch hour. The strength may be very less sometimes, and forcibly somebody will be sitting. But here I am having interest because you are not sitting forcibly with interest. You are sitting, so I am honored to share few of my experiences. I started my career after PhD as a geotech consultant. I have done a lot of consultancy work along with my guide, Professor Sridharan. One of the important projects I was discussing with somebody yesterday was a defense project in Balesur, Andhra, in Bhubaneswar, Prithvi missile project. So I was the consultant along with Professor Sridharan in the Wheeler Island. We used to go daily. I used to go daily 11 kilometers in the boat, and lot of crocodiles were there. And it's a Wheeler Island, and Abdul Kalam was the head of that. And I used to present the borewell data in the transparency. Sridharan used to come and he allowed me to present, and it was an exciting experience. After that, also I was in TCE. Then I joined UVC as an academician, and of course after joining UVC, I continued my consultancy, but due to some administrative work and all, people used to give me only the critical consultancy works. For example, during the fag end of my career, one apartment was being constructed. They have gone up to 2 basement depth. The adjacent structures were damaged. I returned in March. I got the offer from High Court of Karnataka. Justice Goendraju called me through the government advocate to take up the project, to do the forensic analysis, reasons, etc. So it is fortunately or unfortunately, I was not called for the regular projects. Whenever there is a crisis, I used to be called, because I worked in the beginning of my career. I used to enjoy that. And when I joined UVC also, there was a the adjacent building, there was a site, the layout was there, and in between there was an empty site. When Marwadi has constructed that, they have dig the borehole. I was talking about 1997. See, borehole in the northeast center, the corner, they went for the borehole. It was in the midnight, around 10 o'clock or so, 11 o'clock. The borewell went up to 6 meters. The adjacent structure, the 14-story building was started shaking. Then police commissioner was from northeastern states, his famous name, I don't know who is that, northeastern police commissioner. He was a very strict officer. He came and asked the owner, there was a screaming and the building was shaking like that, like this. The civil engineering, basics of civil engineering. If the sigma h equals 0, sigma v equals 0, sigma m equals 0, one of the conditions is not satisfied, it's a failure. It was shaking, it was moving. So the police police commissioner asked the authorities to demolish the building, and the contractor came to me and asked what you have to do. Then I came to know that the contractor has not taken the permission from the authorities, corporation authorities, and also the soil test was not done. And also when I was the head of the Department of Civil Engineering in 2010 and 12, there was a 5-story building which was constructed in one place, wherein adjacent buildings they are constructed, and this building only the loose soils they are filled up, and then when that fellow, the contractor, has not gone for the soil investigation, he has taken the soil investigation of the adjacent buildings, it was same, and he came to know that he thought that it is the same for this also. He used the same soil investigation data. Structural engineer has designed the building, and when the building went up to five floors, again it was start shaking, and then it was demolished. Why I am telling this is I am going to show a few case histories, very interesting case histories. Those are the case histories I really enjoyed. Whenever there was a crisis, I used to be called, and of course I was not charging much for the consultancy, and that is one of the things people are not very much attracted towards me. But I was one of the first geotechnical consultant to carry out the block vibration test, the boreholes at early ages. In 1993, at my young age, I conducted and I got thorough fundamentals about all the soil samplings, the testing, and also I have done my PhD on the experimental. So I have done a lot of experimental work, and that helped me to go ahead with the consultancy work. Today, I am going to show you few of the case histories, and I was very much curious to know, by seeing the press reports, the Bangalore Mahanagara Palike has shortlisted 600 buildings are in distress. And during the rainy season, there was a failure of the buildings. Then I thought, we should have a survey of it and find out what is the reason. For any foundation failures, as youngsters, the students should know that the failure of the foundation or may be due to, number one, it is the mistake of the engineers. It is if they have not done the soil investigation, if they have not taken the permission from the local authorities, and if they have not taken care of the adjacent structures, and if they are not taken care of the slope, stability, etc. So these are the things, the very interesting thing, and we have collected the data of about 50 to 60 buildings. Most of the buildings are due to these factors. I am going to present very few case histories based on that, and first I am going to show you what is the cause of the failure and what is the forensic analysis. I would like to tell you, for the youngsters, forensic analysis. See, Professor Madhav used to tell always, there is a relationship between human beings and the soil. If the soil is not well, if the human beings are not well, we go to the doctors. If the soil is not well, the consultant, that the doctors, will go and treat them. And if the accident takes place, if any human being is killed, the body will not be given to the relatives. Post-mortem study, the forensic analysis will do for the cause of the death, etc. Then the body is handled. If the civil engineering structures fail due to foundation failure, it is a crime. It is not an accident. It is the failure. Failure is not an accident. For example, I would like to tell you, our researchers have given the classical geotechnical failures. They have done lot of research. You can predict based on the load, the vibration, etc., how the soil will fail. Based on that, you can design. forensic engineering is the youngest branch of civil engineering, wherein a designer, the soil scientist, in addition to that, a forensic engineer will predict the failure of the soil, failure of the structure, and then will ensure the safety of the structure. So, I am going to present the youngest branch and very interesting case histories, but you will feel bad because these failures should have been avoided if the civil engineers are very, very careful and alert. See, I have already told you Bangalore has witnessed many building collapses, and you can see the second point. Common reasons for foundation failures are inadequate soil protection, improper geotechnical investigations, water level fluctuations, design errors, and improper construction practices. And the lack of awareness about the importance of soil investigation has led to a large number of building failures. See, the geotechnical investigation means Mother Earth is very confidential, highly confidential. If you stand on the ground, you don't know what is the type of soil below the ground level. If you take soil in hand, it will be having the the clay, sand, silt, etc. Clay, if it is less than 0.002 mm, it is clay. 0.002 mm to 75 micron is sand. Sorry, silt. If more than that, it is sand. Even sand is called as the cohesion of soil. Before coming to understanding the soil mechanics portions, you are thinking that sand is different, soil is different, etc. It is also a soil, is a cohesion of soil. And lack of awareness. The Mother Earth is highly confidential. We don't know what is the type of soil below the ground level. You have to investigate. You have to see what is the type of soil. The importance of soil investigation is to know the physical properties of the soil, and you should understand the engineering properties. That is the strength, compressibility, and the permeability. Strength should be more, permeability should be less, compressibility should be less. So if you attain these conditions, if you satisfy this condition, then you will be through with the the good foundation things. Therefore, soil investigation is very, very important for any civil, the construction of any civil engineering structure. And foundation failure is critical, because even if a building has not failed, building is not failed, the building may not be failed due to the structural design, but it may fail due to foundation, it is due to this redistribution of the loads acting in a way it was not designed, and thus affects the stability of the whole structure. Rapid urbanization, the mass influx of people, and the resultant increase in demand for land contributed to the encroachment of lakes. So this is one of the main reasons in Bangalore. Many lakes are encroached, and most part of the city now has been constructed on sites that were lakes at some point. See, in the recent survey, I already told you, BBMP, more than 600 such poor buildings have been found across the 8 zones in Bangalore. Apart from that, most buildings in Bangalore are not being built professionally. Most importantly, soil investigation is not being done before building construction in common. Soil investigation, they are not done. Without the soil investigation, if anybody goes for the civil engineering construction, either the building will fail or it will be uneconomical. So there is a mindset in the owner's mind that masonry can construct the building at lower cost, but masonry may use more material that they don't think of. So if you are not doing the soil investigation, either the building is uneconomical or it is unsafe. So therefore, we have to make use of the advantages of the soil investigation or the geotechnical report is we have to make use of the recent technology, obtain surface and subsurface explorations, have complete data about the construction site, establish parameters of the foundation, cost-effective service, that is economical foundation, economical structures, and then prepares proper site investigation reports, best soil treatment. So if the soil is not good, you can always treat the soil and increase the strength, decrease the permeability, and decrease the settlement. Then collapsed buildings. I have selected few buildings in Bangalore, conducting a survey on media reports. By seeing the media reports, I just noted down which are the areas and the buildings which have failed. site visits are done to carry out the forensic observations, that is with the cause of the failure and what is the reasons, etc. And to find the details of the collapsed buildings, the nature of the building collapse and causes of the failure. These are the things we have done. And I will take the first case history quickly. Two buildings at Kamla Nagar. It was collapsed on October 13, 2021 according to the press report. We went there and we found that the building was constructed side by side 15 by 40 feet plot. One building was G+3 and other one is G+1. Building was constructed on elevated plane with respect to the plot behind it. You can see here review of two buildings. The causes of the failure, you can see the foundation of the building was in the elevated plane above the empty side behind gate with inadequate support. When it was raining heavily, the soil under the foundation started to wash out towards the empty side. Then the ground floor sank following the foundation fitting. That is the causes. Then forensic observation. When we do the detailed analysis, a building in the plot behind was demolished recently. The building was demolished recently, and both the buildings had common walls. Both the buildings have common walls. After the demolition of the building behind, this building lost lateral support for the foundation at the back. Due to heavy rainfall, the soil under the foundation washed away. And then as soon as the building was demolished behind the plot, the soil slope should have been given the necessary support to hold back the foundation. This is one of the forensic observation. And the building at Hebbal, it was collapsed on February 5, 2020. And again, the causes of the failure, you can see the building was built with 5 floors without the approval of BBMP. It was identified that the owner of the adjacent plot carried out deep excavation. Adjacent building deep excavation. He has gone, the excavation is gone below the foundation, the soil will flow. The foundation pillar of the collapsed building was damaged during the excavation and caused the tilting of the building. See, whenever you don't take the permission of BBMP, what they will do? They will demolish that portion, particular portion, to extend that. So as a result, what will happen is, it is observed that the building was not constructed according to the building bylaws. The JCB operator, what he did was, while excavating the adjacent plot, had damaged parts of the foundation column of the building, causing the weakening of the structure. He is not a civil engineer. That small damage made the building to collapse. And the forensic observation, one more observation was found as a sump in the adjacent plot developed cracks and water began to seep into the foundation. And the weakened soil and damaged foundation pillar together has caused the failure. So this is one of the reasons why we have to take the authorities permission, and you have to construct the building according to the bylaw. If you don't construct the building according to the bylaw, they may come with the court notice at any point of time, and then the JCB fellows may create problems, and then the whole building will collapse. So be aware of it. This is the second point. Then building at Purnachala layout, it was collapsed during October 2021. So it's a 6-year-old building, G+3-story building, and 10 by 20 square feet. And plot was tilted after a heavy downpour in Bangalore in October 2021. You can see the causes of the failure: insufficient foundation. It's a very small site, 10 by 20, and poor structural design. Sometimes structural design also will cause differential settlement and other things. Constructed by violating building bylaws, 2 violations. Second one. And the building was built next to the stormwater drain. Third one. Stormwater drain runs deeper than the foundation of the building. See, these are the factors are very important. Then if you can see here the building tilted backward following the rain in the city. Cracks were developed in the staircase, walls and concrete flooring in front of the building. The forensic observation was, it was observed that the building site is very small and right next to the stormwater drain. Here the foundation area was equal to or smaller than the built-up area of the other house. So this is obvious. Then next one is 5-story building collapsed in Kasturi Nagar. This is a resident sunshine apartment in Kasturi Nagar near the Vanaswadi area. It was collapsed on October 7, 2020. See, it's almost on the same dates the buildings were collapsed. And the structure was built on 60/40 site, and plan was approved, of course, approved by BBMP, and the building said to be 8 years old. The structure consists of ground and 3 floors. And of course there are no casualties. See, causes you can see the main reason found to be the size of the concrete column. It is again the structural one. Setbacks of the buildings are not met up to the limits of the building bylaws. They are not followed the building bylaws. The plan was approved by BBMP officials, but to build ground at 2 floors, but they have gone for the extra floors. Then forensic observation was, interconnected rigidity is absent. Because of that, whole load transfer to the single support due to the size of the footing. That is the eccentricity. Due to eccentricity it failed because they have not taken the help of the proper structural engineer. Unequal load distribution causes differential settlement. Geotechnical failure is also there. So it will affect differential settlement. Then due to some poor construction practices and during excavation. Then forensic observation continued. It is an illegal penthouse construction work carried out after 2-3 years of building completion. For the certain equipment used, they found cracks due to rotation. So these are some of the forensic observations. So this is one of the important see in the Majestic area in Bangalore, those who know Majestic, there was a Kapali theatre, film theatre. It's a very famous theatre, the oldest theatre. Huh?
It's owned by Rajesh.
Yeah. It was a very old theatre. Actually, you can see first in the slide. Kapali Theatre. The building was located adjacent to Kapali Theatre, and the building has ground and 3 floors with the flow of flat gates, guest house, and recreation club. So this forensic analysis work was carried out by our friends Jay Shukla and Ravikar Vaidya. forensic approach, the soil investigation was carried out by digging 3 open pits and conducting 5 static open pits. But architects have given some suggestions, they have violated. Forensic approach also says same thing. And see, all these failures occurs due to the errors committed by the engineers. As civil engineers, we always think that structural design is very important. The architectural plan is important. We agree with you. See, during my career as a professor, I used to invite invited by the APSC, Andhra Public Service Commission, also once UPSC for the interviews. I used to ask the question to the civil engineers. You are a full civil engineer, you are a PE civil or a tech civil. If you are given a site of 30-40 sites, okay, what is the 2 important things you want to ask as an engineer? You used to tell about the structural design, that, this. But, my dear students, youngsters, you should know that as civil engineers, when you are given a task of any size, it may be a dam site, it may be a residential building, it is a railway track, it is a road, etc., etc. 2 important things you should always bear in mind. Number 1, survey of that area. Survey will give a lot of details so that you can plan it. Once you plan that, conduct the survey and then plan it properly. Number 2, geotechnical investigation. You should know what is the type of soil below the ground level, what is the strength of the soil composability, what is the remedial measures, etc. These are the 2 aspects you should always remember. And whatever the case histories I have demonstrated today, it clearly indicates that if those engineers have taken care of these 2 aspects, these failures would have been avoided. I think all of you agree with me with the following conclusions. Number 1, the foundation fails due to soil movement from underneath the foundation to the open space behind the plot. So to protect the building in such cases, the slope behind any foundation must be given proper support by retaining walls. Once you construct the building, the soil should not move below the foundation. It should be intact. If it is moving, it's a failure. That's the first conclusion. Second one, while excavating the site, care should be taken not to disturb the foundation of the adjacent plots. You should not disturb the adjacent plots. When you are excavating, care should be taken below the ground level, and the foundation column should have prescribed setback behind the site boundary. Setback bylaws should be followed. Third one, it is recommended to follow all the bylaws while constructing a building in a city. It will definitely help you. Then fourth one, the regulations which are represented in the National Building Code 2016 to prohibit the modification of balconies and other bylaws should be followed during the planning and construction, and it must be verified by the agencies like BBMP officers before commencing the project, and you should follow during construction also. Bylaws you have to follow. Then next one. Next one, to reduce the vibration effects on building, as Prasad and Murali Krishna have demonstrated, especially when the water table is there and then sand is there, liquefaction takes place. Even not even the earthquake. If there is a machine foundation is there, liquefaction takes place. What is liquefaction? If the total effective pressure is equal to 0 in the dynamic condition, sigma dash is equal to sigma minus u. Sigma is the total pressure, u is the pore pressure. When the vibration takes place, especially in the sandy soil, liquefaction occurs. Liquefaction means it flow like water. With the below the foundation, the soil flow like water, then foundation fails. Therefore, to reduce the vibration effects on buildings, an isolation system should have been adopted like active or passive isolators, which helps against the structural vibration caused by the construction project. Before the start of any civil engineering project, it may be a residential building, dam, road, railways, anything, airport, etc., people should aware about the land history, formation of soil, and a detailed information about water bodies near the site are to be known. If any water body is present near the site or previously on site, there should be a detailed geotechnical investigation required. Geotechnical investigation is a must. Then minor potential sinkhole formations and control on dewatering and lower the groundwater level is also very important. These factors should be considered for the construction aspects accordingly. For load transfer failure, one of the commonly adopted remedial measures is underpinning process, which helps to strengthen and stabilizing the foundation of an existing building. If site comes under filled up soil, you should be very, very careful, especially when the layout is full of buildings and one vacant site is there, all dumped materials will be there. Then you have to be very careful about the filled up soil of the locality, and there should be adoption of piles for foundation of buildings until the pile reaches the hard slab. Okay, these are the very important. Finally, one line conclusion, my dear friends. Take the BBMP approach as civil engineers. Please see that two important factors are to be fulfilled before taking up any project. One is the survey work, next one is the geotechnical report. In general, geotechnical investigation is very, very important. I appreciate Dr. Centenary Reddy because I am in touch with him always. We used to talk. See, he is concentrating also in addition to the academics on the giving suggestions to the engineers. He is doing lot of consultancy work. He is having thorough fundamental knowledge of the geotechnical engineering. I think all the students of this college are really blessed, and PVV Satyanarayana also doing excellent work in the geotechnical engineering. And I congratulate both of you. And Professor Rajgopal, who was in IIT Madras, he is our mentor to many of us, and from Madhavi Lata, he guided and really, AU College of Engineering, I am envying, and also we are really blessed with a lot of technical inputs from the faculty members, and students are very lucky. And I once again congratulate all of you for celebrating your 100th year. And particularly Civil Engineering Department is celebrating 70th year, and hopefully you do very well and continue to do your good work, and wish you all the best. Thank you.
Professor Chenab for your lecture on forensic investigation into failure of buildings located in Bangalore. So always the purpose of forensic investigation is to identify the root cause of the failure, and if any scope is there for retrofitting and the rehabilitation, that will be done. If not, the information which you generate through forensic investigation will serve as guideline for future constructions in that area. So thank you very much for sir, for choosing this topic and highlighting the importance of forensic studies to better understand the reasons for failure of structures in varying ground conditions.
Thank you, sir, because I want to finish it, therefore I want to finish. will sleep.
So you have played real T20 innings, sir. Thank you very much. So on behalf of the Department of Civil Engineering, I thank you very much, sir, for your nice encouraging words and for your wishes on the occasion of Centenary celebrations of the university. So we feel it a privilege to have all of you here on the campus during this important Centenary year. So we are very much delighted and look forward to see you again on the campus before this year ends. Our Centenary celebrations will continue after April 26th also, as Vice Chancellor said yesterday. So look forward to host some big event probably in the month of October, because I am given the responsibility of soil testing forum. So maybe addressing that, we will host one big workshop or seminar, and we would like to invite some of you for that. So thank you all. So I think all of you are tired. So have a tea break, snacks and tea is available. Have it and come back in 10 minutes so that we'll have the final session, valedictory session, which is important. So bring your other friends and colleagues. Right? So it will start in 10 minutes from now. Thank you all. Before that, I would like to present the request Professor
పెన్ ఉందా అక్కడ వైట్
Good evening. On this pleasant evening, I welcome you all to the valedictory session of the workshop on geotechnical solutions for infrastructure projects in problematic ground, organized as part of Centenary celebrations of Andhra University by the Department of Civil Engineering, College of Engineering, Andhra University, in association with Indian Geotechnical Society Visakhapatnam chapter. On this occasion, I first invite the coordinator, Professor K. Rajgopal sir, onto the dais. I now welcome the convener of the workshop, Professor C.N.B. Satyanarayana Reddy Garu, Head of the Department and Chairman, IGS Visakhapatnam chapter, onto the dais. I invite Professor A. Murali Krishna from IIT Tirupati onto the dais. I invite Professor S.K. Prasad Garu, former Professor SJCE, Mysore. I invite Professor K.N. Ramesh Garu, H.N. Ramesh Garu, former Principal, UBCE, Bangalore, onto the dais. Kindly take the chair, sir. So now we have the remarks by coordinator and convener.
Shivana, Lego. Shivana.
Very good evening to all of you. It's a pleasure meeting all your friends. Of course, the colleagues and the profession. These are such occasions, and I'm also very happy that we are celebrating this during the centennial year. President Rajshekar Garu is so fond of these activities and gives us an extra push to organize these. And actually it's a good idea, especially for the students, because what I notice with the students, at least in Andhra University, their expectation levels are very, very low. Maybe because they are not exposed to what's going on around. And especially yesterday, we had a talk by Dr. Ravi Kiran. I've known him for more than 20 years. And in these 20 years, he has changed a lot. And the type of tests that he is doing, they are fantastic. Even for me, it was a learning experience, and I'm sure the students also have enjoyed it. And I keep on telling the students that what we teach will become outdated even before you graduate, because we teach from textbooks, and none of the textbooks will have anything about artificial intelligence or modern methods for survey. Like for example, nowadays everything is done through GPS, drones, and other things. And these are some occasions when we meet and then learn some latest techniques. And especially I'm very happy that we had our own IGS president, Dr. Anil Joseph. He has has so much experience. He's basically a structural engineer, but he has done so much geotechnical work. And so we are all very fortunate that he could join. Then Professor B.S. Rajagaru, he was my teacher and also my colleague. And I have known him for more than 40 years. And just talking to such people is very invigorating. And so it is, I'm sure the students, these are meant for students, not only for Andhra University, but even for other engineering college students. And the students are like our inspirations. So the teachers, we get inspired when the students ask questions. If the students ask questions, then we go back, read and then come back fresh. And so it is that context, the students are as much part of learning process as the teachers. So I hope our own students, you have all got exposed to the trends in geotechnical engineering, and you will carry these memories. And hope we will also talk to some industry people. So with this, I want to thank all my friends, Professor Chenab, and then Professor and then Murali Krishna. He is like my grad student. He's my first grad student. So it is Madhavalata was one of my earliest PhD scholars, and then he is her first PhD student. So it is, I'm very happy. Every time I meet him, I get more energy. Of course, when we see the students, we get more energetic. So with this, I want to thank all of you, and I hope you have all enjoyed as much as we enjoyed organizing this. Thank you very much.
Before we have the closing remarks by our convener, I request the participants to give their feedback. First, from the faculty of different colleges.
Good evening, one and all. My guide, Professor C.N.V. Satyanarayan Reddy Garu, my co-guide, Dr. P.V. Satyanarayan Garu, and my external examiner. I felt very happy. In the brochure I have seen Professor H.N. Ramesh Garu. He was my external PhD external examiner. So immediately I decided I must go to Andhra University, and not only that, yesterday I saw one legend of civil engineering student who became legend of civil engineering in India, Professor V.S. Rajagaru. Similarly, today morning we have seen Professor M.R. Madhav Garu. So their names are on the boards of civil engineering department. First batch and second batch students of civil engineering. So their eminent lectures I had. And not only that, AICTE has united engineering colleges of our country. Similarly, IGS, Indian Geotechnical Society, has also united. In my view, IGS means not only Indian Geotechnical, Indian Genius Geotechnical Society. That is my view, because we got an opportunity to meet all executive members, to all executive council members, and not only that, recently up to 2026, our IGC member was AICT chairman, who was Professor T.G. Setaram Garu. So Andhra University has given me this opportunity to interact with greatest people. Even I have seen the first professor of our civil engineering soil mechanics department, Professor Bangareswar Sharma Garu, Professor K.V.S. Apparao Garu, C.V. Krishna Rao Garu, and others. I got an opportunity to interact with them. Finally, Professor Prasad sir, I like him very much. Murali Krishna Garu, Telugu Velugu ayana. అలాగే మా సార్ మాధవీలత గారు తెలుగు తేజాలు, తెలుగు వెలుగుల్ని విశ్వమంతా వ్యాపింపజేసిన ఎంఆర్ మాధవ్ గారు, అలాగే మన సార్ ఐఐటి ప్రొఫెసర్ సారు, వీళ్ళందరూ ఉన్నారు. అయితే నేను ఒక చిన్నది పద్యం అయితే ఆంధ్ర యూనివర్సిటీ మీకు చెప్పాలి. అలాగే మా తెలుగు భాష, యాక్చువల్లీ ఐ లైక్ Telugu language very much because only 2 languages in the world are ending with vowels. One is Italian language and second is my mother tongue Telugu. I feel proud that I was born in this particular area. I belong and I am also a student of Andhra University. మాతృభాష కన్నా మాధుర్యమే లేదు, తెలుగు భాష కన్నా తీపి లేదు, అమ్మ అనుట కన్నా అమృతమ్మ లేదయ్యా, తెలుసుకొనుమా తెలుగు నిలుపుకొనుమా. ఇది నేను తెలుగు భాషకి ఇచ్చే రెస్పెక్ట్. అలాగే విశ్వజనని ఆంధ్ర విశ్వ కళామ తల్లి, నిన్న చూసా, yesterday they have conducted global food fest. So now Andhra Vishwa Kala Parishad became Vishwa Kala Parishad, Vishwajanani. Vishwajanani velugugaka ధీర ధీర ధీరమై, విశ్వజనని వెలుగుగాక నింగినంత కాంతి అయి, విశ్వజనని వెలుగుగాక దివ్య భవ్య రూపమై, విశ్వజనని వెలుగుగాక శత వసంత శోభతో, 100 వసంతాల శోభతో ఆంధ్ర విశ్వకళా పరిషత్ వెలుగుతున్నది. అలాగే ఇంకొక చిన్న చెప్తాను. సుందర విశాఖ కైలాసగిరి కొండ కింద పరచుకున్నట్టి సంద్ర తీరములో వసిస్తూ పొద్దు పొద్దున విద్యా సుమసుగంధాలనిచ్చు ఆంధ్ర విశ్వ కళామ తల్లి కంజాతవల్లి. So it is the only government university, not in India I think, which is having sea view, hill view and land view. The only government university in India which is having sea view, land view and hill view is the most beautiful university, is Andhra University. I feel very happy. And not only that, Andhra University is celebrating 100 years. Now my age is 50 years. I think I am very happy and our department is 70. Thank you very much for the opportunity given to me. Thank you. I love this place and Visakhapatnam is my hometown. I used to walk along the footpaths of RK Beach when I was studying there. Thank you. Thank you.
Faculty from other colleges, anybody? Engineers?
Very good evening to all. The regents, the dais, and engineers and students of the dais. I am Lakshman Reddy, retired as executive engineer, 20 years of service, and now I am with Aditya University as professor of practice. So the lectures went very well and we gain knowledge. The students should participate in depth, as our Rajgopal sir said. So Centenary Reddy garu, I know him from 10 years and I used to work here in APWIDC. So what my humble request is, please conduct online and offline this workshops, because nowadays the time is costly and the journey is very cumbersome. So I am a SASC member and IGS member Kakinada.
Actually this event is being
Yes. Okay. So the people will know the knowledge from any corner. Dr. Madhavi Lata has given ICSA, we used to conduct monthly webinars, Kakinada chapter under the guidance of Badam Bala Sundarao Garu. So if you conduct WebEx offline and online also, there will be much participation and the knowledge will be spread over to ground root level. That is my view. So thank you very much, sir, under this 100 year celebration. Thank you very much.
Any other engineers or faculty members? Next scholars. Any scholar would like to speak? Students?
Tech students.
Sure.
Good evening to everybody. Dignitaries on the dais, dignitaries of the dais, participants, my dear students, ladies and gentlemen. I want to express my sincere gratitude on behalf of all the EC members. See, when we arrived here, we almost had a red carpet welcome. We didn't expect. We felt homely. Each and every EC member was invited and the arrangement was so meticulous. I am very much thankful to the leadership quality of Reddy Garu and his team. After that, hotel also, there was a rousing welcome. The food was good in the hotel. And then we were taken to the venue very nicely. The vehicles were arranged. We did not feel any pain at all. We did not feel anything. And the meeting was conducted very nicely. And as a change, usually in all the EC meetings, the workshops conducted, in that particular slots, EC members will be invited. But to save time, Reddy has meticulously arranged. First, he has arranged the President Anil Joseph's lecture. And after that, all EC members were busy. And one by one, they came and delivered the lecture. Today, and actually by seeing our flight timings, myself and Prasad, we have booked tickets tomorrow actually. So therefore, we were allotted at the end. Only also tomorrow. So all the three. See, everything, every minute details has been taken care of. And when we arrived here, and when we are taking dinner also on the first day, our Reddy is missing. Everything is okay, but he is not there. And then next day morning he arrived exactly at 8:45 and he took us. And I asked him, what is this? He told, no. I made all the arrangements and then I was doing all the work meticulously for the tomorrow's meeting. But he was in touch with our phone. So that is the kind of, we have seen a different type of arrangements here. And hats off to Professor Reddy. And also, last 2 days we learned that the IIT Professor Rajgopal, of course I was always knowing him, he has become almost the backbone of geotechnical engineering, and it has helped Reddy to concentrate on many activities. And he was telling, for past so many years he has done 50 activities. He has conducted IGC online. It is a record one, and he has done all the things on time, and it was meticulous. So it speaks about the true leadership. And on behalf of all the EC members, I congratulate you. You made excellent arrangements for our stay, meeting, and have utilized the services of all the EC members' expertise, and you have done a wonderful job. And one more piece of advice is, everybody, all students, the youngsters, join hands with Reddy Garu, make this Visakhapatnam IGS chapter the best chapter in the country. Because nowadays, civil engineering students, people are not joining. People are mistaken. Now that there are a lot of vacancy for the civil engineers, especially geotechnical engineers. Civil engineer, they can design water resources, etc. But geotechnical engineering is a science, but learning is an art. That's what the mother always says. So those who have joined MTech Geotechnical Engineering at Andhra University, I once again congratulate you. You have a bright future under the leadership of Reddy Garu, Rajgopal Garu, and PVV Centenary. Wish you all the best. Thank you.
Reshma and Sai Chandu to come on the dais. Now it's time for certificates distribution. I request the dignitaries on the dais to distribute the certificates. Please read out the names, Reshma.
Dr. E.V.R. Rao, Professor and HOD, Kalinka University.
Shivanna.
Dr. Manchupati.
శివన్న ఈ ఫ్రేమ్కి వచ్చి నాకు వాళ్ళు తిరుగుతారు అలా ఆ ఫేస్ నుండి
Dr. Manchikanti
అక్కడ ఉంటే నాకు ఈ ఫేస్ నాకు కూడా
Professor
వస్తుంది
Civil Engineering,
నాకు ఫ్రేమ్
GVPC. Mr. M. Venu, Assistant Professor, Shashi Institute of Technology and Engineering. Dr. Balla Satyanarayana, Associate Professor and HOD, Prakati Engineering College. Ms. S. Akila, Assistant Professor, Civil Engineering, GVP, CD, PGC. Ms. G. Shravani, Assistant Professor, Civil Engineering. Mr. K. Satya Ishwa, Assistant Professor, ANITS, Visakhapatnam. Dr. S. Ishwar Rao, Assistant Professor. Dr. K. Tulasi, Faculty, AU College of Engineering. Ms. P. Sridevi, Assistant Professor. Dr. L.B. Bulai, LB College of Engineering. Dr. P.N.T. Narasimha Rao, Professor and Dean, and its College of Engineering. Dr. G. Sirisha, Associate Professor and HOD, AU College of Women's. Ms. Sheikh Reshma Nazreen, Guest Faculty, AU College of Engineering for Women's. Professor G.V. Ramana, NIT Warangal. Dr. T. Usha Madhuri, Associate Professor, AU College of Engineering. Ms. I. Shiva Parvati, Ma'am, Professor, Civil Engineering, AU College of Engineering. Dr. K. Ishwar Rao, Executive Engineer, WRD, Government of AP. Sri S. Avinash, ISPRL. Sri Kona Harshavardhan, Project Manager, KLR Pile Foundation. Sri C.R. Balaji, Principal Engineer, Professor V.S. Raju Consultants, Hyderabad. Mr. T.V. Ramakrishna, Ram Consultancy. Ms. M. Nagalakshmi, Manager, Technical, Agarwal Infra Private Limited. Sri Kasa Aparavu, Executive Engineer, VMRDA, Visakhapatnam. Sri S. Satyanarayana, Executive Engineer, Civil, VPA. Ms. Ruhi Jumna, Quality Manager, Rishik Enterprises. Dr. AVV Chaudhary, Practicing Engineer. Dr. K. Srinivas Rao, Retired Senior Engineer, WRD Department, Government of AP. Mr. P.B. Vijay Raju, Simha Constructions. Sri M. Ramakrishna, Director, KDM Engineers. Sri N. Ramesh Kumar, Assistant Engineer, Civil, BPA. Ms. U. Sharada, Assistant Executive Engineer. Sri Chiranjeev Shankar, Principal Engineer. Ms. Nivedita Barik, Senior Manager, KDM Engineers. Sri Madhusudana Rao, Lead Civil Engineer. Sri M. Ratnakumar, Executive Engineer. Sri M. Ramchi, Assistant Engineer, VPA. Sri Jairam Das, Senior Engineer, VPA. Sri G. Ananda Murali, Assistant Engineer, VPA. Mr. J. Vijay Pratap, Junior Engineer, VPA. Ms. Tejaswi, Geotechnical Engineer, Standard. Sri V. Srinivas, Executive Engineer, VPA. Sri VBK Srinivas, Consultant Civil Engineer. Sri P. Shivaprasad, Assistant Engineer, VPA. Sri C.H. VSR Murthy, CEO, Hindustan Construction Chemicals. Sri Ramesh Shetty, Assistant General Manager, Geotechnical Fibers. Sri C.H. Apparavu, Deputy WRD Executive Engineer. Ms. K. Padmavati, Executive Engineer, North Zone GVMC. Ms. T. Prasanna, Executive Engineer, West Zone GVMC. Sri V. Lakshman Reddy, Professor of Practice, Aditya University. Sri V.K. Maurya, DGM, NTPC, Hyderabad. Sri Sizir Kranti Nayak, Manager, Metaframe.
Very good, very good.
Ms. A. Harika, Research Scholar, IIT Madras. Ms. A. Uma Maheshwari, Research Scholar, Andhra University. Mr. P. Rakesh, Research Scholar, NIT Raipur.
I request Professor B.N. Narasimha.
Mr. Hanumantu, Research Scholar, NIT Roorkela.
ఛార్జింగ్ తీస్తారా పెట్టాలి ఇక ఆగిపోతే అదే అనిపిస్తుంది వాళ్ళు చేతిస్తే వాళ్ళకి వచ్చేసి
Dr. K. Rajeshwara Rao, Executive Engineer, WRD, Government of AP.
Very nice, sir.
Mr. R. Sai Chandu, Research Scholar, Andhra University.
Mrs. Reshma Chandran T, Research Scholar, Andhra University.
Now I request our convener, Professor C.N.V. Satyanarayana Reddy Garu, to give his closing remarks.
Good evening to all of you. Distinguished dignitaries from the dais, Dr. Usha Madri and Professor Shobharati, engineers from engineering departments, consulting organizations, and dear student friends. So we have come to the end of our 2 days workshop on geotechnical solutions for infrastructure projects in problematic ground. So during these 2 days, we have arranged 14 lectures covering almost all problematic soils by eminent experts in the field of geotechnical engineering. So having those many experts for this workshop was possible because the National Executive Committee of Indian Geotechnical Society has agreed for holding its EC meeting here. So since they were coming, I thought of utilizing their expertise, and that is how this workshop was planned. And we could arrange for 14 lectures on various topics, right? So we have speakers, senior most speakers like Professor V.S. Raju, Professor M.R. Madhav. Then we have President of IGS, Dr. Anil Joseph. Then Dr. Madhvi Lata, Dr. H.N. Namil, Dr. Professor S.K. Prasad, Professor Murli Krishna, right? Yeah, Professor Tyagaraj. And then we had yesterday Professor Dr. Parthasarathi. He is known for his works in offshore structures and offshore geotechnical investigation. And then we had Professor Neelima Sachum from IIT Indore, and then Professor Samadhiya from IIT Roorkee. He was past president of IBS. Professor Rajgopal, former professor and head of IIT Madras and presently adjunct professor of Civil Engineering Department of AUCE. And I have also delivered a lecture, right? So in all 14 lectures were there, covering the topics of soft glass, liquefiable soils, then geotechnical engineering, right, regarding stability of structures subjected to earthquakes, and then you have been exposed to construction aspects of the Chenab bridge, right, highest railway bridge in the world. So that was founded, though it is founded on rock, right, the nature of rock prevailing there with fractures directed right towards the valley, posed serious problems and how they mitigated, right, it was beautifully covered. And Professor Rajgopal sir has explained about construction of stable embankments for the railway structure in and around Chenab bridge, and he highlighted the importance of drainage for stability of the embankments. And at the end, we had some failure studies presented by H.N. Ramesh, Professor H.N. Ramesh, and his forensic observations. So in all, I feel the workshop is complete in all aspects. We could get all 14 resource persons that were listed in the initial brochure. No changes were there. So I thank all the resource persons for sparing their valuable time and preparing quality PPTs to disseminate knowledge on the topic of workshop. So the Department of Civil Engineering, Andhra University and IDS Visakhapatnam chapter highly thank all the speakers for sparing their time, for traveling and coming to Visakhapatnam and delivering the lectures. So I would like to thank our Honorable Vice Chancellor Professor G.P. Rajshekhar. So he is from IIT Kharagpur. So he has seen some of our geotechnical events organized there. The moment he joined, he asked me, you organize one major event in association with IGS as part of Centenary celebrations, and based on Vice Chancellor's direction, I have requested our EC for holding one of the EC meetings here, and that too preferably before April, and all have obliged my request and agreed to come, and so I thank them a lot for supporting me and Andhra University in organizing this important workshop for the benefit of students and engineers from different parts of the country. This event is being live streamed. Even yesterday's and today's program is completely available on YouTube. So as per the suggestion of the participant Sri Lakshman Reddy garu. We will try to organize some events in online mode, some webinars we will organize. And when our major workshop is there, we will try to live telecast, right, the program, and our Vice Chancellor supports that very much. Whatever technical deliberation that happen here, his objective is it should reach to any corner of the country, to that matter world. If something is available on YouTube, anyone from any place can browse and view at any time. So certainly we will try to have coverage of the events and keep it available for viewing in YouTube. So I thank the engineers particularly for taking interest, because for the last 3 months regularly we have been organizing events. First event when Keller program was organized, excavation support systems, addressing deep excavations. Almost 60 engineers were there because it was one day event, and our PG students, scholars and teachers from other colleges were there, and almost all was full right from beginning to end. Next, last month we have organized a 2-day event on BIS code IS 18591 on reinforced soil, geotechnical reinforced soil structures. Even for that also, engineers in large number attended. This is the 3rd event, and that too March 31st. Some targets will be there. That is the reason why we missed the engineers from DGNB and MES. But still, I thank the other engineers, particularly Port Visakhapatnam Port Trust. Even if department organizes one more workshop next week also, Port Trust will make it a point that they will nominate at least 5 to 10 engineers. Whenever we organize any programs, without a VPT engineer, the event will not be happening. Right? So I thank Chief Engineer, Visakhapatnam Port Trust, and Chief Engineers of other departments for sanctioning on-duty leave to attend this workshop. So anyway, so we won't be troubling you in the near future. We will take some gap. Maybe in October, we will organize a big event highlighting the importance of the soil investigation, both the field and laboratory testing, and how a geotechnical report is to be prepared, right? So getting a very thick geotechnical investigation report with so many boreholes is not required. So if you give more number of boreholes and go to a private lab, without doing just they will fill in the pro forma and give you a beautiful report, but when an expert sees, right, structural engineer opens it and reads, he will be totally confused, and any knowledgeable geotechnical expert verifies that he will simply say that the report is useless. All basic properties, even classification will be wrong. I am sorry to say, NABL accredited laboratories don't go. In Visakhapatnam you have NABL accredited laboratories. So some of the reports I have posted to NABL saying that you have certified and they are doing business. They wrote some C, they wrote some phi. There is no depth of foundation, there is no size of footing. SBC is written. NABL accredited sample. So the reply I got from NABL is, sir, you give a written complaint, we will initiate action. That we cannot do, so be careful. If you go to any academic institution, at least you can question, and the person who has issued will be able to explain logically how he has arrived at the recommended bearing capacity or whatever pile capacity calculation. If you go and ask to NABL accredited lab, whatever they have given end result and whatever initial properties have been listed, they cannot do it. Right? I have verified it. So be careful. Only few quality labs are there. All others are not proper. Right? So be careful. Just like if you go to a doctor, you will do an inquiry 100 times. Which doctor is good? Is it not? You don't go just by looking at board qualifications. Sometimes qualification may not be proper. Right? So you have to take public opinion, and then only you go to a doctor, geotechnical doctor. We are all geotechnical doctors. Right? So now and then you should also check your geotechnical consultant also. Though you know answer, you put some questions. You will know who is genuine consultant and who is fake consultant. So one should be aware, because you are paying the amount in lakhs, major projects. If a proper advice is not given, all your money will just will be dumped into the soil. Right? Be careful. Anyway, to highlight on that, we'll come back with a program on the occasion of Tadrigi's birthday. So thank you very much for your patient hearing and staying back till late, 6 or 6:30. So, thank you all once again. I thank my department faculty members. Dr. P. Satyanarayana, he is Secretary of IGS chapter, and he is always supports me whatever I do. He is always with me, and that is the reason why I am able to do these many activities which are useful for the practicing engineers, researchers, and even our PG students. And our office bearers of IGS Vishakhapatnam chapter always say yes, whatever we say, they will always, they know that whatever we do is correct. So sometimes in a hurry I won't consult them also, but they will never question me, they understand and they are supporting. I thank all my office bearers of Vishakhapatnam chapter. And since they have given us freedom, certainly IGC 2020, though we could not organize in physical mode, definitely we will try in near future to host IGC 29 or 20th, 2029 or 2030. We will put our efforts. I request EC members to keep that point in mind right from today. 28th I will not put because Bangalore is in line, so we don't come in competition with you. 29 we will propose. If it gets materialized, okay, otherwise 2030. Vishakhapatnam should be. We will host it. Do you have any plan for Tirupati? Tirupati is still young. Vishakhapatnam is old chapter. So allow us to host IGC once. After that we may not have energy also. Myself and Professor P. Satyanarayana also will be retiring in 34, 35 during that period. Yeah, 29, 30 reserve for us. So thank you all. I would like to thank Dr. Usha Madhuri for her continuous support for all my activities, for inaugural or valedictory. She is always with me in spite of whatever works she has. And I need not search for any anchor to do that. So thank you, madam, and all you, and also Shiva Parvati will be also supporting me. She was involved in some other work, so she could not propose vote of thanks for today's program. So that's why I am doing both presidential remarks and vote of thanks. So I thank Registrar of Andhra University, Professor Rambabu, and Rector of the University, Professor P. King, and Principal of AU College of Engineering, Professor M. Shashi. She is the first woman Principal of AU College of Engineering. She said she will come for valedictory. Yesterday she was out of session, but the day after tomorrow we have a convocation, university convocation, trial run is going, and she was asked to be there. So that's how we missed her. Anyway, she was there yesterday with our EC members. So I thank all of you, right, for everything, right, for your support and giving us energy to organize right events of this kind, right, regularly from department. Right, in between we have also organized some events on BIS platform. We have ICI. Some events are pending. Hopefully, one event we will do before April 26th. One day means at least engineers can come, half day they can come, so that the event will run, right? So ICA one event we may organize. Unlike geotechnical, ICA getting people is somewhat difficult. IGC, that the bond is there, so easy to get, right? So anyway, so thank you all. We will conclude our program with the national anthem.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंधु गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्छल जलधि तरंगा तब शुभ नामे जागे तब शुभ आशीष मांगे
forgot to thank. I would like to thank my research scholars, present and past. Present Mr. Sai Chandu, Reshma, and past research scholars, Dr. Nagalakshmi and Dr. Tulasi, and other research scholars of the department. What are their names? Padmini and Divya Sureka, right, for their help, and I thank all our MTech students, both second year and first year, right, for sparing their time, though for first year's exams are scheduled. Actually, due to this workshop, their exams, 2 exams are postponed by Vice Chancellor. So in spite of that, examination fear will be there, but still they helped us by agreeing to pick up and taking care of it. So I thank right, all my students and scholars, right, for their much needed support. Right? So I wish them all the best. So thank you all. So let us have a photo and then the group photo. So all of you come forward.
మన బ్యాక్ వచ్చి లేదు ఒట్టు పర్లేదు బ్యాక్ రా
ప్లేస్ ఉంది కదా మీరు కూడా ఇలా సైడ్
అలా ఉంచు
బ్యాక్ మీరు ముందుకు రండి ప్లేస్ ఉంది సార్ సక్సెస్ఫుల్ ప్రోగ్రామ్ అయింది స్మైల్ ఇవ్వండి సార్ కొంచెం లేదు సార్ అది ఆర్టిఫిషియల్ అయిపోతుంది సార్
తీసుకోండి
ఓకే ఓకే రెడీ రెడీ
వైట్ చాలా ఉండదా
అవసరం లేదు వెయిట్ సార్ స్మైల్ చేయాలి అందరూ
సరే అండి నాకు వైట్ చాలా ఎక్కువ మంది
తీసుకోలేదు
సార్ సార్ వన్ సెకండ్ పర్లేదు పర్లేదు రెడీ సార్ వన్ మో ఓకేనా ఓకే సార్ డన్ అయ్యా అందరూ పట్టదు మిస్ అవ్వలేదు రైట్ కదా మనం మీరు హైదరాబాద్ సార్